Welcome to our Cloud Computing full course by Simplilearn. Imagine cloud engineers are among the hottest professionals in tech right now. As businesses continue moving online, the demand for cloud experts is skyrocketing. By 2025, this industry is set to grow even bigger, making cloud computing one of the most rewarding fields to dive into. Think about it. Amazing salaries, endless career growth, and the chance to shape the future of technology. Sounds exciting, right? But what exactly is cloud computing? Simply put, it's like having access to powerful services, storage, computing power, and networking. Over the internet, that is the cloud, this tech enables businesses to grow faster, be more efficient, and stay ahead in the digital game. In this course, we will cover everything you need to know in order to become a cloud pro. From understanding the basics of cloud computing to diving into must-know topics like cloud security, comparing AWS and Azure, and the steps to become a cloud engineer. We'll also share project ideas and the best certifications to boost your career. So let's get started. Before we begin, if you are interested in getting certified in cloud, check out Simplilearn's Cloud Architect Certification Program, build expertise in AWS, Microsoft Azure, and GCP with a Cloud Architect Certification course. Plus, we have included an exam voucher for any one Azure course, so you can get certified hassle-free. Gain access to official AWS authored self-learning content and master the ins and outs of cloud architectural principles. Learn how to design and deploy scalable services on various cloud platforms. So you can find the course link in the description box below and the pinned comments.
Imagine you're the owner of a small software development firm and you want to scale your business up. However, a small team size, the unpredictability of demand, and limited resources are roadblocks for this expansion. That's when you hear about cloud computing. But before investing money into it, you decide to draw up the differences between on-premise and cloud-based computing to make a better decision. When it comes to scalability, you pay more for an on-premise setup and get lesser options too. Once you've scaled up, it is difficult to scale down and often leads to heavy losses in terms of infrastructure and maintenance costs. Cloud computing, on the other hand, allows you to pay only for how much you use, with much easier and faster provisions for scaling up or down. Next, let's talk about server storage. On-premise systems need a lot of space for their servers, notwithstanding the power and maintenance hassles that come with them. On the other hand, cloud computing solutions are offered by cloud service providers who manage and maintain the servers, saving you both money and space. Then we have data security. On-premise systems offer less data security, thanks to a complicated combination of physical and traditional IT security measures, whereas cloud computing systems offer much better security and lets you avoid having to constantly monitor and manage security protocols. In the event that a data loss does occur, the chance for data recovery with on-premise setups are very small. In contrast, cloud computing systems have robust disaster recovery measures in place to ensure faster and easier data recovery. Finally, we have maintenance. On-premises systems also require additional teams for hardware and software maintenance, loading up the costs by a considerable degree. Cloud computing systems, on the other hand, are maintained by the cloud service providers, reducing your costs and resource allocation substantially. So now, thinking that cloud computing is a better option, you decide to take a closer look at what exactly cloud computing is. Cloud computing refers to the delivery of on-demand computing services over the internet on a pay-as-you-go basis. In simpler words, rather than managing files and services on a local storage device, you'll be doing the same over the internet in a cost-efficient manner. Cloud computing has two types of models: deployment model and service model. There are three types of deployment models: public, private, and hybrid cloud. Imagine you're traveling to work. You've got three options to choose from. 1. You have buses, which represent public clouds. In this case, the cloud infrastructure is available to the public over the internet. These are owned by cloud service providers. 2. Then you have the option of using your own car. This represents the private cloud. With the private cloud, the cloud infrastructure is exclusively operated by a single organization. This can be managed by the organization or a third party. And finally, you have the option to hail a cab. This represents the hybrid cloud. A hybrid cloud is a combination of the functionalities of both public and private clouds. Next, let's have a look at the service models. There are three major service models available: IaaS, PaaS, and SaaS. Compared to on-premise models, where you'll need to manage and maintain every component, including applications, data, virtualization, and middleware, cloud computing service models are hassle-free. IaaS refers to infrastructure as a service. It is a cloud service model where users get access to basic computing infrastructure. They are commonly used by IT administrators. If your organization requires resources like storage or virtual machines, IaaS is the model for you. You only have to manage the data, runtime, middleware, applications, and the OS, while the rest is handled by the cloud providers. Next, we have PaaS. PaaS, or Platform as a Service, provides cloud platforms and runtime environments for developing, testing, and managing applications. This service model enables users to deploy applications without the need to acquire, manage, and maintain the related architecture. If your organization is in need of a platform for creating software applications, PaaS is the model for you. PaaS only requires you to handle the applications and the data. The rest of the components like runtime, middleware, operating systems, servers, storage, and others are handled by the cloud service providers. And finally, we have SaaS. SaaS, or Software as a Service, involves cloud services for hosting and managing your software applications. Software and hardware requirements are satisfied by the vendors, so you don't have to manage any of those aspects of the solution. If you'd rather not worry about the hassles of owning any IT equipment, the SaaS model would be the one to go with. With SaaS, the cloud service provider handles all components of the solution required by the organization. Time for a quiz now. In which of the following deployment models are you, as the business, responsible for the application, data, and operating system? 1. IaaS. 2. PaaS. 3. SaaS. 4. IaaS and PaaS. Let us know your answer in the comment section below for a chance to win an Amazon voucher. Meet Rob. He runs an online shopping portal. The portal started with a modest number of users, but has recently been seeing a surge in the number of visitors. On Black Friday and other holidays, the portal saw so many visitors that the servers were unable to handle the traffic and crashed. Is there a way to improve performance without having to invest in a new server? Wondered Rob. A way to upscale or downscale capacity, depending on the number of users visiting the website at any given point? Well, there is. Amazon Web Services, one of the leaders in the cloud computing market. Before we see how AWS can solve Rob's problem, let's have a look at how AWS reached the position it is at now. AWS was first introduced in 2002 as a means to provide tools and services to developers to incorporate features of Amazon.com to their website. In 2006, its first cloud services offering was introduced. In 2016, AWS surpassed its $10 billion revenue target. And now, AWS offers more than 100 cloud services that span a wide range of domains. Thanks to this, the AWS Cloud Service Platform is now used by more than 45% of the global market. Now, let's talk about what is AWS. AWS, or Amazon Web Service, is a secure cloud computing platform that provides computing power, database, networking, content storage, and much more. The platform also works with a pay-as-you-go pricing model, which means you only pay for how much of the services offered by AWS you use. Some of the other advantages of AWS are security. AWS provides a secure and durable platform that offers end-to-end privacy and security. Experience. You can benefit from the infrastructure management practices born from Amazon's years of experience. Flexible. It allows users to select the OS, language, database, and other services. Easy to use. Users can host applications quickly and securely. Scalable. Depending on user requirements, applications can be scaled up or down. AWS provides a wide range of services across various domains. What if Rob wanted to create an application for his online portal? AWS provides compute services that can support the app development process from start to finish. From developing, deploying, running, to scaling the application, up or down based on the requirements. The popular services include EC2, AWS Lambda, Amazon Lightsail, and Elastic Beanstalk. For storing website data, Rob could use AWS storage services that would enable him to store, access, govern, and analyze data to ensure that costs are reduced, agility is improved, and innovation accelerated. Popular services within this domain include Amazon S3, EBS, S3 Glacier, and Elastic File Storage. Rob can also store the user data in a database with AWS services, which he can then optimize and manage. Popular services in this domain include Amazon RDS, DynamoDB, and Redshift. If Rob's businesses took off, and he wanted to separate his cloud infrastructure, or scale up his work requests, and much more, he would be able to do so with the networking services provided by AWS. Some of the popular networking services include Amazon VPC, Amazon Route 53, and Elastic Load Balancing. Other domains that AWS provides services in are analytics, blockchain, containers, machine learning, Internet of Things, and so on. And there you go. That's AWS for you in a nutshell. Now, before we're done, let's have a look at a quiz. Which of these services are incorrectly matched? 1, 2, 3, 4. We'll be pinning the question in the comment section. Comment below with your answer and stand a chance to win an Amazon voucher. Several companies around the world have found great success with AWS. Companies like Netflix, Twitch, LinkedIn, Facebook, and BBC have taken advantage of the services offered by AWS to improve their business efficiency. And thanks to their widespread usage, AWS professionals are in high demand. They're highly paid and earn up to more than $127,000 per annum. Once you're AWS certified, you could be one of them too.
Hello everyone, welcome back to the channel. Today, I want to take you on a journey that could transform your career, much like how cloud computing has transformed some of the world's most innovative companies. Imagine Netflix, once a DVD rental service, transforming into a streaming giant capable of delivering high-definition content to millions of users simultaneously. Or consider Airbnb, which has used cloud computing to manage listings and bookings for millions of properties around the globe, providing a seamless experience for hosts and travelers alike. Both Netflix and Airbnb utilized cloud technologies to efficiently scale their businesses, manage large volumes of data, and ensure high availability and performance. So by transitioning from traditional costly and inflexible on-premises infrastructure to scalable cloud environments, they significantly reduced cost, accelerated innovation, and improved user experience in real time. Now you might think that working on such impactful projects requires years of experience and advanced degrees. But there's the good news, guys. With the right approach, you can start a career in cloud engineering in just 3 months, even if you are starting from scratch. In this video, I will outline a clear, actionable plan that uses entirely free online resources to get you there. We will cover the essential skills you need to learn, the certifications that can help validate your knowledge, and practical projects that will make your resumes stand out. So if you're ready to dive into the world of cloud computing and perhaps one day contribute to the next big thing in tech, so stay tuned, guys. So let's get started. And the number one point you should start with is starting your cloud journey. So transitioning into cloud engineering may seem daunting, especially if you are new to this field. The first step is understanding why this is a valuable career move. The cloud industry is booming with a projected market value of $800 billion by 2025 and the potential to grow even further. This growth means a constant demand for skilled professionals, making it an excellent time to enter the field. Now that we understand the industry's potential, the next question is, where should you start? So you should choose a cloud provider. So choosing a cloud provider is a critical decision as it shapes your learning path and future jobs opportunities. So the three major players are AWS, Azure, and Google Cloud Platform, GCP. So starting with AWS, so AWS, that is Amazon Web Services, is often recommended for beginners because it has the largest market share and a wide range of services, which translates into more job opportunities. Now coming to Azure, that is another strong option, especially if you're targeting jobs in enterprises that use Microsoft technologies. Now coming to GCP, that is Google Cloud Platform, and it is gaining popularity and offers excellent features, especially in data analytics and machine learning. For beginners, AWS is popular choice due to its widespread use and extensive documentation. However, it's important to research the demand in your local job market and consider your own interest when making a decision. And with the cloud provider chosen, the next step is to build a strong foundation in the fundamental technologies that underpin cloud computing. So now, before diving into cloud-specific services, it's essential to understand the foundational technologies that cloud computing relies on. These include, number one comes networking. So understanding how data moves across networks is crucial for setting up and managing cloud infrastructure. Then comes operating systems. Familiarity with operating systems, particularly Linux, is essential as most cloud environments run on Linux servers. Then comes virtualization. So this is the process of creating virtual instances of physical hardware. That's a core concept in cloud computing. And then comes databases. So knowledge of databases, both relational and non-relational, is critical for managing data in the cloud. So with these foundational skills in place, you are now ready to explore cloud-specific learning paths. So let's start with certifications. So certifications can validate your knowledge and make you stand out in the job market. For AWS, starting with the AWS Cloud Practitioner certification is advisable. This certification provides a broad overview of cloud concepts and AWS services. It covers key areas such as compute services, storage options, security measures, networking capabilities, and billing and pricing structures. Now coming back, while certifications are valuable, they need to be complemented with practical, hands-on experience to truly demonstrate your skills. Here comes building projects or hands-on practice. So building projects is the most effective way to apply what you have learned and to demonstrate your abilities to potential employers. So here are a few beginner-friendly projects to consider. Number one is setting up virtual machines. So start by launching an EC2 instance on AWS. Learn about the different instance types, configurations, and the basics of server management. Then comes the next project, that is cloud storage systems. So experiment with services like S3 for object storage and RDS for relational databases. Document the use cases and differences between these services. Then deploy a web application. Host a static website using S3 and CloudFront, which will teach you about web hosting, content delivery, and the basics of DNS management with Route 53. Initially, you can use the AWS console for these tasks, but as you progress, try implementing these projects using infrastructure as code tools like Terraform. This approach not only deepens your understanding, but also aligns with industry best practices. In addition to practical projects, having some coding knowledge can greatly enhance your capabilities as a cloud engineer. So now we'll see how you can learn to code. While not always mandatory, coding skills can significantly enhance your effectiveness as a cloud engineer. Languages like Python and Bash are particularly useful for scripting and automation. Even a basic understanding can help with tasks such as writing scripts for server automation, managing cloud services or resources programmatically, then implementing infrastructure as code. For those new to coding, check out SimplilearN videos on YouTube, which offers excellent starting points. Coding skills not only make you more versatile, but also open up opportunities to specialize in areas like DevOps or cloud native development. And once you have built your skills and some projects, it's time to start with the job hunting process. That is, building your profile. Creating a strong online presence is crucial when job hunting. Your LinkedIn profile should clearly reflect your new skills, certifications, and projects. So here are some tips. Number one is optimize your LinkedIn profile. That is, include a professional photo, an engaging summary, and detailed description of your projects. Then comes network actively. Connect with professionals in the field, join cloud computing groups, and participate in discussions. And then comes apply strategically. Tailor your resume for each job application, highlighting the skills and projects that align with the job description. Applying for jobs can be a number game, so be persistent. It's also helpful to reach out to recruiters or hiring managers directly to express your interest in the role. As you start to gain experience in your first cloud role, consider specializing in a niche area to advance your career. And then comes specializing and continuous learning. So specializing in a particular area of cloud computing can make you more valuable and increase your earning potential. Possible specializations include DevOps, that is, it focuses on automation, continuous integration, and continuous deployment practices. Then comes serverless computing, work with functions as a service, that is FAS, and other serverless architectures. And then comes security. specialize in cloud security to protect data and infrastructure. The cloud industry is dynamic with new tools and technologies emerging regularly. So continuous learning is key, so stay updated through online courses, webinars, and industry news. Finally, remember that the journey into cloud engineering is continuous and ever evolving. So, if we talk about resources, so embarking on a career in cloud engineering is challenging but highly rewarding. You utilize free resources like YouTube tutorials, community forums, and documentation to guide your learning.
Before cloud computing existed, if we need any IT servers or application, let's say a basic web server, it does not come easy. Now here is an owner of a business, and I know you would have guessed it already that he's running a successful business by looking at the hot and fresh brewed coffee in his desk and lots of paperwork to review and approve. Now he had a smart, not only smart looking, but a really smart worker in his office called Mark. And on one fine day, he called Mark and said that he would like to do business online. In other words, he would like to take his business online, and for that, he needed his own website as the first thing. And Mark puts all his knowledge together and comes up with this requirement that his boss would need lots of servers, database, and softwares to get his business online, which means a lot of investment. And Mark also adds that his boss will need to invest on acquiring technical expertise to manage the hardware and software that they will be purchasing, and also to monitor the infrastructure. And after hearing all this, his boss was close to dropping his plan to go online. But before he made a decision, he chose to check if there are any alternatives where he don't have to spend a lot of money and don't have to spend acquiring technical expertise. Now that's when Mark opened this discussion with his boss, and he explained his boss about cloud computing. And he explained his boss the same thing that I'm going to explain to you in some time now about what is cloud computing. What is cloud computing? Cloud computing is the use of a network of remote servers hosted on the internet to store, manage, and process data rather than having all that locally and using local server for that. Cloud computing is also storing our data in the internet from anywhere and accessing our data from anywhere throughout the internet. And the companies that offer those services are called cloud providers. Cloud computing is also being able to deploy and manage our applications, services, and network throughout the globe and manage them through the web management or configuration portal. In other words, cloud computing service providers give us the ability to manage our applications and services through a global network or internet. Example of such providers are Amazon Web Services and Microsoft Azure. Now that we have known what cloud computing is, let's talk about the benefits of cloud computing. Now I need to tell you, the cloud benefits is what is driving cloud adoption like anything in the recent days. If you want an IT resource or a service now with cloud, it's available for me almost instantaneously, and it's ready for production almost the same time. Now this reduces the go live date, and the product and the service hit the market almost instantaneously compared to the legacy environment. And because of this, the companies have started to generate revenue almost the next day, if not the same day. Planning and buying the right size hardware has always been a challenge in legacy environment, and if you're not careful when doing this, we might need to live with a hardware that's undersized for the rest of our lives. With cloud, we do not buy any hardware, but we use the hardware and pay for the time we use it. If that hardware does not fit our requirement, release it and start using a better configuration and pay only for the time you use that new and better configuration. In legacy environments, forecasting demand is an full-time job, but with cloud, you can let the monitoring and automation tool to work for you and to rapidly scale up and down the resources based on the need of that hour. Not only that, the resources, services, data can be accessed from anywhere as long as we are connected to the internet. And even there are tools and techniques now available which will let you to work offline and will sync whenever the internet is available. Making sure the data is stored in durable storage and in a secure fashion is the talk of the business, and cloud answers that million-dollar question. With cloud, the data can be stored in a highly durable storage and replicated to multiple regions if you want, and the data that we store is encrypted and secured in a fashion that's beyond what we can imagine in local data centers. Now let's bleed into the discussion about the types of cloud computing. Very lately, there are multiple ways to categorize cloud computing because it's ever growing. Now we have more categories. Out of all, these 6 sort of stand out. Categorizing cloud based on deployments and categorizing cloud based on services. And again, under deployments, categorizing them based on how they have been implemented. Is it private? Is it public? Or is it hybrid? And again, categorizing them based on the service it provides. Is it infrastructure as a service, or is it platform as a service, or is it software as a service? Let's look at them one by one. Let's talk about the different types of cloud based on the deployment models first. In public cloud, everything is stored and accessed in and through the internet, and any internet users with proper permissions can be given access to some of the applications and resources. And in public cloud, we literally own nothing, be it the hardware or software. Everything is managed by the provider. AWS, Azure, and Google are some examples of public cloud. Private cloud, on the other hand, with private cloud, the infrastructure is exclusively for a single organization. The organizations can choose to run their own cloud locally or choose to outsource it to a public cloud provider as managed services. And when this is done, the service, the infrastructure will be maintained on a private network. Some examples are VMware Cloud, and some of the AWS products are very good example for private cloud. Hybrid cloud has taken things to the whole new level. With hybrid cloud, we get the benefit of both public and private cloud. Organizations will choose to keep some of their applications locally, and some of the application will be present in the cloud. One good example is NASA. It uses hybrid cloud. It uses private cloud to store sensitive data and uses public cloud to store and share data which are not sensitive or confidential. Let's now discuss about cloud based on service model. The first and the broader category is infrastructure as a service. Here we would rent the service, network, storage, and we'll pay for them in an hourly basis. But we will have access to the resources we provision, and for some we will have root level access as well. EC2 in AWS is a very good example. It's a VM for which we have root level access to the OS and admin access to the hardware. The next type of service model would be platform as a service. Now, in this model, the providers will give me a pre-built platform where we can deploy our codes and our applications, and they will be up and running. We only need to manage the codes and not the infrastructure. Here in software as a service, the cloud providers sell the end product, which is a software or an application, and we directly buy the software on a subscription basis. It's not the infra or the platform, but the end product or the software or a functioning application, and we pay for the hours we use the software. And in here, the client maintains full control of the software and does not maintain any equipment. Amazon and Azure also sell products that are software as service. This chart sort of explains the difference between the 4 models, starting from on-premises to infrastructure as a service to platform as a service to software as a service. This is self-explanatory that the resources managed by us are huge in on-premises, that towards your left as you watch, and it's little less in infrastructure as a service as we move further towards the right, and further reduced in platform as a service, and there's really nothing to manage when it comes to software as a service because we buy the software, not any infrastructure component attached to it. Now let's talk about the life cycle of the cloud computing solution. The very first thing in the life cycle of a solution or a cloud solution is to get a proper understanding of the requirement. I didn't say get the requirement, but said get a proper understanding of the requirement. It is very vital because only then we will be able to properly pick the right service offered by the provider. Getting a sound understanding, the next thing would be to define the hardware. Meaning choose the compute service that will provide the right support where you can resize the compute capacity in the cloud to run application programs. Getting a sound understanding of the requirement helps in picking the right hardware. One size does not fit all. There are different services and hardwares for different needs you might have, like EC2 if you're looking for IaaS, and Lambda if you're looking for serverless computing, and ECS that provides containerized service. So there are a lot of hardwares available. Pick the right hardware hardware that suits your requirement. The third thing is to define the storage. Choose the appropriate storage service where you can back up your data, and a separate storage service where you can archive your data locally within the cloud or from the internet. And choose the appropriate storage. There is one separately for backup called S3, and there is one separately for archival, that's for Glacier. So knowing the difference between them really helps in picking the right service for the right kind of need. Define the network that securely delivers data, video, and applications. Define and identify the network services properly. For example, VPC for network, Route 53 for DNS, and direct connection for private P2P line from your office to the AWS data center. Set up the right security services, IAM for authentication and authorization, and KMS for data encryption at rest. So there are a variety of security products available. We got to pick the right one that suits our need. And there are a variety of deployment and automation and monitoring tools that you can pick from. For example, CloudWatch is for monitoring, autoscaling is for being elastic, and CloudFormation is define the management process and tools. You can have complete control of your cloud environment if you define the management tools which monitors your AWS resources and or the custom applications running on AWS platform. There are a variety of deployment, automation, and monitoring tools you can pick from, like CloudWatch for monitoring, autoscaling for automation, and CloudFormation for deployment. So knowing them will help you in defining the life cycle of the cloud computing solution properly. And similarly, there are a lot of tools for testing a process like CodeStar and CodeBuild and CodePipeline. These are tools with which you can build, test, and deploy your code quickly. And finally, once everything is said and done, pick the analytics service for analyzing and visualizing the data using the analytics services, where we can start querying the data instantly and get a result. Now, if you want to visually view the happenings in your environment, you can pick Athena, and other tools for analytics are EMR, and which is Elastic MapReduce, and Cloud Search.
Thanks, guys. Now we have Samuel and Rahul to take us through the full course in which they will explain basic framework of Amazon Web Services and explore all of its important services like EC2, Lambda, S3, IAM, and CloudFormation. We'll also talk about Azure and some of its popular services.
Hello everyone, let me introduce myself as Sam, a multi-platform cloud architect and trainer, and I'm so glad and I'm equally excited to talk and walk you through this session about what AWS is and talk to you about some services and offerings and about how companies get benefited by migrating their applications and infra into AWS. So what's AWS? Let's talk about that. Now, before that, let's talk about how life was without any cloud provider, and in this case, how life was without AWS. So let's walk back and picture how things were back in 2000, which is not so long ago, but a lot of changes for better had happened since that time. Now, back in 2000, a request for a new server is not an happy thing at all, because a lot of money, a lot of validations, a lot of planning are involved in getting a server online or up and running. And even after we finally got the server, it's not all said and done. There's a lot of optimization that needs to be done on that server to make it worth it and get a good return on investment from that server. And even after we have optimized for a good return on investment, the work is still not done. There will often be a frequent increase and decrease in the capacity, and even news about our website getting popular and getting more hits, it's still an bittersweet experience, because now I need to add more servers to the environment, which means that it's going to cost me even more. But thanks to the present day cloud technology, if the same situation were to happen today, my new server, it's almost ready, and it's ready instantaneously. And with the swift tools and technologies that Amazon is providing in provisioning my server instantaneously and adding any type of workload on top of it and making my storage and server secure, creating a durable storage where data that I store in the cloud never gets lost, with all that features, Amazon has got our back. So let's talk about what is AWS. There are a lot of definitions for it, but I'm going to put together a simple and a precise definition as much as possible. Now, let me iron that out. Cloud still runs on an hardware, right? And there are certain features in that infrastructure in that cloud infrastructure that makes cloud cloud, or that makes AWS a cloud provider. Now, we get all the services, all the technologies, all the features, and all the benefits that we get in our local data center, like, security and compute capacity and databases. And in fact, we get even more cool features like content caching in various global locations around the planet. But again, out of all the features, the best part is that we get everything on a pay-as-we-go model. The less I use, the less I pay, and the more I use, the less I pay per unit. Very attractive, isn't it? Right? And that's not all. The applications that we provision in AWS are very reliable because they run on a reliable infrastructure, and it's very scalable because it runs on an on-demand infrastructure, and it's very flexible because of the designs and because of the design options available for me in the cloud. Let's talk about how all this happened. AWS was launched in 2002 after the Amazon, we know as the online retail store, wanted to sell their remaining or unused infrastructure as a service or as an offering for customers to buy and use it from them, sell infrastructure as a service. The idea sort of clicked, and AWS launched their first product in 2006. That's like 4 years after the idea launch. And in 2012, they held a big-sized customer event to gather inputs and concerns from customers, and they were very dedicated in making those requests happen. And that habit is still being followed. It's still being followed as reInvent by AWS. And at 2015, Amazon announced its revenue to be 4.6 billion. And in 2015 through 2016, AWS launched products and services that help migrate customer services into AWS. Well, there were products even before, but this is when a lot of focus was given on developing migrating services. And in the same year, that's in 2016, Amazon's revenue was 10 billion. And not the least, as we speak, Amazon has more than 100 products and services available for customers and get benefited from. Alright, let's talk about the services that are available in Amazon. Let's start with this product called S3. Now, S3 is a great tool for internet backup, and it's the cheapest storage option in the object storage category. And not only that, the data that we put in S3 is retrievable from the internet. S3 is really cool. And we have other products like migration and data collection and data transfer products. And here we can not only collect data seamlessly, but also in a real-time way monitor the data or analyze the data that's being received. That there are cool products like AWS Data Transfers available that helps achieve that. And then we have products like EC2, Elastic Compute Cloud. That's an resizable computer where we can anytime alter the size of the computer based on the need or based on the forecast. Then we have simple notification services, systems and tools available in Amazon to update us with notifications through email or through SMS. Now anything can be sent through email or through SMS if we use that service. It could be alarms, or it could be service notifications if you want, stuff like that. And then we have some security tools like KMS, Key Management System, which uses AES 256-bit encryption to encrypt our data at rest. Then we have Lambda, a service for which we pay only for the time in seconds it takes to execute our code, and we're not paying for the infrastructure here. It's just the seconds the program is going to take to execute the code. If it's a short program, we'll be paying in milliseconds. If it's a bit bigger program, we'll be probably paying in 60 seconds or 120 seconds. But that's a lot cheap, lot simple, and lots cost effective as against paying for service on an hourly basis, which a lot of other services are. Well, that's cheap, but using Lambda is a lot cheaper than that. And then we have services like Route 53, a DNS service in the cloud. And now I do not have to maintain an DNS account somewhere else and my cloud environment with AWS. I can get both in the same place. Alright, let me talk to you about how AWS makes life easier, or how companies got benefited by using AWS as their IT provider for their applications or for the infrastructure. Now, Unilever is a company, and they had a problem, right? And they had a problem, and they picked AWS as a solution to their problem, right? Now, this company was sort of spread across 190 countries, and they were relying on a lot of digital marketing for promoting their products. And their existing environment, their legacy local environment, proved not to support their changing IT demands, and they could not standardize their old environment. Now, they chose to move part of their applications to AWS because they were not getting what they wanted in their local environment. And since then, rollouts were easy, provisioning new applications became easy, and even provisioning infrastructure became easy, and they were able to do all that in push button scaling. And needless to talk about backups that are safe and backups that can be securely accessed from the cloud as needed. Now, that company is growing along with AWS because of their swift speed in rolling out deployments and being able to access secure backups from various places and generate reports, and in fact useful reports out of it that helps their business. Now, on the same lines, let me also talk to you about Kellogg's and how they got benefited by using Amazon. Now, Kellogg's had a different problem. It's one of its kind. Now, their business model was very dependent on an infra that will help to analyze data really fast, right? Because they were running promotions based on the analyzed data that they get. So they being able to respond to the analyzed data as soon as possible was critical or vital in their environment. And luckily, SAP running on HANA environment is what they needed, and they picked that service in the cloud, and that sort of solved the problem. Now, the company does not have to deal with maintaining their legacy infra and maintaining their heavy compute capacity and maintaining their database locally. All that is now moved to the cloud, or they are using cloud as their IT service provider, and now they have a greater and powerful IT environment that very much complements their business.
Hi there, I'm Samuel, a multi-platform cloud architect, and I'm very excited and honored to walk you through this learning series about AWS. Let me start the session with this scenario. Let's imagine how life would have been without Spotify. For those who are hearing about Spotify for the first time, Spotify is an online music service offering, and it offers instant access to over 16 million licensed songs. Spotify now uses AWS Cloud to store the data and share it with their customers, but prior to AWS, they had some issues. Imagine using Spotify before AWS. Let's talk about that. Back then, users were often getting errors because Spotify could not keep up with the increased demand for storage every new day. And that led to users getting upset and users canceling the subscription. The problem Spotify was facing at that time was their users were present globally and were accessing it from everywhere, and they had different latency in their applications. And Spotify had a demanding situation where they need to frequently catalog the songs released yesterday, today, and in the future, and this was changing every new day. And the songs coming in rate was about 20,000 a day, and back then they could not keep up with this requirement, and needless to say, they were badly looking for a way to solve this problem. And that's when they got introduced to AWS, and it was a perfect fit and match for their problem. AWS offered a dynamically increasing storage, and that's what they needed. AWS also offered tools and techniques like storage lifecycle management and trusted advisor to properly utilize the resource, so we always get the best out of the resource used. AWS addressed their concerns about easily being able to scale. Yes, you can scale the AWS environment very easily. How easily, one might ask? It's just a few button clicks. And AWS solved Spotify's problem. Let's talk about how it can help you with your organization's problem. Let's talk about what is AWS first, and then let's bleed into how AWS became so successful and the different types of services that AWS provides, and what's the future of cloud and AWS in specific. Let's talk about that. And finally, we'll talk about a use case where you will see how easy it is to create a web application integration with AWS. Alright, let's talk about what is AWS. AWS, or Amazon Web Services, is a secure cloud service platform. It is also pay-as-you-go type billing model where there is no upfront or capital costs. We'll talk about how soon the service will be available. Well, the service will be available in a matter of seconds. With AWS, you can also do identity and access management, that is, authenticating and authorizing a user or a program on the fly. And almost all the services are available on demand, and most of them are available instantaneously. And as we speak, Amazon offers 100 plus services, and this list is growing every new week. Now that would make you wonder how AWS became so successful. Of course, it's their customers. Let's talk about the list of well-known companies that has their IT environment in AWS. Adobe uses AWS to provide multi-terabyte operating environments for its customers. By integrating its system with AWS Cloud, Adobe can focus on deploying and operating its own software instead of trying to deploy and manage the infrastructure. Airbnb is another company. It's an community marketplace that allows property owners and travelers to connect each other for the purpose of renting unique vacation spaces around the world. And the Airbnb community users' activities are conducted on the website and through iPhones and Android applications. Airbnb has a huge infrastructure in AWS, and they're almost using all the services in AWS and are getting benefited from it. Another example would be Autodesk. Autodesk develops software for engineering, designing, and entertainment industries using services like Amazon RDS or Relational Database Service and Amazon S3 or Amazon Simple Storage Service. Autodesk can focus on deploying or developing its machine learning tools instead of spending that time on managing the infrastructure. AOL, or American Online, uses AWS, and using AWS they have been able to close data centers and decommission about 14,000 in-house and co-located servers and move mission critical workload to the cloud and extend its global reach and save millions of dollars on energy resources. Bitdefender is an internet security software firm, and their portfolio of softwares include antivirus and anti-spyware products. Bitdefender uses EC2, and they're currently running few hundred instances that handle about 5 terabytes of data, and they also use Elastic Load Balancer to load balance the connection coming in to those instances across availability zones, and they provide seamless global delivery of service because of that. The BMW Group, it uses AWS for its new connected car application that collects sensor data from BMW 7 series cars to give drivers dynamically updated map information. Canon's Office Imaging Products division benefits from faster deployment times, lower cost, and global reach by using AWS to deliver cloud-based services such as mobile print. The Office Imaging Products division uses AWS such as Amazon S3 and Amazon Route 53, Amazon CloudFront, and Amazon IAM for their testing, development, and production services. Comcast, it's the world's largest cable company and the leading provider of internet service in the United States. Comcast uses AWS in a hybrid environment. Out of all the other cloud providers, Comcast chose AWS for its flexibility and scalable hybrid infrastructure. Docker is a company that's helping redefine the way developers build, ship, and run applications. This company focuses on making use of containers for this purpose. And in AWS, the service called the Amazon EC2 Container Service is helping them achieve it. The ESA, or European Space Agency, although much of ESA's work is done by satellites, some of the program's data storage and computing infrastructure is built on Amazon Web Services. ESA chose AWS because of its economical pay-as-you-go system as well as its quick startup time. The Guardian newspaper uses AWS, and it uses a wide range of AWS services including Amazon Kinesis, Amazon Redshift that power an analytic dashboard which editors use to see how stories are trending in real time. Financial Times, FT, is one of the world's largest leading business news organization, and they used Amazon Redshift to perform their analysis. A funny thing happened. Amazon Redshift performed so quickly that some analysts thought it was malfunctioning. They were used to running queries overnight, and they found that the results were indeed correct, just as much faster. By using Amazon Redshift, FT is supporting the same business functions with costs that are 80% lower than what was before. General Electric, GE, is at the moment as we speak migrating more than 9,000 workloads including 300 disparate ERP systems to AWS while reducing its data center footprint from 34 to 4 over the next 3 years. Similarly, Harvard Medical School, HTC, IMDb, McDonald's, NASA, Kellogg's, and a lot more are using the services Amazon provides and are getting benefited from it. And this huge success and customer portfolio is just the tip of the iceberg. And if we think why so many adapt AWS, and if we let AWS answer that question, this is what AWS would say. People are adapting AWS because of the security and durability of the data and end-to-end privacy and encryption of the data and storage. Experience. We can also rely on AWS way of doing things by using the AWS tools and techniques and suggested best practices built upon the years of experience it has gained. Flexibility. There is a greater flexibility in AWS that allows us to select the OS, language, and database. Easy to use. Swiftness in deploying. We can host our applications quickly in AWS, be it a new application or migrating an existing application into AWS. Scalability. The application can be easily scaled up or scaled down depending on the user requirement. Cost saving. We only pay for the compute power, storage, and other resources you use, and that too without any long-term commitments. Now let's talk about the different types of services that AWS provides. The services that we talk about fall in any of the following categories you see, like compute, storage, database, security, customer engagement, desktop and streaming, machine learning, developers tools, stuff like that. And if you do not see the service that you're looking for, it's probably is because AWS is creating it as we speak. Now let's look at some of them that are very commonly used. Within compute services, we have Amazon EC2, Amazon Elastic Beanstalk, Amazon Lightsail, and Amazon Lambda. Amazon EC2 provides compute capacity in the cloud. Now this capacity is secure and it is resizable based on the user's requirement. Now look at this. The requirement for the web traffic keeps changing, and behind the scenes in the cloud, EC2 can expand its environment to 3 instances, and during no load, it can shrink its environment to just 1 resource. Elastic Beanstalk, it helps us to scale and deploy web applications, and it's made with a number of programming languages. Elastic Beanstalk is also an easy to use service for deploying and scaling web applications and services deployed be it in Java, .NET, PHP, Node.js, Python, Ruby, Docker, and a lot other familiar services such as Apache, Passenger, and IIS. We can simply upload our code, and Elastic Beanstalk automatically handles the deployment from capacity provisioning to load balancing to auto scaling to application health monitoring. And Amazon Lightsail is a virtual private server which is easy to launch and easy to manage. Amazon Lightsail is the easiest way to get started with AWS for developers who just need a virtual private server. Lightsail includes everything you need to launch your project quickly on a virtual machine, like SSD based storage, a virtual machine, tools for data transfer, DNS management, and a static IP, and that too for a very low and predictable price. AWS Lambda has taken cloud computing services to a whole new level. It allows us to pay only for the compute time, no need for provisioning and managing servers. And AWS Lambda is a compute service that lets us run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically from few requests per day to thousands per second. You pay only for the compute time you consume. There is no charge when your code is not running. Let's look at some storage services that Amazon provides, like Amazon S3, Amazon Glacier, Amazon EBS, and Amazon Elastic File System. Amazon S3 is an object storage that can store and retrieve data from anywhere. Websites, mobile apps, IoT sensors, and so on can easily use Amazon S3 to store and retrieve data. It's an object storage built to store and retrieve any amount of data from anywhere. With its features like flexibility in managing data and the durability it provides and the security that it provides, Amazon Simple Storage Service or S3 is a storage for the internet. And Glacier is a cloud storage service that's used for archiving data and long-term backups. And this Glacier is an secure secure, durable, and extremely low-cost cloud storage service for data archiving and long-term backups. Amazon EBS, Amazon Elastic Block Store, provides block store volumes for the instances of EC2. And this Elastic Block Store is highly available and a reliable storage volume that can be attached to any running instance that is in the same availability zone. EBS volumes that are attached to the EC2 instances are exposed as storage volumes that persist independently from the lifetime of the instance. And Amazon Elastic File System, or EFS, provides an elastic file storage which can be used with AWS Cloud Service and resources that are on premises. And Amazon Elastic File System, it's simple, it's scalable, it's an elastic file storage for use with Amazon Cloud Services and for on-premises resources. It's easy to use and offers a simple interface that allows you to create and configure file systems quickly and easily. Amazon File System is built to elastically scale on demand without disturbing the application, growing and shrinking automatically as you add and remove files, so your application have the storage they need and when they need it. Now let's talk about databases. The two major database flavors are Amazon RDS and Amazon Redshift. Amazon RDS, it really eases the process involved in setting up, operating, and scaling a relational database in the cloud. Amazon RDS provides cost-efficient and resizable capacity while automating time-consuming administrative tasks such as hardware provisioning, database setup, patching, and backups. It sort of frees us from managing the hardware and sort of helps us to focus on the application. It's also cost effective and resizable, and it's also optimized for memory, performance, and input and output operations. Not only that, it also automates most of the services like taking backups, monitoring, stuff like that. It automates most of those services. Amazon Redshift. Amazon Redshift is a data warehousing service that enables users to analyze the data using SQL and other business intelligence tools. Amazon Redshift is an fast and fully managed data warehouse that makes it simple and cost-effective to analyze all your data using standard SQL and your existing business intelligence tools. It also allows you to run complex analytic queries against petabyte of structured data using sophisticated query optimizations. And most of the results, they generally come back in seconds. Alright, let's quickly talk about some more services that AWS offers. There are a lot more services that AWS provides, but we're going to look at some more services that are widely used. AWS Application Discovery Services help enterprise customers plan migration projects by gathering information about their on-premises data centers. Planning a data center migration can involve thousands of workloads. They are often deeply interdependent. Server utilization data and dependency mapping are important early first step in migration process. And this AWS Application Discovery Service collects and presents configuration, usage, and behavior data from your servers to help you better understand your workloads. Route 53, it's a network and content delivery service. It's an highly available and scalable cloud domain name system or DNS service. And Amazon Route 53 is fully compliant with IPv6 as well. Elastic Load Balancing, it's also a network and content delivery service. Elastic Load Balancing automatically distributes incoming application traffic across multiple targets such as Amazon EC2 instance, containers, and IP addresses. It can handle the varying load of your application traffic in a single availability zone and also across availability zones. AWS Auto Scaling, it monitors your application and automatically adjusts the capacity to maintain steady and predictable performance at a lowest possible cost. Using AWS Auto Scaling, it's easy to set up application scaling for multiple resources across multiple services in minutes. Auto scaling can be applied to web services and also for DB services. AWS Identity and Access Management, it enables you to manage access to AWS services and resources securely. Using IAM, you can create and manage AWS users and groups and use permissions to allow and deny their access to AWS resources. And moreover, it's a free service. Now let's talk about the future of AWS. Well, let me tell you something. Cloud is here to stay. Here's what in store for AWS in the future. As years pass by, we're going to have a variety of cloud applications born like IoT, artificial intelligence, business intelligence, serverless computing, and so on. Cloud will also expand into other markets like healthcare, banking, space, automated cars, and so on. As I was mentioning some time back, lot or greater focus will be given to artificial intelligence. And eventually, because of the flexibility and advantage that cloud provides, we're going to see a lot of companies moving into the cloud. Alright, let's now talk about how easy it is to deploy an web application in the cloud. So the scenario here is that our users like a product and we need to have a mechanism to receive input from them about their likes and dislikes and give them the appropriate product as per their need. Alright, though the setup and the environment, it sort of looks complicated, we don't have to worry because AWS has tools and technologies which can help us to achieve it. Now we're going to use services like Route 53, services like CloudWatch, EC2, S3 and a lot more, and all these put together are going to give an application that's fully functionable and an application that's going to receive the information like using the services like Route 53, CloudWatch, EC2 and S3. We're going to create an application and that's going to meet our need. So back to our original requirement, all I want is to deploy a web application for a product that keeps our users updated about the happenings and the new comings in the market. And to fulfill this requirement, here is all the services we would need. EC2 here is used for provisioning the computational power needed for this application. And EC2 has a vast variety of family and types that we can pick from for the types of workloads and also for the intents of the workloads. We're also going to use S3 for storage, and S3 provides any additional storage requirement for the resources or any additional storage requirement for the web applications. And we're also going to use CloudWatch for monitoring the environment, and CloudWatch monitors the application and the environment, and it provides trigger for scaling in and scaling out the infrastructure. And we're also going to use Route 53 for DNS, and Route 53 helps us to register the domain name for our web application. And with all the tools and technologies together, all of them put together, we're going to make an application, a perfect application that caters our need. Alright, so I'm going to use Elastic Beanstalk for this project, and the name of the application is going to be, as you see, GSG Signup, and the environment name is GSG Signup Environment 1. Let me also pick a name. Right, let me see if this name is available. Yes, that's available. That's the domain name. So let me pick that, and the application that I have is going to run on Node.js. So let me pick that platform and launch. Now, as you see, Elastic Beanstalk, this is going to launch an instance. It's going to launch the monitoring setup or the monitoring environment. It's going to create a load balancer as well, and it's going to take care of all the security features needed for this application. Alright, look at that. I was able to go to that URL, which is what we gave, and it's now having an default page shown up, meaning all the dependencies for the software is installed and it's just waiting for me to upload the code, or in specific the page required. So let's do that. Let me upload the code. I already have the code saved here. That's my code, and that's going to take some time. Alright, it has done its thing. And now if I go to the same URL, look at that, I'm being thrown an advertisement page. Alright, so if I sign up with my name, email, and stuff like that, it's going to receive the information and it's going to send an email to the owner saying that somebody had subscribed to your service. That's the default feature of this app. Look at that. Email to the owner saying that somebody had subscribed to your app and this is their email address, stuff like that. Not only that, it's also going to create an entry in the database. And DynamoDB is the service that this application uses to store data. There's my DynamoDB. And if I go to tables, right, and go to items, I'm going to see that a user with name Samuel and email address so and so has said okay or has shown interest in the preview of my site or product. So this is where, or this is how I collect those information, right? And some more things about the infrastructure itself is it is running behind an load balancer. Look at that. It had created a load balancer. It had also created an auto scaling group. Now that's the feature of Elastic Load Balancer that we have chosen. It has created an auto-scaling group. And now let's put this URL. You see this? It's not a fancy URL, right? It's an Amazon given URL, a dynamic URL. So let's put this URL behind our DNS. Let's do that. So go to services, go to Route 53, go to hosted zone, and there we can find the DNS name, right? So that's a DNS name, all right? Right, let's create an entry and map that URL to our load balancer, right? And create. Now, technically, if I go to this URL, it should take me to that application. All right, look at that. I went to my custom URL and now that's pointed to my application. Previously, my application was having a random URL and now it's having a custom URL. So what did we learn? We started the session with what is AWS. We looked at features and tools, technologies, products that AWS provides. And we also looked at how AWS became very successful. Again, we looked into the benefits and features of AWS in depth. And we also looked at some of the services that AWS provides in random. And then we picked particular services and we talked about them like EC2, Elastic Beanstalk, Lightsail, Lambda, storage, stuff like that. Then we also looked at the future of AWS, what AWS holds in the store for us. We looked at that, and then finally we looked at a lab in which we created an application using Elastic Beanstalk, and all that we had to do was a couple of clicks and boom, an application was there available that was connected to the database, and that was connected to the simple notification system, that was connected to CloudWatch, that was connected to storage, stuff like that.
What is Azure? What's the big cloud service provider all about? So Azure is a cloud computing platform provided by Microsoft. Now it's basically an online portal through which you can access and manage resources and services. Now resources and services are nothing but, you can store your data and you can transform the data using services that Microsoft provides. Again, all you need is the internet and being able to connect to the Azure portal. Then you get access to all of their resources and their services. In case you want to know more about how it's different from its rival, which is AWS, I suggest you click on the top right corner and watch the AWS versus Azure video so that you can clearly tell how both these cloud service providers are different from each other. Now, here are some things that you need to know about Azure. It was launched on February 1st, 2010, which is significantly later than when AWS was launched. It's free to start and has a pay-per-use model, which means, like I said before, you need to pay for the services you use through Azure. And one of their most important selling points is that 80% of Fortune 500 companies use Azure services, which means that most of the bigger companies of the world actually recommend using Azure. And then Azure supports a wide variety of programming languages, the C#, Node.js, Java, and so much more. Another very important selling point of Azure is the amount of data centers it has across the world. Now, it's important for a cloud service provider to have many data centers around the world because it means that they can provide their services to a wider audience. Now, Azure has 42, which is more than any cloud service provider has at the moment. It expects to have 12 more in a period of time, which brings its total number of regions it covers to 54. Now, let's talk about Azure services. Now, Azure services have 18 categories and more than 200 services, so we clearly can't go through all of them. It has services that cover compute, AI and machine learning, integration, management tools, identity, DevOps, web, and so much more. You're going to have a hard time trying to find a domain that Azure doesn't cover. And if it doesn't cover it now, you can be certain they're working on it as we speak. So first, let's start with the compute services. First, virtual machine. With this service, what you're getting to do is to create a virtual machine of Linux or Windows operating system. It's easily configurable. You can add RAM, you can decrease RAM, you can add storage, remove it. All of it is possible in a matter of seconds. Now let's talk about the second service, cloud service. Now with this, you can create an application within the cloud, and all of the work after you deploy it, deploying the application that is taken care of by Azure, which includes, provisioning the application, load balancing, ensuring that the application is in good health, and all of the other things are handled by Azure. Next up, let's talk about Service Fabric. Now with Service Fabric, the process of developing a microservice is greatly simplified. So you might be wondering, what exactly is a microservice? Now a microservice is basically an application that consists of smaller applications coupled together. Next up, functions. Now with functions, you can create applications in any programming language that you want. Another very important part is that you don't have to worry about any hardware components. You don't have to worry what RAM you require or how much storage you require. All of that is taken care of by Azure. All you need is to provide the code to Azure and it'll execute it, and you don't have to worry about anything else. Now let's talk about some networking services. First up, we have Azure CDN, or the Content Delivery Network. Now the Azure CDN service is basically for delivering web content to users. Now, this content is of high bandwidth and can be transferred or can be delivered to any person across the world. Now, these are actually a network of servers that are placed in strategic positions across the world so that the customers can obtain this data as fast as possible. Next up, we have Express Route. Now, with this, you can actually connect your on-premise network onto the Microsoft Cloud or any of the services that you want through a private connection. So the only communication that happens is between your on-premise network and the service that you want. Then you have Virtual Network. Now, with Virtual Network, you can have any of the Azure services communicate with each other in a secure manner, in a private manner. Next, we have Azure DNS. So Azure DNS is a hosting service which allows you to host their DNS or domain name system domains in Azure. So you can host your application using Azure DNS. Now for the storage services. First up, we have disk storage. With disk storage, you're given a cost-effective option of choosing HDD or solid-state drives to go along with your virtual machines based on your requirements. Then you have blob storage. Now, this is actually optimized to ensure that they can store massive amounts of unstructured data, which can include text data or even binary data. Next, you have file storage, which is a managed file storage and can be accessible via the SMB protocol or the server message block protocol. And finally, you have queue storage. Now with queue storage, you can provide durable message queuing for an extremely large workload. And the most important part is that this can be accessed from anywhere in the world. Now, let's talk about how Azure can be used. Firstly, for application development. It could be any application, mostly web applications. Then you can test the application, see how well it works. You can host the application on the internet. You can create virtual machines like I mentioned before. With the service, you can create these virtual machines of any size or RAM that you want. You can integrate and sync features. You can collect and store matrices. For example, how the data works, how the current data is, how you can improve upon it. All of that is possible with these services. And you have virtual hard drives, which is an extension of the virtual machines where these services are able to provide you a large amount of storage where data can be stored.
Talk about Azure in great length and breadth. And if you're looking for a video that talks and walks you through all the services in Azure, then this could be one of the best video you could find in the internet. And without any further delay, let's get started. Everybody likes stories, so let's get started with a story. In a city not so far away, a CEO had plans to expand his company globally and called one of his IT personnel for an IT opinion. And this guy has been in the company for a long time and is very seasoned with the company's infra. And he nicely answered the questions with what he foresaw. And he said, I have a good news and a bad news for us to go global. And he starts with the good news. He said, Sir, we're well on our way to become one of the world's largest shipping company. And the bad news is, however, our data centers have almost run out of space, and setting up new ones around the world would be too expensive and very time consuming. Now the IT personnel, let's call him Mike, now he explains the situation from how he saw it. But the CEO had done some homework about how he was going to do it, and he answered Mike saying, don't worry about that, Mike. I've come up with a solution for a problem and it's called Microsoft Azure. Well, Mike is an hard-working and honest IT professional working for that company, but he did not spend time on learning the latest technologies. And he asked this question very honestly, oh, how does it solve a problem? And the CEO begins to explain Azure to Mike, and he starts with what is cloud computing, and then he goes on and talks about Azure and the services offered by Azure and why Azure is better than the other cloud providers, and what are the great companies that uses Azure and how they got benefited out of it. And then he winds it all up with the use cases of Azure. So he begins his explanation saying Microsoft Azure is known as the cloud service provider, and it works on the basis of cloud computing. Now Microsoft Azure is formerly known as Windows Azure, and it's Microsoft's public cloud computing platform. It also provides a range of cloud services, including some of them are compute, analytics, storage, and networking. We can always pick and choose from these services to develop and scale our applications, or even plan on running existing applications in the public cloud. Microsoft Azure is both a platform as a service and infrastructure as a service. Let's now fade their conversation out and let's talk about what is cloud computing, Azure, services offered by Azure, how is Azure leading when compared to other cloud service providers, and what are the companies that are using Azure. Let's talk about that. In simple terms, cloud computing is being able to access compute services like servers, storage, database, networking, software analytics, intelligence, and a lot more over the internet, which is the cloud, with the flexibility of the resources that we use. Like anytime I want a resource, I can use one and it becomes available immediately. And anytime if I want to retire a resource, I can simply retire a resource and not pay for it. And we also typically pay only for the services that we use. And this helps greatly with our operating cost to run our infrastructure more efficiently and scale our environment up or down depending on the business needs and changes. And all the servers and storages and databases and networking, all that are accessed through the network of remote systems or remote computers hosted in the internet, typically in the provider's data center, which is Azure in this case. Now, we don't use any physical server or an on-premises server here. Well, we still use physical servers and VMs, hosted on a hardware or a physical server, but they're all in the provider's environment and none of them sit on premises or in our data center. We only access them remotely. It looks and feels the same, except for the fact that they are in a remote location. We access them remotely, do all the work remotely, and when we're done, we can shut it down and not pay for them. So some of the use cases of cloud computing are creating applications and services. The other use cases are storing or using cloud for storage alone. If there is one thing that ever grows in an organization, is the storage. Every new day there is a new storage requirement, and it's very dynamic. It's very hard to predict, and if we go out and buy a big storage capacity upfront, until we use the storage capacity fully, the empty storages, we're wasting money on them. So instead, I can go for a storage which scales dynamically, that's in the cloud. Put storage or put data in the cloud and pay only for what you're storing. And for the next month, if you have deleted or flushed out some files or data, pay less for it. So it's a very dynamic storage in the cloud, and a lot of companies are getting benefited from storing data in the cloud because of its dynamic in nature and the cost that comes along with it, the cheap cost that comes along with it. And also they give a lot of the providers like Azure, they give data replication for free. They promise an SLA along with the data we store in the cloud. So there's an SLA attached to it. And they also provide data recoveries as well. If in case something goes wrong with the physical disk where our data is stored, Azure automatically makes our data available from the redundant or other places where it had stored our data because of the SLA they wanted to keep. The other use case for Azure is hosting websites and running blogs using the compute service. Be it storing music and letting your users stream the music, Azure is a good place to store music and stream the music with the benefit of CDN, Content Delivery Network, which allows us to stream video or audio files with great speed. With Azure, our audio or video application works seamlessly because they are provided to the client with very low latency, and that improves the customer experience for our application. Azure Compute Service is a good place for delivering software on demand. There are a lot of softwares, embedded softwares that we can buy using Azure, and everything on a pay-as-you-go service model. So anytime we need a software, we can go out and immediately buy the software for the next 1 hour or 2 hour, let's say, and use them and then return it back. We're not bound to any yearly licensing cost by that. Azure Computing Services has analytics available for us with which we can analyze, get a good visualization of what's going on in a network, be it logs, be it the performance, be it the metrics. Instead of looking at logs and searching logs and trying to do manual things over the heaps and heaps of logs that we have saved, Azure Analytics Services helps us to get a good visual of what's going on in the network. Where have we dropped? Where have we increased? Or what's causing? What's the major driver? What is the top 10 errors that we get in the server, in the application? Stuff like that. Those can be easily gathered from the Azure Analytic Services. Now, cloud is really a very cool term for the internet. A good analogy would be looking back anytime we look at a diagram. When we do not know how things are transferred, we simply draw a cloud, right? For example, a mail gets sent from a person in one country to a person in the other country. There are a lot of things happening in between from the time you hit the send button and the time the other person hits the read button, right? And the simple and the easiest way of putting it in a picture is simply draw a cloud, and on the one end, one person will be sending the email, and on the other end, the other person will be reading the email. So a cloud is a really cool term for the internet. Now that's some basics about cloud computing. Now that we've understood about cloud computing in general, let's talk about Microsoft Azure as a cloud service. Now, Microsoft Azure is a set of cloud services to build, manage, and deploy applications on a network with the help of Microsoft Azure's frameworks. Now, Microsoft Azure is a computing service created by Microsoft basically for building, testing, deploying, and managing applications and services through a global network of Microsoft managed data centers. Now, Microsoft Azure provides SaaS, which is software as a service, and PaaS, which is platform as a service, and IaaS, infrastructure as a service, and they support many different programming languages, tools, and framework. And those tools and framework include both Microsoft specific and third-party software. Now let me pick and talk about a specific service. For example, management. Azure Automation provides a way for us to automate the manual, long running and frequently repeated tasks that are commonly performed tasks both in cloud and enterprise environment. It saves us a lot of time and increases the reliability, and it kind of gives a good administrative control and even schedules the task automatically to be performed on a regular basis. To give you a quick history of Microsoft Azure, it was launched on 1st February 2010, and it was awarded, or it was called an industry leader for infrastructure and platform as a service by Gartner. Now, Gartner is the world's leading research and advisory company. This Microsoft Azure supports a number of programming languages like C#, Java, and Python. All these cool services we get to use and pay only for how much we use. For example, if we use for an hour, we only get to pay for an hour, even the costliest system available. And if we use them for an hour, we only pay for that particular hour, and then we're done. No more billing on the resource that we have used. Microsoft Azure has spread itself more than 50 regions around the world. So it's quite easy for us to pick a region and start provisioning and running our applications probably from day one, because the infrastructure and the tools and technologies needed to run our application are already available. All that we have to do is commit the code in that particular region or build an application and launch it in that particular region, and they become live starting day one. Now, because we have 50 regions around the world, we can very carefully design our environment to provide low latency services to our customers. All right. Instead of in traditional data center, let's say, customers will have to, or their requests will have to travel all the way around the globe to reach a data center which lives in the other side of the planet. And this adds more latency to it. And it is really not feasible to build a data center near each customer location because of the cost involved. But with Azure, it's possible. Azure already has data centers around the world, and all that we have to do is just pick a data center, build an environment there. They're available starting day one, number one. And also the cost is considerably saved because we are using a public cloud instead of an physical infrastructure to serve those customers from a very local location. And the services that Azure is offering is ever increasing. As of now, as we speak, we have like 200 plus services offered, and they span through different domain or different platform or different technologies available within the Azure console portal. Now we're going to talk about that later in this section, so hold your breath till we talk about it. But for now, just know that we have like 200 plus services offered by Azure. Let's now talk about different services in Azure, starting with artificial intelligence plus machine learning, where we have a lot of tools and technologies. So the wide variety of services available in Azure includes artificial intelligence plus machine learning plus analytic services to get to give us a good visual of how the data or how the application is performing, or the type of the category of data stored, and to read from the logs. And variety of compute services, different VMs with different size and different operating systems, different containers available, different type of databases available, a lot of developer tools that are available for us, and identity service to manage our users in the Azure cloud. And those users can be integrated or federated with, let's say, Google, Facebook, LinkedIn. So there are some external federation services. They can be used to integrate with our identity system. IoT services, IoT tools and technologies available, and management tools to manage the users. Creating identity is one, and then managing them on top of it is a totally different thing. And we have tools, technologies to manage the users. Cool services for data migration. Data migration is now made simple. Tools and technologies available for mobile application development. And I can plan my own network in the cloud with the networking services. I can implement my own security, both Azure provided and third-party security services on Azure cloud. That's now possible. And a lot of storage options available in the cloud. So these are just a glimpse of the big list of services available in Azure cloud. So that was a glimpse of what's available in the cloud. Let's talk about the services in specific. Let's take compute for example. Whenever we're building a new application or deploying existing ones, the Azure Compute Service provides the infrastructure we need to run and maintain our application. We can easily tap in the capacity that Azure Cloud Service has, and we can scale our compute requirement on demand. We can also containerize our application. We have the option of choosing Windows or Linux VM machine and take the advantage of the flexible options Azure provides for us to migrate our VMs to Azure, and a lot more. And these compute services also include a full-fledged identity solution, meaning integration with Active Directory in the cloud or on-premises, and a lot more. Let's look at some of the services that this compute domain provides. Some of the services the compute domain provides are virtual machines. And this Azure Virtual Machines gives us the ability to develop and manage a virtual computer environment or a virtualized environment inside Azure's cloud environment, that too in a virtual private network. Now we will talk about virtual private network at a later point, but as of now, just know that there are a lot of services available in Azure Compute Service that we can get benefited from. we can always choose from a very wide range of compute options. For example, we have an option to choose the operating system. We have the option to choose whether the system should be in on-premises or in the cloud, or do we want to maintain the environment both in on-premises and in the cloud. We have the option of choosing the operating system, whether we want to use our own operating system with some software attached to it, or do we want to go and buy the operating system from the cloud, from Azure Marketplace. And these are just a few of the options available for us when we want to buy the compute environment. And these compute environments are easily scalable, meaning we can easily scale our VM instances from one instance to thousands of virtual machines in a matter of minutes, or simply put, in a couple of button clicks. And all these services are available on a pay for what we use model, meaning there is no upfront cost. We use the service and then pay for the services that we have used. There is no literal long-term commitment when it comes to using virtual machines in the cloud. And most of the services are built on a pay per minute billing basis. All right. And at no point, because of the pay per minute billing model, at no point we will be overpaying for any of the services. That's attractive, isn't it? Now let's talk about batch service. Now, batch service is always independent. Regardless of whether you choose Windows or Linux, it's going to run fairly well. And with batch service, we can take advantage of the environment's unique features. And not only that, in short, the batch service helps us to manage the whole batch environment, and also it helps to schedule the jobs. Now, this Azure batch service actually runs on a large scale parallel and high performance computing. Because of that, batch jobs are highly efficient in Azure. And when we run batch services, this Azure batch creates a pool of computer nodes and installs the needed applications that we want to run, and then it schedules jobs to those individual nodes in those pools. As a customer, there is no need for us to install a cluster, or there is no need for us to install a software that actually schedules the jobs, or even to manage or even to scale those infrastructure or the software, because everything is managed by Azure. And this batch service is a platform as a service. There is no additional charge for using this batch service, except for, the only charges that we'll be paying is for the virtual machines that the service uses, and the storage that we will be using, of course, and the networking services that we will be using for this batch service. Let's summarize. This batch service, we have a choice of operating system that we can pick and use, and it scales by itself. Now, the alternative for the batch would be queues, but in queues, we'll have to pre-provision and pay for the infrastructure even if we're not using it. But with a batch, we only pay for what we use. And this batch service helps us to manage the application, manage the scheduling as a whole, as if they are just one thing. As next thing in the compute domain, let's talk about this Fabric service. Now, this Fabric service is actually a distributed system platform that helps us to package, deploy, and manage a scalable and a very reliable microservice and containers. And what does it help? This Azure Fabric service helps us, or it helps the developers and administrators, so they can avoid the complex infrastructure problems, and they can focus only on implementing workloads or taking care of their development, taking care of their application instead of spending time on infrastructure. So what's Service Fabric? Service Fabric, it provides runtime capabilities and life cycle management to applications that are composed of microservices, no infrastructure management at all. And with Service Fabric, we can easily scale the application to tens or hundreds or even to thousands of machines. Here, machines represent containers. As next thing in compute domain, let's talk about virtual machine scale set. Now, this virtual machine scale set, it lets us to create a group of identical load balanced VMs. I just want to mention it again. It helps us to manage a group identical and load balanced VMs. The number of instances or the number of VM instances in a scale set can increase or decrease in response to the demand or in response to a schedule that we define. The resources needed on a Monday morning is not the same as that would be required on a Saturday or a Sunday morning. All right. And even within the day, the resources that would be needed in the beginning of the business hour is not the resources that would be needed at noon or, after 8 or 9 in the evening. So the demands could actually vary in the environment, and this skill set helps us to take care of the varying demand or take care of the different infrastructure requirement at a different schedule throughout the day, throughout the week, throughout the month, or could be throughout the year as well. The skill set also allows us to provide high availability to our applications, and it helps us to centrally manage, configure, and update a large number of VMs as if they are just one thing. Now you might ask, well, virtual machines are enough. Why would we need a virtual machine skill set? Just like I said, this virtual machine skill set helps us with a greater redundancy and improved performance for our applications. And those applications can be accessed through a load balancer that actually distributes the requests to the application instances. So in a nutshell, this virtual machine scale set, it helps us to create a large number of identical virtual machines, number one. And with scale set, we can increase or decrease the virtual machines. With virtual machine scale set, we can centrally manage and configure and update a big group of VMs. And it's a great use case when it comes to big data or container workloads. As next thing in compute domain, let's talk about cloud services. Now this Azure Cloud Service is actually a platform as a service, and it's very friendly. In fact, it is designed for applications that support scalability or an application that requires scalability or reliability, and on top of it, you want them to be very inexpensive to operate. So Azure Cloud Service provides all these. So where would this cloud service run? Well, it runs on a VM, but it's a platform as a service. VMs are infrastructure as a service, and when we run applications on VM through cloud service, it becomes platform as a service. So here is how you got to be thinking. With infrastructure as a service like VMs, we first create and configure the environment, and then we run applications on top of it. Let's look at the responsibility. The responsibility for us in VM is that we manage everything end to end, like deploying new patches, picking the versions of the operating system, and making sure they are intact and all that stuff. It's all managed by us. But on the contrary, with platform as a service, it's as if the environment is already ready. All that you have to do is deploy your application in it and manage the platform. Manage the platform not as an administrator, because all the administration is taken care by Azure, like deploying new versions of the operating system. It's all handled by the Azure. So we deploy the application and we manage the application. That's it. Infrastructure management is handled by Azure. So what does cloud service provide? This cloud service provides a platform where we can write the application code, and we don't have to worry about hardware. Simply hand over the code and cloud service takes care of it. So no worry on the hardware at all. So responsibilities like patching, what do we do if something crashes? How do I update the infrastructure? How do I manage the maintenance or the downtime in the underlying infrastructure? All that is handled by Azure. It also provides a good testing environment for us. We can simply run the code, test it before it's actually released to the production. I want to expand a bit on these testing applications. So this Azure Cloud Service, it actually gives us a staging environment for testing a new release without it affecting the existing release, which actually reduces the customer downtime. So we can run the application, test it, and anytime that's ready for production, all that's needed for us to do to move it to production is simply to swap the staging environment into the production environment, and the old production environment will now become the new staging environment, where we can add more to it and then swap it back at a later point. So it kind of gives us a swappable environment for testing our applications. And not only that, it gives us health monitoring alerts. It helps us to monitor the health and availability of our application. And there is a dashboard we can benefit from when we use Azure Cloud Services, and that shows the key statistics all in one place. And we can also set up real-time alerts to warn when a service availability or a certain metrics that we are concerned about degrades. As next thing in compute domain, let's talk about functions. Now, functions are serverless computing. Now, many times if you heard about Azure being serverless, a lot of time they are referencing, or the person who's talking to you is referencing to serverless computing or Azure Functions, which is a serverless computing service hosted on Microsoft Azure. The main motive of a function is to accelerate and simplify application development. Functions helps us to run code on demand without we need to pre-provision or manage any Azure infrastructure. So Azure Functions are script or a piece of code that gets run in response to an event that you want to handle. So in short, we can just write a code that you need for a problem at hand without actually worrying about the whole application or the infrastructure that will be running that code. And the best of all the best is when we use functions, we only pay for the time that our code runs. So what does functions provide, or what does Azure Functions provide? Azure Functions allow users to build applications using serverless simple functions with a programming language of our choice. So the current programming languages that are supported is C#, F#, Node.js, Java, and PHP. So here we really don't have to worry about provisioning or maintaining servers. If a code requires more resource, yes, Azure Functions handles or it provides the additional resources needed by the code. And the best part is we only pay for the amount of time the functions are running, not the resources, but the amount of time the function is running. As next thing, and moving to the new domain, let's talk about the container domain in Azure. Now the container domain or the container service, it allows us to quickly deploy a production ready Kubernetes or a Docker Swarm cluster. Now what's a container? A container is a standard unit of software that packages up code and all its dependencies so the applications run quickly and reliably from one computing environment to another. It could be testing to staging to development environment to staging to production, or from one production to another production, or on-premises to cloud, or one cloud to another cloud, vice versa. Now imagine we had an option not to worry about the VM and just focus on the application. Well, that's exactly what containers helps us achieve. So these container instances enable us to focus on applications and not worrying about managing VMs, or not worrying about learning the new tools required to manage the VMs or even the deployment. And our applications that we create, they run in a container. And running in a container is what helps us to achieve all these, not being able to manage or not needing to manage the virtual machines. So these containers, they can be deployed into the cloud using a single command if you're using a command line interface, and a couple of button clicks if we are using the Azure portal. And these containers are kept lightweight, but they are equally secure as virtual machines. Let's talk about container service as next thing. The container service, or sometimes called as Azure Kubernetes Service, it helps us to manage the containers. Container is one thing, and a service that's used to manage the container is another thing. Now this Kubernetes service, or ACS, it helps us to manage the containers. So let's expand on this a bit. So this Azure Container Service, or ACS, it actually provides a way to simplify the creation, configuration, and management of a cluster of virtual machines that are pre-configured to run containerized applications on top of them. Deploying these containers might take like 15 to 20 minutes, or deploying the virtual machines that run containers in it might take 15 to 20 minutes. And once they are provisioned, we can actually manage them by using simple SSH tunnel into them. And this ACS, when it runs applications from Docker images. What does that mean? Docker images makes sure that the applications the container runs are fully portable. Images are portable. And ACS also helps us to orchestrate the container environment. Not only that, it also helps us to ensure that these applications that we run in containers can be scaled to thousands or even tens of thousands of containers. So in a nutshell, managing an existing application into a container and running it using AKS or ACS is really easy, or that's what it is all about, to make the application management or migration easy. Now, managing the container-based architecture, and we discussed that containers could be tens or even tens of thousands of containers. So managing them is made simple using this container services. And even training of model using a large data set in a complex and resource intensive environment, this AKS helps us to simplify that environment. Alright, as next thing in container domain, let's talk about container registry. We spoke about registry a little bit when we spoke about Docker images. So container registry is a single place where we can store our images, which are Docker images. When we use containers, it's Docker images that we use for our image purposes. So these container images are a central registry that can be used to ease container development by easing the storage and management of container images. So there we can store all kind of images like Docker Swarm, or the images used in Docker Swarm are in Kubernetes. Everything can be stored in container registry in Azure. Now, anytime we store a container image, it provides us an option for geo replication. What that means is that we can efficiently manage a single registry replicated across multiple regions. Now, this geo replication, it actually enables us to manage global deployments, assuming we are having an environment that requires a global deployment. So it helps us to manage global deployments as one entity because we are geo-replicating. We would be updating, we would be editing one image, and that image gets replicated throughout the global replication centers we would have set up. And so just one editing would have actually edited the global images, and those global images would have provisioned the global application. So one edit, replication, and then provisioning of the applications global wide. And this replication also helps us network latency, because anytime an application needs to deploy, it does not have to rely on a single source which can be reached only through high latency network. Because we have global replications around the world, anytime the application wants to check back, it would check back the application which is in a very nearby location for the application itself. Global replication means that we are managing it as a single entity that's being replicated across the multiple regions in the globe. As next thing in our learning, let's talk about Azure databases. Now, these Azure databases are relational. In fact, they have many flavors in them. We're going to look at different flavors, SQL, NoSQL, cache type of database that Azure offers. So we're going to learn one at a time, or we're going to learn one by one. So this Azure SQL database is a relational database. In fact, it's a relational database as a service. It's managed by Azure. We don't get to do a lot of management in it. So it's a relational database as a service based on Microsoft SQL Server database engine. And this database is a high performance database. It is very reliable, and it's very secure as well. And this high reliability, high performance, and for this high security, we really don't have to do anything. It comes along with it, and it's managed by Azure. And there are two things that I definitely need to mention about Azure SQL database. That is, it's an intelligent service. Number one, it's fully managed by Azure, and it also has this one good thing, which is it has built-in intelligence that learns app patterns and adapts to maximize performance and reliability and data protection of the application. That's something that's not found in many of the other cloud providers that I'm aware of, so I thought I'll mention it. So it uses built-in intelligence to learn about the user's database patterns and helps improve performance and protection. And migration or importing data is very easy when it comes to Azure SQL database. So it can be readily or immediately used for analytic reporting and intelligent applications in Azure. As next thing, let's talk about Azure Cosmos DB. Now, Azure Cosmos DB is a database service that is for NoSQL type, and it's created to provide low latency and an application that scales dynamically or that scales rapidly. Now, this Azure Cosmos DB is a globally distributed service, and it's a multi-model database. This can be provisioned in a click of a button. That's all we got to do if we need to provision an Azure Cosmos DB in the Azure. It helps with scaling the database. We can elastically and independently scale throughput and storage across this database and in any of the Azure geographic regions. It provides a good throughput, it provides good latency, it provides good availability, and it provides, or Azure promises, a comprehensive SLA that no other database can offer. That's the best part about Cosmos DB. So this Cosmos DB was built with global distribution in mind, and it's built with the horizontal scale in mind. And all this we can use by only paying for what we have used. And remember, the difference between Azure Cosmos DB and the SQL database is that Azure Cosmos DB supports NoSQL, whereas SQL doesn't. Alright, few other things about Azure Cosmos DB is it allows users to use key value graph, a column, family, and document data. It also gives users a number of API options like SQL, JavaScript, MongoDB, and few others that you might want to check in the document at the time of reading. And the best part here is that all that we mentioned, we get to use only by paying for the amount of storage and throughput that are required. And the storage and the throughput can be elastically scaled based on the requirement of that R. Alright, let's talk about Redis Cache. Discussion about Azure database won't be complete without we talking about Redis Cache. Now, Redis Cache is a secure data cache. It's also sometimes called as messaging broker that provides high throughput and low latency access to data for the applications. Now, Redis Cache is based on a popular open source caching product, which is Redis, sometimes called as Redis Cache. Now, what's the use case? It's typically used to cache to improve the performance and scalability of a system that rely heavily on backend data stores. Now, performance when we use Redis Cache is improved by temporarily copying the frequently accessed data to a fast storage located very close to the application. Now, with Redis Cache, this fast storage is located in memory with Redis Cache instead of being loaded from the actual disk in the database itself. Now, this Redis Cache can also be used as an in-memory data structure store. Not only that, it can be used as a distributed non-relational database and a message broker. So there are a variety of use cases for this Redis Cache. And by using Redis Cache, the application performance is improved by taking advantage of the low latency and the high throughput performance that this Redis Cache engine provides. So to summarize, this Redis Cache, when we use Redis Cache, data is stored in the memory instead of the disk to ensure that there is high throughput and low latency when the application needs to read the data. It provides various levels of scaling without any downtime or interference. Now, this Redis Cache is actually backed by Redis server, and it supports string, hashes, linked list, and various other data structures. Now let's talk about security and identity services. Now, identity management in specific is a process of authenticating first and then authorizing using security principles. Now, not only that, identity management involves controlling information about those principal identities. You might ask, now what's a principal identity? Now, identity or principal identity are services, applications, users, groups, and a lot more. The speciality about this identity management is that it not only helps authenticate and authorize principals in cloud, it also helps authenticate and authorize principals or resources on premises, especially when you run an hybrid cloud environment. So all these services and features that this identity management helps us to get additional level of validation, like identity management can provide multi-factor authentication. It can provide access policies based on condition, a permit or deny based on condition. It can also monitor suspicious activity, and not only that, it can also report it. It can also help generate alerts for potential security issues, and in a way to mitigate it, can send us an alert so we can get involved and prevent a security accident from happening. So let's talk more about identity management. So some of the services under security and identity management are Azure Security Center. Now, this Azure Security Center provides security management and threat protection across the workloads in both cloud and in the hybrid environment. It helps control user access and application control to stop any malicious activity if present. It helps us to find and fix vulnerabilities before they can be even exploited. It integrates very well with analytic methods that helps us to identify, or it gives us the intelligence to identify or detect attacks and prevent them before it can actually happen. And it also works seamlessly with hybrid environments. So you don't have to have one policy for on-premises and one policy for the cloud. It's now a unified service, both for on-premises and the cloud. The next service in security and identity would be Key Vault. Now, a Key Vault is a service or a feature that helps safeguard the cryptographic keys and any other secrets used by the cloud applications and the services. In other words, this Azure Key Vault is a tool for securely storing and accessing the secrets of the environment, the secret keys. Now, a secret is anything that you really want to have a very tight control access, like the certificates, like the passwords, stuff like that. Now, if I tell you what Key Vault actually solves, that would actually explain what Key Vault is. Now, Key Vault is used in secrets management. It's helped in securely storing the tokens, the passwords, the certificates. It helps in key management. It really helps in creating and controlling the encryption keys that we would use to encrypt data. It helps in certificate management. Talking about certification management, it helps us to easily provision, manage, and deploy public and private SSL, TLS certificates in Azure, and a lot more. So in a nutshell, this Key Vault, it provides users the ability to provision new vaults and keys in just a matter of minutes. All that in a single command, or all that in a couple of button clicks. It also helps users to centrally manage their keys, secrets, and policies. Next in the list, let's talk about Azure Active Directory. Now, Azure Active Directory, it helps us to create intelligent-driven access policies to limit resource usage and manage user identities. What does that mean? Now, this Azure Active Directory is a cloud-based Active Directory and identity management service. Now, Azure Active Directory combines, it's actually a combination of the core directory services plus application access management plus identity protection. And one good thing about this Azure, in fact, there are a lot of good things, but especially when you're running hybrid environments, you might wonder, well, how this Azure Active Directory is going to behave. Now, this Azure Active Directory is built to work on-premises and cloud environment as well. Not only that, it also works seamlessly with mobile applications as well. So in a nutshell, this Azure Active Directory, it acts as an central point of identity and access management for our cloud environment. It also provides good security solutions that protect against unauthorized access of our app and the data. Now that we've discussed about security and identity, let's talk about the management tools that Azure has to offer. Azure provides built-in management and account governance tools that helps administrators and developers, that helps them to keep their resources secure and very compliant. And again, it helps both in on-premises and in the cloud environment. And these management tools help us to monitor the infrastructure, monitor the applications. It also helps in provisioning and configuring resources. It also helps in updating apps. It helps in analyzing threats, taking backup of the resources, build disaster recoveries. It also helps in applying policies and conditions to automate our environment. We use Azure management tools, and it's also used in cost control methods. So this Azure management plays a wide role across the Azure services. And in the management tools, first comes the Azure Advisor. Now this Azure Advisor, it acts as a guide to educate us about Azure best practices. It throws recommendations that we can select on the basis of the category of service and it also provides the impact it can have, or the impact that would happen in our environment if we follow the recommendations given. And recommendations are, first one is the recommendations are kind of templatized, and it throws the templatized recommendations. Not only that, it also provides customized recommendations on the basis of the configuration, on the basis of our usage patterns. And these recommendations are not hard. It's not like something that it recommends and then just leaves us hanging there. These recommendations provided are very easy to follow, very easy to implement and see results. You can think of Azure Advisor as a very personalized cloud consultant that helps you to follow best practices to optimize our deployments. It kind of analyzes our resources, our configurations, our usage, and then it recommends a solution for us that really helps in improving the cost effectiveness, improving the performance, improving high availability, and improving security in our Azure environment. So with this Azure Advisor, we can get a proactive, actionable, and personalized best practice recommendations. Now, you don't have to be an expert. Just follow the Azure Advisor and your environment is going to be good. It also helps in improve the performance, security, high availability of our environment. And also it helps in bringing down the overall Azure spend. And the best part is it's a free service that analyzes our Azure usage and provides recommendations, how we can optimize our Azure resource to reduce cost. And reduce cost at the same time boost the performance, helps in strengthening the security and improve the overall reliability of our environment. Next in the list would be Network Watcher. Now, this Network Watcher helps users identify and gain insights in the overall network performance and the health of the overall environment. Now, these Azure Watchers provides enough tools to monitor, to diagnose, to view the metrics, and to enable or disable logs, which means to generate and collect the logs for resources in the Azure Virtual Network. So with Network Watcher, you can monitor and diagnose issues in networking without even logging into the virtual machines. With just the logs, which are real time, we can actually come to a conclusion what could be wrong in a certain resource, in a VM or in a database, by just looking at the logs. And not only that, it's used for analytic or to gain some intelligence of what's happening in our network. We can gain a lot of insight to the current network traffic pattern using the security group flow logs that this Network Watcher offers. It also helps in investigating VPN connectivity issues using detailed logs. Now, you might or might not know that VPN troubleshooting requires both parties, or it involves two parties. The person, the network administrator on this side and the network administrator on the other side. And they will have to check logs in their end, and we'll have to check logs in our end, stuff like that. But with the Network Watcher, it kind of takes it to the next level. The logs itself, we could easily identify which side is having the issue and suggest an appropriate fix. And the next in the list would be Microsoft Azure Portal. Now, this Microsoft Azure Portal, it provides a single unified console to perform various number of activities like building, not only building, managing and monitoring the web applications that we build. Now, this portal can be used to organize our environment or the appearance of the environment or the visual of the environment based on our work style. And using Azure Portal, users can control who gets to manage or access the resources, all from the Azure Portal. And this Azure Portal gives a very good visibility on the spends that happen on each resource, right? And if we can customize it, we can also identify spends based on team, spends based on days, spends based on department, stuff like that. So it kind of gives us a good visual of where the money is spending or where is the bill consumed within the Azure environment. Next in the list would be Azure Resource Manager. Now, Azure Resource Manager enables us to manage the usage of the application resources. Now, we use Resource Manager to deploy, monitor, and manage solution resources as a group, as if it's one single entity. Now, the infrastructure of our application is typically made of various components, which includes virtual machine, storage, virtual network, web app, database servers, some other third-party services that we might use in our environment. And they are, by nature, separate services. But with Azure Resource Manager, we don't see them as different components or different entities. Instead, we see them as related services in a group that supports an application. Now we kind of get the relation between them. Instead of letting them spread, Azure Resource Manager identifies the relation between them and helps us to visually see them all as one or single entity. Not only that, Azure Resource Manager helps, or it ensures that the resources that we provision are deployed at a constant rate along with the other application. It also helps users to visually see their resources and how they are connected, and that helps in managing the resources a lot better. Resource group also is used to control who can access the resources within the user's organization. Kind of gives you the fine-grained control over who gets to access and who does not get access. And the last one in the management tools would be automation. And this automation gives us the ability to automate, configure, and install upgrades across hybrid environments. It provides a cloud-based automation and configuration service. Not only that, this can be applied for non-Azure environments as well, which is on-premises. So some of the automation we could do is process automation, update management automation, configuration features automation, stuff like that. And this Azure automation provides complete control during the deployment, operation, and also during the decommissioning of the workloads and resources. With automation, we can actually automate time-consuming or mundane or any task that's error-prone because of human errors. Those things can be automated. So irrespective of how many times you run it, it's going to run the same way. And that really helps in reducing the overall time and also the overhead cost, because a lot of the things are automated, which means it's human error-free, which means the application is not going to break and keep running for a longer time. With automation, we can actually build a good inventory of operating system resources and configuration items all in one place with ease. And this really helps in tracking the changes and investigating the issue. Let's say something happened. Because we have automation, because it's logging the configuration changes, it's easy to track, easy to identify what has changed lately that has broken the environment, go back and fix it or kind of roll it back. That solves the problem. And that actually summarizes the Azure management tools or management services. Now let's talk about the networking tools or the networking services available in Azure. There are a variety of services, especially networking services, that Azure offers, and I'm sure it's going to be an interesting one. Let's begin our discussion with Content Delivery Network. Now, the Content Delivery Network, in short, CDN, it allows us to perform secure and a very reliable content delivery. Not only that, it also helps in accelerating the delivery time, or in other words, reducing the delivery time, also called as load times. It also helps in saving bandwidth and increases in responsiveness to the application. Let's expand on this. The Content Delivery Network is actually a distributed network of servers that can efficiently deliver web content to users. Now, CDNs, we're going to use the word CDN here. CDNs store cached content on global edge servers, also called as POPs, point of presence locations, that are very close to the end users, so the latency is minimized. It's like taking a copy of the data or taking a multiple copy of the data and storing it in different parts of the world, and whoever is requesting it, the data gets delivered to them from a server which is very locally to them. So this CDN offers developers a global solution for rapidly delivering high bandwidth content to users by caching the content in a strategically placed location which is very near to them. So these content delivery networks, it really helps in handling That's one advantage you get for content delivery network. That's we can handle spikes and heavy loads very efficiently. And we can also run analytic against the logs that gets generated in content delivery network, which helps in gaining good insight on the workflow and what would be the future business need for that application. And this, just like a lot of other services, this is on a pay-as-you-go type. So you use the resource first and then you only pay for what you have used. The next one in networking would be ExpressRoute. Now, ExpressRoute is actually a circuit or a link that provides a direct private connection to Azure. And because it's direct, it gives low latency link to Azure. It gives good speed and reliability for the Azure data transfer. It could be on-premises to Azure. So it gives very good speed. It gives increased reliability and low latency for that connection. Let's expand on this a bit. Now, this ExpressRoute is a service that actually provides a private connection between Microsoft data center and infrastructure in our premises or in a different co-location facility that we might have. Now, these ExpressRoutes do not go over the public internet. And because they don't go over the public internet, they offer a high security, reliability, and speed and low latency compared to the connections which are in the internet. Because it's fast, because it's reliable, because it has low latency, it can be used as an extension of our existing data center. Users are not going to feel the difference whether they are accessing services from an on-premises or in the cloud environment, because latency is minimized as much as possible. Users are really not going to see the difference. And because it's a private line and not a public internet line, it can be used to build hybrid applications without compromising privacy or the performance. Now, these virtual private cloud, these ExpressRoutes can be used for taking backups. If assume a backup going through the internet, that would be a nightmare. If you use ExpressRoute for backups, that's going to be fast. And imagine recovering a data through the internet, from the cloud, through the internet, to the on-premises in a time of disaster. That would be the worst nightmare. So these ExpressRoutes can be used not only to backup, but also to recover the data. Because it provides good speed, low latency, recovering the data is going to be a lot sooner. The next product or service we're going to discuss in networking is Azure DNS. Now, Azure DNS allows us to host domain name in Azure, and these domain names come with an exceptional performance and availability. Now, Azure DNS is used to set up and manage DNS zones and records for our domain name in the cloud. Now, this Azure DNS is a service for DNS, just like the name says, and it provides name resolution by using Azure's infrastructure. And by using this domain, we can actually manage the DNS ourselves through the Azure portal with the same credential. Imagine having a DNS provider which does not even belong in our IT. Imagine that environment. We would have a separate portal to manage the DNS environment. Now, those are gone. And now we can actually manage the DNS in the very same Azure portal where we use the rest of the other services. And this Azure DNS very much integrates with other DNS service providers. It uses a global network of name servers to provide fast response to DNS queries. And these domains are having additional availability compared to the other domain service providers' availability promises. These are going to have more availability than the rest because most of the servers are maintained by Microsoft, and it helps resolve sooner. It helps resyncing. Let's say a server fails, it kind of helps resyncing with the rest of the servers. So all the Microsoft's environment, all the Microsoft's global network of name servers kind of ensures that our domain names are resolved properly, not only properly, but also are available most of the time. Right, next in the list in networking services is virtual network. I'm sure this is going to be very interesting and I'm sure you're going to like it. So this networking or virtual networking in Azure, it actually allows us to set up our own private cloud in the public cloud. It gives us an isolated and highly secure environment for our application. Let's expand on this. So this Azure Virtual Network helps us to provision Azure virtual machines, and it helps us to securely communicate with other on-premises and internet networks. It also helps in controlling the traffic that flows through or flows in and out of this virtual network to other virtual networks and to the internet. Now this Azure virtual network, sometimes called as VNet, is actually a representation of our own network in the cloud. It's actually a logical isolation of the Azure cloud dedicated to our subscription. All our environments are provisioned in a VNet that is separate from another customer's VNets. That way we have that logical separation there. So this virtual network can also be used to provision VPNs in the cloud, so we can connect the cloud and the on-premises infrastructure and a lot more, especially in an environment where we have hybrid environment. Surely we will be using virtual network because that's going to require a VPN for secure data transfer in and out of the cloud and in and out of the on-premises environment. Alright, so it kind of gives us an boundary for all the resources. So all the traffic between the Azure resources, they kind of logically stay in between or logically stay within the Azure virtual network. And here we can design the network. It's given over to us. You can pick the IP, you can pick the routing, you can pick the subnet. A lot of freedom is given, or I would say a lot of control on how the network is designed. It's not like something that's already cooked and we only get to use it. No, we can actually build the network from the scratch. We can pick the IP address that we like. We can pick which subnet needs to communicate with the other subnet, stuff like that. And like I said, if you are using hybrid environment, you definitely would be requiring a virtual network because it helps connect the on-premises and the cloud in a secure fashion using VPN. The last product we're going to discuss in networking is a load balancer. This load balancer actually provides application a good availability and a good network performance. So how does it work? It actually works by load balancing the traffic to and from the virtual machine and the cloud resources. Not only that, it also load balances between cloud and cross-premises virtual networks. With Azure Load Balancer, we can actually scale our application and create high availability for our services, which means our application will be available most of the time. If any of the server goes dead, the server does not get traffic. What happens if the server gets traffic? User is going to experience downtime. What happens if the server does not get traffic? User won't experience any downtime. The connection is shifted to an healthy service, so the user experiences uptime all the time. So this load balancer supports inbound and outbound scenarios, and it provides low latency. It gives high throughput of the data transfer, and we can actually scale up the flow of the TCP and UDP connections from hundreds to thousands to even millions because we have a load balancer now in between the user and the application. So how does it operate? This load balancer actually receives the traffic and it load balances the traffic to the backend pool of instances connected to it according to the rule and the health probe that we set. That's how it maintains high availability. So what does load balancer help? It helps in creation of high available scalable application in the cloud in minutes. It can be used to automatically scale the environment with the increasing application traffic. And one feature of load balancer is to check the health of the user's application instance, and it removes or it stops sending the request to the unhealthy instance and kind of shifts that connection to the healthy instance. That way a user or a connection does not get stuck with an instance that's not healthy. That's all that you need to know about the networking services. Now let's talk about the storage services or the storage domain in Azure. Now Azure Storage in general is a Microsoft managed service providing cloud storage, which basically is highly available, secure, durable, scalable, and redundant because it's all managed by Azure. We don't don't get to manage a lot of it. And these Azure storages are a group of storage services. They cater different needs. And the storage products include Azure Blobs, which is actually an object storage. It includes Azure Data Lake. It includes Azure Files. As you see, it includes Azure Queues. It includes Azure Tables and a lot more. But let's start our discussion with Azure Store Simple. Azure Store Simple is an hybrid cloud storage solution that actually lowers the cost of storage to nearly 60% of how much you would be actually spending without using it. So Azure Simple Storage or Store Simple is an integrated storage solution that manages the storage task between on-premises and the cloud storage. What I really like about Azure is that it's built around a hybrid environment in mind. There are a lot of other cloud providers that are there where running an hybrid environment is a big challenge. It has some compatibility. You won't be able to find an hybrid or a on-premises and cloud solution for your need, stuff like that. But with Azure, especially when it comes to storage, a lot of the things that we're going to see, it clearly is designed with hybrid environment in mind. All right, so let's come back and talk about Store Simple. So Store Simple is a very efficient, cost-effective, and a very easily manageable SAN, storage area networking solution in the cloud. I thought I'll throw in this information. The reason why it got Store Simple is really because it uses Store Simple 8000 series devices which are used in Azure Data Center. And this Store Simple or Simple Storage, it comes along with storage tiering to manage the stored data across the various storage media. So the very current data is actually stored in on-premises on solid-state drives. And data that is used less frequently is stored in HDDs or hard disk drives. And the data that requires archived or that needs to be archived, very old data, let's say less frequently used data, candidate for archive, they are actually pushed to the cloud. So you see how this storage tiering automatically happens in Store Simple. And another cool feature of Store Simple is that it enables us to create an on-demand and scheduled backups of data and then store the data locally or in the cloud. And these backups are actually taken in the form of incremental snapshot, which means that they can be created and restored quickly. It's not a complete backup, it's an incremental backup. And these cloud snapshots, they can be critically important when there is a disaster and when there is a disaster recovery scenario, because these snapshots can be called in and they can be put on storage systems and then they become the actual data. So recovering is faster if you have proper scheduled backups or if you have frequent backups. And this Storage Simple, it really helps in easing our backup mechanism, which means it kind of eases our disaster recovery steps or procedures as well. So this Store Simple, it can be used to automate data management, data migration, data movement, data tiering across the enterprise, both in cloud and on premises. It actually improves the compliance and accelerates the disaster recovery for our environment. And if there is one thing that's increasing every new day in our environment, that would be storage. And this Store Simple addresses that need, and we really don't have to pre-plan or think in deep for having a proper storage, because now we have a simple storage available in the cloud, and moreover it's on a pay-as-you-go type. So not much pre-planning on storage is needed. Yes, there will be a need, but not as much as I would without the cloud or without the simple storage. And the next service under storage that we would like to discuss is the Data Lake Store. This Data Lake Store or storage, it's a cost-effective solution for big data analytics in specific. So let's expand this. So this Data Lake Storage is an enterprise-wide repository for big data analytic workload. Now that's the major service that's dependent on this Data Lake Store. And this Data Lake enables us to capture data of any size, of any type, and of any ingestion speed, and it kind of collects them in one single space or in one single place for operational efficiency. Operational efficiency and for analytic purpose. Hadoop in Azure is very dependent on this Data Lake Storage. And this Data Lake Store is designed with performance for analytics in mind. So anytime you think of, or anytime you're using analytic in the cloud, or anytime you're using Hadoop in the cloud in Azure, we are definitely using, or we will be to the most part, or the normal procedure, or the right storage to pick would be data lake store in Azure. It's designed with security in mind. So anytime we use Azure storage, we can be rest assured that we are using storage from within a data center which has, or which was built with security in mind. So this data store also uses Azure Blob storage behind the scenes for global scale, durability, and for performance. Let's talk about blob storage. Now, blob storage provides large amount of storage and scalability. Now, this blob storage is the object storage solution for Azure Cloud. Let's expand a bit on blob storage. Azure Blob Storage is Microsoft offering for object storage. Now, this blob storage is optimized for storing massive amount of unstructured data, which could be text or binary data. It's designed and it's optimized for rapid reads. If I explain to you on what scenarios we would be using blob storage, that might help you get a good understanding of what blob storage is. So it's designed, as of now it's being used in many IT environments to serve images or documents directly to the browser. It helps in storing files for distributed access. A lot of fetchers can fetch data from Azure Blob Storage. And it's currently helping users stream video and audio. It's currently being used for writing log files. It's currently being used to store data as backup and restore at a later point in times of disaster recovery. It also is used as an archiving storage in a lot of cloud IT environments. It's widely used in storing analytic data, not only storing but also running analytic query against the data stored in it. So that's a wide use case for blob storage. Not only that, in addition to all that we mentioned, it also supports versioning. So anytime somebody updates an data, a new version gets created, which means at any point I can roll back as and when needed. And it provides a lot of flexibility on optimizing the user's storage need. It also supports tiering of the data. So based on need, when I actually explore, I would find a lot of options I can pick from that suits to my unique storage environment or unique storage need. And like I said, it stores unstructured data, and this unstructured data is available for customers through REST-based object storage environment. The next product and storage service would be queue storage. Now, queue storage provides durable queues for large volume cloud services. It's a very simple and a cost-effective, durable messaging queue for large workloads. Let's expand this queue storage for a moment. Now, this queue storage is a service for storing large amount of messages that can be accessed from anywhere in the world through HTTP and HTTPS calls. A single queue or a single queue message can be up to like 24 KB in size, and a single queue can contain millions of such 24 KB in size messages. And how much can it hold? It can hold up to the total capacity of the storage account itself. So that's kind of easy to translate. How much would it hold? And this Azure Queue Storage, it provides an messaging solution between applications and components in the cloud. What does it help? It helps in designing an application for scale. It helps in decoupling the application, so it's not very dependent, or sometimes it's not at all dependent on the other application, because now we have a queue in between which kind of translates, or which kind of connects, or which kind of decouples both the environment. Now we have a queue in between, both the environment can scale up or scale down independently. The next in the storage service would be file storage. Let's talk about file storage. Now, these Azure files provide secure, simple, and managed cloud file shares. Now, with file share in the cloud, it actually extends the user server's on-premises performance and capacity. And a lot of familiar tools for the cloud file share management can be used along with the file storage that we're talking about. So let's expand a bit on file storage. Now, this Azure Files or Azure File Storage offers a fully managed file shares in the cloud that can be accessed via the SMB protocol. So server message block protocol. Now this Azure file shares can be mounted concurrently by cloud or in on-premises deployments. A lot of operating systems are compatible with it. Windows are compatible, Linux is compatible, Mac OS is compatible. In addition to all this being able to run on-premises and on the cloud, or being able to access from on-premises and on the cloud, it can also offer cache for caching the data and keeping it locally so it's immediately available when needed. So that's some additional feature, I would say that's some advanced feature that it offers compared to the other file shares available in the market. Let's talk about table storage. Now, table storage is a NoSQL key value pair storage for quick deployments with large semi-structured data sets. The difference between one important thing to note with table storage is that it has a flexible data schema and also it's highly available. Let's expand a bit on table storage. So anytime you want to pick a schema-less a NoSQL type table storage is the one we'll end up picking. It provides an key pair attribute storage with a schema-less design. This table storage is very fast and very cost effective for many of the applications, and for the same amount of data it's a lot cheaper when you compare it with the traditional SQL data or data storage. So some of the things that we can store in the table storage are, of course, they're going to be flexible data sheets such as user data for web application, address books, device information, and other types of metadata for our service requirements. And it can have any number of tables up to the capacity limit of the storage account. Now this is not possible with SQL. This is only possible with NoSQL, especially with table storage in Azure. Explanation of storage really concluded the length and breadth of the explanation this CEO was giving his IT personnel. But this IT personnel is not done with it yet. He still has a question even after this lengthy discussion, and his question was, well, there are a lot of other cloud providers available. What made you specifically choose Azure? I mean, from the kind of question that he asked, we can say that he is very curious, and he definitely had asked a very thoughtful question. So his CEO went on and started to explain about the other capabilities of Azure, or how it kind of outruns the rest of the cloud providers. So he started, or he again started his discussion, but from a different angle now. So he started to explain what are the capabilities or how Azure is better than the competitors. So he started with explaining the platform as a service capabilities. And I'm going to tell you what the CEO told his IT person. So this platform as a service, or in platform as a service, the infrastructure management is completely taken care by Microsoft, allowing users to focus completely on the innovation. No more infrastructure management responsibilities. Go and focus on innovation. That's a fancy way of saying it. When we buy platform as a service, that's what we get. We can contribute our time on innovation and not just maintaining the infrastructure. And Azure especially is .NET friendly. Azure supports the .NET programming language, and it has, or it is built or designed, or it is optimized to work with old and new applications deployed using .NET programming framework. So if your application is .NET, most of the time you would end up picking Azure. I mean, if you try to compare, most of the time you would end up picking Azure as your cloud service provider. And the security offerings that Azure offers is it's designed based on the security development lifecycle, which is an industry-leading assurance process. When we buy services from Azure, it assures that the environment is designed based on security development lifecycle. And like I mentioned many times in the past, and I would like to mention it again, Azure has well thought about the hybrid environments, which a lot of other cloud providers have failed. So it's very easy to set up an hybrid environment, to migrate the data or not to migrate the data and still run a hybrid environment. They work seamlessly with Azure, because Azure provides seamless connection across on-premises data centers and the public cloud. It also has a very gentle learning curve. If you look at the documentation, it's picture rich, and the documentations are neat and clear. It would encourage you to learn more. It would encourage you to think and imagine and try easily get a grasp of how services work. So it has a very gentle learning curve. Azure allows the utilization of technologies that several businesses have used for years. So there is a big history behind it. It has a very gentle learning curve. The certifications, the documentations, the stage-by-stage certification levels, it's all very gentle learning curve, which is generally missing in other cloud service providers. Now, this would really impress the CTOs or people working in finance and budgeting. If an organization is already using Microsoft software, they can definitely go and avail or be bold and ask for a discount that can reduce the overall Azure spending. In other words, overall pricing of the Azure. So that's what helped, or they are the information that helped the CEO pick Azure as his cloud service provider. And then the CEO goes on and talks about the different companies that are currently using Azure, and they are definitely using Azure for a reason, like Pixar, Boeing, Samsung, EasyJet, Xerox, BMW, 3M. They are major multinational, multi-billion companies. They rely, run, operate their IT in Azure. And this CEO has a thought that his IT person is still not very convinced unless and until he shows him a visual of how easy things are in Azure. So he goes on and explains about a practical application of Azure, which is what exactly I'm going to show you as well. All right, a quick project on building an Azure app using, or building a .NET application in Azure Web App and making it connect to an SQL database will solidify all the knowledge that we have gained so far. So this is what we're going to do. I have an Azure account open, as you see, logged in, and everything is fresh here. Let me go to resource group. There's nothing in there. It's kind of fresh. All right, I'm logged in, and this is what we're going to do. So we're going to create an application like this, which is nothing but an to-do application, a to-do list application, which is going to run from the web app, get information from us, and save it in the database that's connected to it. So you can already see it's a two-tier application, web and DB. All right. So let me go back to my Azure account. The first thing is to create an resource group. Let's give it a meaningful name. Let's call it Azure Simplilearn. All right. And it's going to be a free trial. And the location, pick one that's nearest to you, or wherever you want to launch your application. Now for this use case, I'm going to pick Central US and create. It's going to take a while to get created. There you go. It's created. It's called Azure Simplilearn. Now what do we need? We need an web app and a separate SQL database. Let's first get our web app running. So go to App Services and then click on Add. It's not the web app plus SQL that we want. We want web app alone for this example. So let's create an web app. Give it a quick name. Let's call it Azure Simplilearn. The subscription is free trial, and I'm going to use my existing resource group, a resource group that we created some time back. It's going to run out of Windows, and we're going to publish the code. All set, we can create it. All right, while this is running, let me create my database. All right, SQL database, create a database. Give it a name. Let's call it Azure Simplilearn DB. Put it in our existing resource group that we created. It's going to be a blank database, all right? And it's going to require some settings like the name of the server and the admin login, the password that goes along, and in which location this is going to be created. The server name is going to be Azure Simplilearn DB. That's the server name. And the admin login can be, what can be the admin login name? Let's see. So let's call it Simplilearn. That's my admin login name. And let me pick a password. Click on create. So what have we done so far? We have created an web app and we have created a database in the resource group that we have created. So if I go to resource group, it's going to take some time before things show up. So if I go to my resource group, I only have one resource group as of now, Azure Simplilearn, and there I have a bunch of resources being created. It's still being created. Right. In the meantime, I have my application right here that's running out of or that's in Visual Studio as of now. Right. So once the infrastructure is set and ready in the Azure console, we're going to go back to Visual Studio, feed these inputs in the Visual Studio so the code knows what the database is, the credentials to log into the database, stuff like that. So we're going to feed those information in Visual Studio. By that, we're actually feeding it into the application, and then we're going to run it from there. Deploying this application takes quite a while. We really got to be patient. Right, now we have all the resources that we need for the application to run. Here's my database, and here's my app service. There's one more thing we need to do, that is create an firewall exception rule. So one more thing needed is to create an firewall exception rule, right? So the application is going to run from my local desktop, and it's going to connect to the database, right? So let's add an exception rule by simply adding the client IP. It's going to pick my IP, the IP of the laptop I'm using as of now, and it's going to create an exception to access the database. So that's done. Now we can go back to our Visual Studio. I already have a couple of apps running, or a couple of configurations pushed from Visual Studio. I'm going to clean that up. If you're doing it for the first time, you may not need to do this. Alright, so let's start from the scratch. This is very similar to how you would be doing in your environment. Alright, so we're going to select an existing Azure app service. Now before that, I have logged in. As you can see, I have logged in with my credentials. So it's going to pull few things automatically from my Azure account. So in this case, I'm going to use an existing Azure app. So select existing and then click on publish. Alright, if you recall, these are the very same resources that we created a while back. Right, we have clicked on save, and it's running, kind of validating the code, and it's going to come up with an URL. Now initially the URL is not going to work because we haven't mapped the application to the database. So that would be the next thing. Alright, so the app has been published and it's running from my web app as of now. It's going to throw an error. Like you see, it's throwing an error. That's because we haven't mapped the app and the DB together. So let's do that. Alright, let's do that. So let's go to Server Explorer. This is where we're going to see our databases that we have created. Now let's quickly verify that. Go back to the resource group, right? Appropriate resource group, which is right here. And here I have my database, Azure SimplilearN database. Right, it has some issues connecting to my database. Give me a quick moment. Let's fix it. All right, so we'll have to map the database into this application. All right, so let's go to the Solution Explorer, click on Publish, and a page like this gets shown. And from here, we can go to Configure. Here is our web app, all right, with all its credentials. Let's validate the connection, number 1. All right, and then click on Next. This is my DB connection string, right, which the app is going to use to connect to my DB. Now, if you recall, our DB was Azure SimplilearnDB, and that's not being shown here. So let's fix that. Right, so let's fix that. Click on Configure, and here let's put our DB servers URL. Now before that, let's change this to SQL Server. All right, and then in here put the DB's URL. So go back to Azure. Here is my DB or server's name. Put that here. Right, the username to connect to the server, that's right here. Put that in, and the password to connect to the server, let's put that in. All right, it's trying to connect to our Azure portal or the Azure infrastructure, and here is my database. If you recall, it's Azure SLDB. That's the name of the database. Let's test the connection. Connection is good. Click on OK. So now it's showing up correctly. Azure SimplilearnDB, that's the name of the database that we created. Now it's configured. All right, let's modify the data connections. Right, let's map it to the appropriate database again. All right, so our name of the database is Azure SimplilearnDB, and then it's going to be SQL Server. That's the data source. The username is SimpliLearn, and the password is what we have given in the beginning. All right, let's validate the connection. It's good. Click OK. Now we're all set and ready to publish our application again. Now the application knows how to connect to the database. We have educated it with the correct connection strings, the DNS name, the username, and the password for the application to connect to the database. So Visual Studio is building this project, and once it is up and running, we'll be prompted with an URL to connect, and anytime we put or we give inputs to the URL, that's going to receive the input and save it in the database. Alright, so here is my to-do list app, and I can start creating to-do list for myself. All right, so I have the items already listed. I can create an entry, and these entries get stored in the database. I can create another entry. Take the dog for a walk. That's gonna get stored. I can create another entry. Book tickets for a scientific exhibition, and that's going to receive and put that in the database. And that concludes our session. So through this session we saw how I can use Azure services to create a web app and connect that to the DB instance, and how those two services which are decoupled by default, which are separate by default, how I can use the connection strings to make connection between the app server and the database and be able to create an working app.
Let's now take a look at some individual features of S3, starting off with lifecycle management. So lifecycle management is very interesting because it allows us to come up with a predefined rule that will help us automate the transitioning of objects from one storage class to another without us having to manually copy things over. Of course, you could imagine how time-consuming that would be if we had to do this manually. So we're going to see this very soon in a lab. However, let me discuss how this works. So once it's basically a graphical user interface. It's very, very simple to use once you come up with these lifecycle management rules. But you're going to define two things. You're going to define the transition action and the expiration action. So the transition action is going to be something like, well, I want to transition an object from, maybe it's all objects, or maybe it's just a specific type of object in a folder, example, that has a specific prefix, from one storage class, let's say standard, to standard inactive or infrequent access. Maybe only after 45 days, after at least a minimum of 30 days like we spoke of before. And then maybe after 90 days, you want to transition the objects in IA to right away Glacier Deep Archive, or 180 days. You come up with whatever combination you see fit. Okay, it doesn't have to be sequential from S3 to IA to one zone, etc., because like we discussed before, it depends what kind of objects that you're interested in putting in one zone, objects that you don't really mind losing if that one availability zone goes down. So you're going to be deciding those rules. It ends up that this even is not a simple task because you have to monitor your usage patterns to see which data is hot, which data is cold, and what's the best kind of lifecycle management to implement to reap the benefits of the lowest cost. So you have to put somebody on this job and make the best informed decisions based on your access patterns, and that is something that you need to consistently monitor. So what we can do is we can instead opt for something called S3 Intelligent Tiering, which basically analyzes your workload using machine learning algorithms. And after about a good 30 days of analyzing your access patterns, we'll automatically be able to transition your objects from S3 standard to S3 standard infrequent access. Okay, it doesn't go past the IA one, it doesn't go after the Glacier and whatnot. Okay, so it can then offer you that at a reduced price overhead. So there is a monitoring fee that is introduced in order to implement this feature. It's a very nominal, very, very low monitoring fee. And the nice thing is if ever you take out an object out of the infrequent access before the 30-day limit, as we spoke of before, you will not be charged an overhead charge because of that. Why? Because you're using the intelligent tiering. You're already paying an overhead for the monitoring fee. So at least in that sense, the intelligent tiering will take the object out of IA and put it back into the S3 standard class if you need access to it before the 30 days. And in that case, you won't be charged that overhead. So that is something that is very that is very good to do in order not to have to put somebody on that job. So yes, you're paying a little bit of overhead for that monitoring fee, but at the other side of the spectrum, you're not investing in somebody working many hours to monitor and put into place a system to monitor your data access patterns. So let's take a look at how to do this right now. Let's implement our own lifecycle management rules. So let's now create a lifecycle rule inside our bucket. First off, we're going to need to go to the management tab in the bucket that we just created. And right on the top, you see right away, lifecycle rule. We're going to create lifecycle rule and we're going to name it. So I'm just going to say something very simple, like simply learn lifecycle rule. And we have the option of creating this rule for every single object in the bucket, or we can limit the scope to a certain type of file, perhaps with a prefix like, I could see one right now, something like logs. So anything that we categorize as a log file will transition from one storage tier to the next as per our instructions. We're doing this because we really want to save on costs. Right? It's not so much of organizing what's your older data versus your newer data. It's more about reducing that storage cost as your objects get less and less used. So in this case, logs are a good fit because perhaps you're using your logs for the first 30 days, you're sifting through them, you're trying to get insights on them, but then you kind of move them out of the way because they become old data and you don't need them anymore. So we're going to see how we can transition them to another pricing tier, another storage tier. We could also do this with object tags, which is a very powerful feature. And in the lifecycle rules action, you have to at least pick one of these options. Now, since we haven't enabled versioning yet, what I'm going to do is just select transition the current version of the object between these storage classes. So as a reminder of what we already covered in the slides, our storage classes are right over here. So the one that's missing is obviously the default standard storage class, which all objects are placed in by default. So what we're going to say is this. We want our objects that are in the default standard storage class to go to the standard inactive access storage class after 30 days. And that'll give us a nice discount on those objects being stored. Then we want to add another transition. And let's say we want to transition them to Glacier after 90 days. And then as a big finale, we want to go to Glacier Deep Archive. You can see the rest are grayed out. Wouldn't make sense to go back. And maybe after 180 days, we want to go there. Okay. Now there's a little bit of a warning or a call to attention here. They're saying if you're going to store very small files into Glacier, not a great idea. There's an overhead in terms of metadata that's added, and also there's an additional cost associated with storing small files in Glacier. So we're just going to acknowledge that. Of course, for the demonstration, that's fine. In real life, you don't want to store very big tar files or zip files that had, one or more log files in there. Okay, that would bypass that surcharge that you would get. And over here, you have the timeline summary of everything we selected up above. So we have here after 30 days, the standard inactive access, after 90 days, Glacier, and after 180 days, Glacier Deep Archive. So let's go and create that rule. All right, so we see that the rule is already enabled, and at any time you could go back and disable this if ever you had a reason to do so. We can easily delete it as well, or view the details and edit it as well. So if we go back to our bucket, now what I've done is created that prefix with the /logs. Since we're not doing this from the command line, we're going to create a logs folder over here that will fit that prefix. So we're going to create logs, create folder. And now we're going to upload our, let's say, Apache log files in here. So we're going to upload one demonstration Apache log file that I've created with just one line in there, of course, just for demonstration purposes. We're going to upload that. And now we have, we're going to just close that. And now we have our Apache log file in there. So what's going to happen, because we have that lifecycle rule in place, after 30 days, any file that has the logs prefix, or basically is placed inside this folder, will be transitioned as per that lifecycle rule policy that we just created. So congratulations, you just created your first S3 lifecycle rule policy. Let's now move over to bucket policies. So bucket policies are going to allow or deny access to not only the bucket itself, but the objects within those buckets to either specific users or other services that are inside the AWS network. Now, these policies fall under the category of IAM policy. So IAM stands for Identity and Access Management. And this is a whole other topic that deals with security at large. So there are no services in AWS which are allowed to access other services or data, for example, within S3, without you explicitly allowing it through these IAM policies. So one of the ways we do that is by attaching one of these policies, which are written in a JSON format. So it's a text file that we write. At the end of the day, that's the artifact, and that's a good thing because we can use that artifact and we can configuration control it in our source control and version it and put it alongside our source code. So when we deploy everything, it is part of our deployment package. So in this case here, we have several ways of doing this. We can use what's called the policy generator, which is a graphical user interface that allows us to simply click and point and populate certain text boxes, which will then generate that JSON document that will allow us to attach that to our S3 bucket. And that will determine, like I said, which users or services have access to whatever API actions are available for that resource. So we might say we want certain users to be able just to list the contents of this bucket, not necessarily be able to delete or upload new objects into that bucket. So you can get very fine-grained permissions based on the kind of actions you want to allow on this resource. So in order to really bring this home, let's go and perform our very own lab on this. Let's now see how to create an S3 bucket policy. Going back to our bucket, we're now going to go into permissions. So the whole point of coming up with a bucket policy is that we want to control who or what, the what being other services, have access to our bucket and our objects within our bucket. So there are several ways we can go about doing this. Let's edit a bucket policy. One, we can go and look at a whole bunch of pre-canned examples, which is a good thing to do. Two, we could actually go in here and code the JSON document ourselves, which is much more difficult, of course. So what we're going to do is we're going to look at a policy generator, which is really a form-based graphical user interface that allows us to generate, through the answers that we're going to give here, the JSON document for us. First question is, we got to select the policy type. Of course, we're dealing with S3, so it makes sense for us to create an S3 bucket policy. The two options available to us are allowing or denying access to our S3 bucket. Now, in this case here, we could get really fine-grained and specify certain kinds of services or certain kinds of users. But for the demonstration, we're just going to select star, which means anything or anybody can access this S3 bucket. All right. Now, depending on also the actions that we're going to allow. So in this case here, we can get very fine-grained, and we have all these checkboxes that we can check off to give access to certain kind of API action. So we can say we want to give access to, just deleting the bucket, which obviously is something very powerful, but you can get more fine-grained. As you can see, you have more of the getters over here, and you have more of the listing and the putting new objects in there as well. So you can get very fine-grained. Now, for demonstration purposes, we're going to say all actions. So this is a very broad and wide-ranging permission, something that you really should think twice about before doing. We're basically saying we want to allow everybody and anything, any service, all API actions on this S3 bucket. So that's no small thing. We need to specify the Amazon resource name, the ARN of that bucket specifically. So what we're going to do is go back to our bucket, and you can see here the bucket ARN. Okay, so we're just going to copy this, paste it in this policy generator, and just say add statement. You can see here kind of a resume of what we just did, and we're going to say generate policy. And this is where it creates for us, and make this a little bit bigger for us, it creates that JSON document. So we're going to take this, we're going to copy it, and we're going to paste it into the generator. Okay. Now, of course, we could flip this and change this to a deny, right? Which would basically say we don't want anybody to have access, or anything, any other service to have access to this S3 bucket. We could even say /* to also encapsulate all the objects within that bucket. So if I save this right now, you have a very ironclad S3 bucket policy, which basically denies all access to this bucket and the objects within. Of course, this is on the other side of the spectrum, very, very secure. So we might want to, for example, host a static website through our S3 bucket. So in this case here, allowing access would make more sense, right? So if I save changes, you see that we get an error here saying that we don't have permissions to do this. And the reason for that is because it realizes that this is extremely permissive. So in order to give access to every single object within this bucket, as in the case that I was stating of a static website being hosted on your S3 bucket, it would be much better to also at first enable that option. So I'm just going to duplicate the tab here. And once you go back to the permissions tab, one of the first things that shows up is this block public access setting, right? Right now it's completely blocked, and that's what's stopping us from saving our policy. We would have to go in here, unblock it, and save it, right? And it's also kind of like a double clutch feature. You have to confirm that just so you don't do that by accident, right? So now what you've effectively done is you've really opened up the floodgates to have public access to this bucket. It's something that can't be accidentally done. It's kind of like having to perform these two actions before the public access can be granted. Now, historically, this was something that AWS was guilty of, was making it too easy to have public access. So now we have this double clutch. Now that this is enabled or turned off, we can now save our changes here successfully. And you could see here that now it's publicly accessible, which is a big red flag that perhaps this is not something that you're interested in doing. Now, if you're hosting a public website and you want everybody just to have read access to every single object in your bucket, yes, this is fine. However, please make sure that you pay very close attention to this type of access flagged over here on the console. So congratulations, you just got introduced to your first bucket policy, a permissive one, but at least now you know how to go through that graphical user interface through the policy generator and create them and paste them inside your S3 bucket policy pane. So let's continue on with data encryption. So any data that you place in S3 bucket can be encrypted at rest very easily using an AES 256 encryption key. So we can have server-side encryption. We could have AWS handle all the encryption for us, and the decryption will also be handled by AWS when we request our objects later on. But we could also have client-side encryption where we, the client that are uploading the object, have to be responsible for also passing over our own generated key that will eventually be used by AWS to then encrypt that object on the bucket side. Of course, once that happens, then the key is discarded, the client key is discarded, and you have to be very mindful that since you've decided to handle your own encryption, client-side encryption, that if ever you lose those keys, well, that data is not going to be recoverable in that bucket on the AWS network. So be very careful on that point. We can also have a very useful feature called versioning, which will allow you to have a history of all the changes of an object over time. So versioning sounds exactly how it's named. Every time you make a modification to a file and upload that new version to S3, it will have a brand new version ID associated with that. So over time, you get a sort of stack of a history of all the file changes over time. So you can see here at the bottom, you have an ID with all these ones, and then an ID with 121212. So eventually, if ever you wanted to revert back to a previous version, you could do so by accessing one of those previous versions. Of course, versioning is not an option that's enabled by default. You have to go ahead and enable that yourself. It is an extremely simple thing to do. And so there may be a situation where you already have objects within your buckets and you only then enable versioning. Well, versioning would only apply to the new objects that would get uploaded from the point that you enabled versioning. The objects that were there before that point will not get a specific version number attached. In fact, they will have a sort of null marker version number that will get attached to them. It's only after that you modify those objects later on and upload a new version that they will get their own version numbers. So right now, what we're going to be doing is a lab on actual versioning. So let's go ahead and do that right now. In this lab, we're going to see how to enable versioning in our buckets. Enable versioning is very easy. We're simply going to click on our bucket, go into properties, and there is going to be a bucket versioning section. We're going to click on edit and enable it. Once that's done, any new objects that are uploaded to that S3 bucket will now benefit from being tracked by a version number. So if you upload objects with the same file name after that, they'll each have a different version number. So you'll have version tracking, a history of the changes for that object. Let's actually go there and upload a new file. I'll upload one called index.html. So we're going to simulate a situation where we've decided we're going to use an S3 bucket as the source of our static website to deploy one. And in this index.html file, if you take a look right now, let's take a look at what's in there. You can see that we have welcome to my website and we're at version 2. Okay, so if I click on this file right now and I go to versions, I can clearly see that there's some version activity that's happening here. Okay, we have here at 1456, which is the latest one is on the top, the current version, we have a specific version ID. And then we have a sort of history of what's going on here. Now, I purposely enabled versioning before and then try to delete versioning or disable versioning. But here's the thing with versioning. You cannot disable it fully once it's enabled. You can only suspend it. Right? Now, suspending means that whatever version numbers those objects had before you decided to suspend it will remain. So you can see I have an older version here that has an older version number. And at this point here, I decided to suspend versioning. And so what it does, instead of disabling the entire history, it puts what's called a delete marker. Okay. You could always roll back to that version if you want. Now, in the demonstration, when we started it together, I enabled it again. So you can see this is actually the brand new version number as we did it together, but you don't lose the history of previous versioning if ever you had suspended it before. So that's something to keep in mind, right? And it'll come up in the exam where they'll ask you, can you actually disable versioning once it's enabled? And the answer is no, you can only suspend it and your history is still maintained. Now, we have that version there, and let's say I come to this file and I want to upgrade this, I don't know, I say version 3, right? And now what's going to happen is if I click on this version, just as the current one with version 2, and I open this, we should see version 2, which is fine. That's expected. If we go back to our bucket and upload that new version file that has version 3 in there, the one I just modified, we should now see in that index.html file a brand new version that was created under the versions tab. And there you go, 1458, just 2 minutes after. You can see here we have a brand new version ID, right? And if I open this one, you can see version 3. So now you have a way to enable versioning very easily in your buckets. And you also have seen what happens when you want to suspend versioning, what happens to the history of those versions files before. Just to actually go back here to the properties where we enabled versioning in the first place, if I want to go back in here and disable it, like I said, you can't disable, you can only suspend. And that's where that delete marker gets placed, but all your previous versions retain their version ID. So don't forget that, because that will definitely be a question on your exam if you're interested in taking the certification exam. So congratulations, you just learned how to enable versioning. Let's move on to cross-region replication, or CRR as it is known. There will be many times when you find yourself with objects in a bucket and you want to share those objects with another bucket. Now that other bucket could be within the same account, could be within another account within the same region, or could be within a separate account in a different region. So there's varying levels of degree there. The good thing is all of those combinations are available. So CRR, if we're talking about cross-region replication, is really about replicating objects across regions. Something that is not enabled by default, because that will incur a replication charge because it's syncing objects across regions. Of course, you are spanning a very wide area network in that case, so there is a surcharge for that. Now, doing so is quite simple to do, but one of the things that we have to be mindful of is to give permissions for the source bucket, which has the originals, to allow for this copying of objects to the destination bucket. So if we're doing this across regions, of course, we would have to come up with IAM policies, and we would also have to exchange credentials in terms of IAM user credentials, in terms of account IDs and the such. We're going to be doing a demonstration in the same account, in the same region, but largely this would be the same steps if we were going to go cross region. So this is something you might find yourself doing if you want to share data with other entities in your company. Maybe you're a multinational and you want to have all your log files copied over to another bucket in another region for another team to analyze, to extract business insights from. Or it might just be that you want to aggregate data in a separate data lake in an S3 bucket in another region, or in like I said, it could be even in the same region or in the same account. So it's all about organizing, moving data around across objects, across these boundaries. And let's actually go through a demonstration and see how we can do CRR. let's now see how we can perform cross-region replication. We're going to take all the new objects that are going to be uploaded in the Simplilearn S3 demo bucket, and we're going to replicate them into a destination bucket. So what we're first going to do is create a new bucket, okay? And we'll just tack on the number 2 here. And this will be our destination bucket where all those objects will be replicated to. We're going to demonstrate this within the same account, but it's the exact same steps when doing this across regions. One of the requirements when performing cross-region replication is to enable versioning. So if you don't do this, you can do it at a later time, but it is necessary to enable it at some point in time before coming up with a cross-region replication rule. All right, so let me create that bucket. And now after the bucket is created, I want to go to the source bucket and I want to configure under the management tab here a replication rule. So I'm going to create a replication rule, call it SimplilearnRep rule. And I'm going to enable this right off the bat. The source bucket, of course, is the Simplilearn S3 demo. We could apply this to all objects in the bucket or perform a filter once again. Let's keep it simple this time and apply to all objects in the bucket. Of course, caveat here, this will only now apply to any new objects that are uploaded into this source bucket and not the ones that are already pre-existing there. Okay. Now, in terms of a destination bucket, we want to select the one we just created. So we can choose a bucket in this account, or if we really want to go cross region or another account in another region, we could specify this and put in the account ID and the bucket name in that other account. So we're going to stay in the same account. We're going to browse and select the newly created bucket. And we're also going to need permissions for the source bucket to dump those objects into the destination bucket. So we can either create the role ahead of time or we can ask this user interface to create a new role for us. So we'll opt for that. And we'll skip these additional features over here that we're not going to talk about in this demonstration. We're just going to save this. So that will create our replication rule that is automatically enabled for us right now. So let's take a look at the overview here. You can see it's been enabled. Just to double check, the destination bucket is the demo 2. We're talking about the same region. And again, here we could opt for additional parameters like different storage classes in the destination bucket that object is going to be deposited in, etc., etc. For now, we just created a simple rule. Now, if we go back to the original source bucket, which we're in right now, and we upload a new file, which will be a transactions file in a CSV format, once this is uploaded, that cross-region replication rule will kick in and will eventually, right, it's not immediate, but will eventually copy the file inside the demo 2 bucket. Now I know it's not there already, so what I'm going to do is pause the video and come back in 2 minutes, and when I click on this, the file should be in there. Okay, so let's now double check and make sure that object has been replicated. And there it is, been replicated as per our rule. So congratulations, you just learned how to perform your first same account S3 bucket region replication rule. Let's now take a look at transfer acceleration. So transfer acceleration is all about giving your end users the best possible experience when they're accessing information in your bucket. So you want to give them the lowest latency possible. You can imagine if you were serving a website and you wanted people to have the lowest latency possible. Of course, that's something that's very desirable. So in terms of traversing long distances, if you have your bucket that is in, for example, the US East 1 region in the United States, in the Virginia region, and you had users, let's say in London, that want to access those objects, of course, they would have to traverse a longer distance than users that were based in the United States. And so if you wanted to bring those objects closer to them in terms of latency, then we could take advantage of what's called the Amazon CloudFront Delivery Network, the CDN network, which extends the AWS backbone by providing what's called edge locations. So edge locations are really data centers that are placed in major city centers where our end users mostly are located, more densely populated areas, and your objects will be cached in those locations. So if we go back to the example of your end users being in London, well, they would be accessing a cached copy of those objects that were stored in the original bucket in the, for example, US East 1 region. Of course, you will get most likely a dramatic performance increase by enabling transfer acceleration. It's very simple to enable this. Just bear in mind that when you do so, that you will incur a charge for using this feature. The best thing to do is to show you how to go ahead and do this. So let's do that right now. Let's now take a look at how to enable transfer acceleration on our SimplilearN S3 demo bucket. By simply going to the Properties tab, we can scroll down and look for a heading called Transfer Acceleration over here, and very simply just enable it. So what does this do? This allows us to take advantage of what's called the Content Delivery Network, the CDN, which extends the AWS network backbone. The CDN network is strategically placed into more densely populated areas, for example, major city centers. And so if your end users are situated in these more densely populated areas, they will reap the benefits of having transfer acceleration enabled because the latency that they will experience will be severely decreased. So their performance is going to be enhanced. If we take a look at the speed comparison page for transfer acceleration, we can see that once the page is finished loading, it's going to do a comparison. It's going to perform, first of all, what's called a multi-part upload, and it's going to see how fast that upload was done with or without transfer acceleration enabled. Now, this is relative to where I am running this test. So right now I'm actually running it from Europe. So you can see that I'm getting very, very good results if I would enable transfer acceleration and my users were based in Virginia. So of course, now I have varying differences in percentage as I go closer or further away from my region where my bucket or my browser is being referenced. So you can see here, United States, I'm getting pretty good percentages. As I go closer to Europe, it gets lower, of course, but still very, very good. Frankfurt, again, this is about probably the worst I'm going to be getting here since I'm situated in Europe. And of course, as I go look more towards the Asian regions, you can see once again it kind of scales up in terms of better performance. So of course, this is an optional feature. Once you enable it, as I just showed over here, this is a feature that you pay additionally for. So bear that in mind. Make sure that you take a look at the pricing page in order to figure out how much this is going to cost you. So that is it. Congratulations. You just learned how to simply enable transfer acceleration to lower the latency from the end user's point of view. We're now ready to wrap things up in our conclusion and go over at a very high level what we just spoke about. So we talked about what S3 is, which is a core service, one of the original services published by AWS in order for us to have unlimited object storage in a secure, scalable, and durable fashion. We took a look at other aspects of S3 in terms of the benefits. We mainly focused on the cost savings that we can attain in S3 by looking at different storage classes. Now, of course, S3 is industry recognized as one of the cheapest object storage services out there that has the most features available. We saw what goes into the object storage in terms of creating first our buckets, which are our containers, high-level containers in order for us to store our objects in. Again, objects are really an abstraction of the type of data that are in there, as well as the metadata associated with those objects. We took a look at the different storage tiers, the default being the standard, all the way till the cheapest one, which is the Glacier, which are meant for long-term archived objects. For example, log files that you may hold on to for a couple of years, may not need to access routinely, and will have the cheapest pricing option by far. So we have many pricing tiers, and if you want to transition from one tier to the next, you would implement a lifecycle policy or use the intelligent tiering option that can do much of this for you. We took a look at some very interesting features, starting from the lifecycle management policies that we just talked about, all the way to versioning, cross-region replication, and transfer acceleration. So with this conclusion, you are now ready to at least start working with S3. Hello everybody, my name is Kent, and today we're going to be covering AWS Identity and Access Management, also known as IAM, tutorial by Simplilearn. So these are the topics which we'll be covering today. We'll be defining what AWS security is, the different types of security in AWS, what exactly is identity and access management, the benefits of identity and access management, how IAM works, its components, its features, and at the end, we're going to do a great demo on IAM with multi-factor authentication and users and groups. So without any further ado, let's get started. So let's get started with what is AWS security. Your organization may span many regions or many accounts, and you may encompass hundreds if not thousands of different types of resources that need to be secured. And therefore, you're going to need a way to secure all that sensitive data in a consistent way across all those accounts in your organization while meeting any compliancy and confidentiality standards that have to be met. So for example, if you're dealing with healthcare data or credit card information or personal identification information like addresses, this is something that needs to be thought out across your organization. So of course we have individual services in AWS, which we will explore in this video. However, in order to govern the whole process at an organizational level, we have AWS Security Hub. Now, AWS Security Hub is known as a CSPM, which stands for a Cloud Security Posture Management Tool. So what does that really mean? Well, it's going to encompass, like I said, all these tools underneath the hood in order to bring a streamlined way for you to organize and adhere to these standards across your organization. It'll identify any misconfiguration issues and compliance risks by continuously monitoring your cloud infrastructure for the gaps in your security policy enforcements. Now, why is that important? Well, these misconfigurations can lead to unwanted data breaches and also data leakages. So in order to govern this at a very high level, like I said, we need to incorporate AWS Security Hub that will automate and manage all these underlying services for us in order to perhaps take automated action. We call that remediary actions. And you can approve these actions manually, or you can automate those actions as you see fit across your organization. So let's delve a little bit deeper into what is AWS security, and then we'll start looking individually at some of these services. And so our organization has special needs across different projects and environments. So of course, the production, development, test environments, all are going to have their own unique needs. However, it doesn't matter which project or which business unit we're talking about and what are their storage backups needs. they should all be implemented in a concise, standardized way across your organization to meet that compliancy we were just talking about. So we want to automate all these tedious manual tasks that we've been doing, like ensuring that perhaps our buckets in S3 are all encrypted or all our EBS volumes are encrypted. And we want to have an automated process in place in order to give us time on other aspects of our business, perhaps our application development, to bring better business value. And that allows us to grow and innovate the company in a way that's best suited for it. So let's take a look at the different types of AWS security. Now, there are many different types of security services out there. However, we're going to concentrate primarily on IAM in this video tutorial. So I like to think of IAM as the glue between all AWS services, because by default, we don't have permission for any one service to communicate with another. So let's just take, for example, an EC2 instance that wants to retrieve an object from S3. Well, those two services could not interact unless we interacted with IAM. So something that's extremely important to learn. And by the end of this video tutorial, you'll be able to understand what IAM is. We have Amazon Guard Duty here, which is all about logs. Basically aggregates all logs from, example, CloudTrail, which we still haven't talked about. It's at the end of this list over here. But instead of looking at CloudTrail individually, Guard Duty will actually take a look at CloudTrail will take a look at your VPC flow logs, and we'll take a look at your DNS logs and monitor that account and your network and your data access via machine learning algorithms. And it'll ID any threat where you can automatically remediate the workflow that you've approved. So for example, if you know of a malicious IP address that's making API calls, well, those API calls are registered in CloudTrail, right? So this machine learning algorithm will be able to detect that and take action. So this is really governed at a higher level than you having to individually inspect all your DNS logs, flow logs, and CloudTrails individually and take action through some scripting fashion that you've come up with. So Guard Duty manages all that. We have Amazon Macie, which once again uses machine learning, but also uses pattern matching. Pattern matching can be used with matching kind of libraries that are already in place, or you can come up with your own pattern matching, and that's used to discover and protect your sensitive data. So for example, if you had healthcare data, also known as HIPAA compliancy, or credit card data that's lying around, well, Macie will discover it and will protect it. So as your data grows across your organization, that might be harder and harder to do in your own way. So Macie really facilitates discovering and protecting that, so you can concentrate on other things. AWS Config is something that kind of works in tandem with all the other services. It's able to continuously monitor your resources configurations and ensure that they match your desired configuration. So for example, maybe you state that your S3 bucket should be encrypted by default, all of them, or you want to make sure that your IAM user access keys are rotated. And if they're not, then take remediary action. So a lot of these automated remediary actions, right, are basically executed via AWS Config. So you'll see the AWS Config actually used by other services underneath the hood. And then you have CloudTrail. CloudTrail is all about logging every single type of API call that's made. So it'll always record the API call, who made it, from what source IP, the parameters that were sent with the API, the response, all that data, which is really a gold mine for you to investigate if there's any security threat. And again, this trail over here, and there can be many, and there's lots and lots of data generated by these trails, can be analyzed by these other services, specifically Guard Duty here, that automates that process so you don't have to. So let's get to the next one, which is, what is identity and access management? So what is IAM? Like I said, IAM is the glue between all AWS services. It will allow those services to communicate with each other once you put IAM into place. The other thing is it allows us to manage our AWS users, which are known as IAM users, and group them together into groups to facilitate assigning and retrieving or removing permissions from them instead of doing it on an individual scale. So of course, if you had 200 IAM users and you wanted in one shot to add a permission to a group that contained 200 IAM users, well, you can do that in one operation instead of 200. Now we do have a distinction between IAM users and end users. End users use applications online, whereas IAM users are your employees in your organization that are interacting directly with AWS resources. So for example, an EC2 instance would be a resource that, let's say, a developer would be interacting with. And traditionally, those are resources that are used full time from 9 to 5, let's say, 5 days a week, 365 days a year, okay? Now, sometimes those users have to have elevated permissions for a temporary amount of time, and that is more suited for a role. And that will eliminate the need to create separate accounts just for, type of actions that are needed for, let's say, an hour a month or 2 hours a week or something like that. Something like backing up an EC2 instance, removing some files, doing some cleanups. Traditionally, you don't have those permissions as a developer, but you can be given temporary permissions to assume this role. So it's kind of like putting a hat on your head and pretending you're somebody that you're usually not for a temporary amount of time. Once you take off the hat, you go back to being your old boring IAM user self, which doesn't have access to performing backups or cleanups and stuff like that. So the roles interact with a service called a secure token service, which gives us specific keys, specifically an access key, a secret key, much like a username and password. And then we have a token key, which only gives you access to this role, this elevated permission, for 1 to 12 hours. So we'll talk more about roles as we go on through this video tutorial, but it's important that you at least remember at this point, even if you don't know all the details, that roles have to do with temporary permissions, elevated permissions. So what are the benefits of IAM? Well, across our organization, we're going to have many accounts, and like I said, hundreds if not thousands of resources. So scalability is going to be an issue if we don't have a very high level visibility and control over the entire security process. And once we have a tool like, for example, Security Hub, which we saw on the first slide, we can continuously monitor and maintain a standard across our organization. So very, very important to have that visibility. And we do when we integrate with AWS Security. Now, we also need to eliminate the human factor, right? So we don't want to manually put out fires every single time. Of course, there will be times when something new occurs that we've never seen before that will be needed. However, once an occurrence happens and reoccurs, we can obviously come up with a plan to remediate the action. So once we automate, we can definitely reduce the time to fix that reoccurring error, or it could be a new error that we don't have to interact with because we're using machine learning algorithm services like I was talking about, like GuardDuty or Macy. And we can really reduce the risk of security intrusions and data leakage and such by using IAM to facilitate this. Of course, you may have many compliance needs. You may be dealing with applications that use healthcare data or credit card information for payments, or you might be dealing with a government agency, let's say in the US, that has certain compliancy requirements that needs assurances that if their data is stored on the cloud, that you're still following the same compliance controls that you were, let's say, on premise. So we have a very, very long list of compliance requirements that each AWS service adheres to. And you can go on the AWS documentation online and you could figure out if, for example, DynamoDB is compliant with HIPAA compliancy. And it is. And so you can be sure that you can use that. So AWS itself has to constantly maintain these compliancy controls in place, and they themselves have to pass all these certifications, and that gets passed on to us. So much less work for us to implement these compliance controls. We can just inherit them by using AWS's security model by IAM. And last but not least, we can build the highest standards for privacy and data security. Now, having all this on our own on-premise data center poses security challenges, especially physical security challenges. You have to physically secure the data center. You might have security personnel that you need to hire, 24/7 camera surveillance, et cetera, et cetera. So just by migrating to the cloud, we can take advantage of AWS's global infrastructure. They're very, very good at building data centers. That's part of their business, and securing them. So of course we have a shared security model in place. However, you can rest assured that at least as the lowest common denominator, physical security has been put into place for us. Again, as other services are used, more managed services or more higher end services used in AWS, more and more of that security model will be AWS's responsibility and less yours. We will always have a certain type of responsibility for our applications, but we can again use these high level services to ensure that our ability to encrypt the data at rest and in transit are always maintained by coming up with specific rules that need to be adhered to. And if those rules are not adhered to, then we have remediary actions that take place in order to maintain, again, that cross-account or organizational-wide security control. Okay, so lots of benefits of using IAM. And let's now take a look at exactly how IAM works and delve deeper into authentication and authorization. So there are certain terms here that we need to know about. One of them is principal. Now, principal is nothing more than an entity that is trying to interact with an AWS service, for example, an EC2 instance or an S3 bucket. Now, that could be a user, an IAM user. It could be even a service, or it could be a role. So we're going to take a look how principals need to be specified inside IAM policies. Authentication. So authentication is exactly how it sounds. Who are you? Could be something as simple as username and password, or it could involve an email address. Example, if you're the root user of the account when you're creating the account for the very first time. Other normal users will not need to log in with their user email. It'll only be the root user that needs that. You could also have developer type access, which needs access, let's say, via command line interface or a software development kit, also known as an SDK. Now, for those kind of access points, we're going to need access keys and secret keys, or public-private keys, let's say, if you want to even authenticate and log in through SSH to an EC2 instance. So there are many different types of authentication that we could set up when creating IAM users based on what kind of access they need. Do they just need access to the console? Do they need access to just services in terms of as a programmatic need? So those are different types of authentication. And then we have the actual request. Now, we could make a request in AWS through various ways. We're going to be exploring that via the console, the AWS console. However, every button you click, every drop-down list you select, that invokes an API call behind the scenes. So everything goes behind a centralized, well-documented API. Every service has an API. So if you're dealing with Lambda, let's say, well, Lambda has an API. If you're dealing with EC2, EC2 has an API. Now, you could interact with that API, like I said, via the console indirectly. You could use a command line interface. You can use an SDK for your favorite programming language like Python. So all of them get funneled through, all your requests get funneled through an API. But that doesn't mean you're allowed to do everything just because we know who you are and you have access to some keys, let's say, to make some API calls. You have to be authorized in order to perform certain actions. So maybe you're only authorized to communicate with DynamoDB, and also maybe you're only authorized to perform reads and not writes. So we can get some very fine-grained authorization through some IAM policies in order to control not only who has access to our AWS, but what they're allowed to do. So very fine-grained actions, read actions, write actions, both, maybe just describe or list some buckets. So depending on the AWS user that's logged in, we can control exactly what actions because every API has fine-grained actions that we can control through IAM. And of course, many different types of resource. When we're coming up with these policies, all these actions can be grouped into resources. So perhaps we can say, well, this user only has access or read-only access to S3, specifically these buckets, and can write to DynamoDB table, but cannot terminate or shut down an EC2 instance. So all these kind of actions can be grouped into resources on a per resource basis based on the kind of role you have in the projects or in the company. So now let's take a look at the components of IAM. We've already seen that we can create IAM users and that how they are different than your normal end users. Now those entities represent a person that's working for an organization that can interact with AWS services. And some of those permissions that we assign through what's called identity-based policies to such a user will have permissions, for example, that are always necessary every time that they're logged in. So perhaps this user, Tom, always needs access to the following services over here, for example, an RDS instance or an S3 bucket, etc., etc. And sometimes they will need temporary access to other services, for example, DynamoDB. So in those cases, there would be a combination of normal IAM policies assigned to the user and certain assume role calls done at runtime in order to acquire this temporary credential, elevated permission. There is also the root user, which is different than your typical super user administrator access. There are some things that a root user can do that an administrator access cannot. For example, a root user, first of all, logs in with their email address and can also have the option to change that email address, something that is very tightly coupled to the AWS account. So you cannot change the email address with an administrator account. The other thing a root user can do is they can change the support contract. They can also view billing information or taxes information, VAT information, for example. So the best thing to do, the best practice is that once you've created your AWS account, you are obviously the root user. The best thing to do is to enable multi-factor authentication, store away those keys in a secure location, and your first administrative task should be to create an administrator super user, from which that point on you will log in as only an administrative user, and you will create other type of administrative users, and those administrative users will create other IAM users. So never log into your AWS account as a root user unless you need to access that specific functionality that I said that is over and above a super user administrator account. So here we have a set of IAM users, and we could assign to them directly IAM policies, which give them access to certain services. However, the best practice is to create groups, which is just a collection of IAM users. And suppose we have a developer group and a group of security administrators. Of course, we could assign different types of policies to that group, and every user that is assigned to the developer group will inherit those IAM permissions. Makes it much easier to manage your IAM users this way. And for the fact that also you can have users that can be assigned to groups, as you can see here, but what's not shown here that is possible as well is you could have a user that is part of two groups at the same time. The thing that you cannot have, though, is the notion of subgroup. So I can't extend this group and create a smaller group of developers out of this big group here. So we don't have hierarchical groups, but we do allow users to partake in different groups at the same time. So they will inherit those permissions, those IAM policy permissions from, for example, if user A was part of developers and user A was part of security, they would inherit these two policy statements over here. Now, there is another type of IAM policy, and that is called a resource-based policy. So resource-based policies are not attached directly to, for example, users, but they're attached more to resources like an S3 bucket, for example. And so when you have such a case, a user group can't be designated as a principal to a group. That's just one of the restrictions. However, there are other ways to get around that. As I said, when you think of an IAM role, I want you to think that these are temporary credentials that are acquired at runtime and are only good for a specific amount of time. Now, an IAM role is really made up of two components. We have what's called a trust policy. So who do you trust to assume this role? Who do you trust to even make an API call to assume the role? After that, we have an IAM policy. Once you've been trusted to assume the role and you get those temporary tokens, what are you allowed to do? Maybe you're allowed to have read-write access to the DynamoDB. So here we have no long-term credentials that are connected to role. You do not assign a role to a user. The user or service will assume the role via API call via the Secure Token Service, STS. And with those temporary credentials, we'll then be able to access, for example, an EC2 instance if the IAM policy attached to the IAM role says that you can do so. So your users and your applications perhaps running on an EC2 instance and the AWS services themselves don't normally have access to the AWS resources, but through assuming a role, they can dynamically attain those permissions at runtime. So it's a very flexible model that'll allow you to bypass the need to embed security credentials all over the place and then have to maintain those credentials and make sure they're rotated and they're not acquired by anybody trying to find a security hole in your system. So from a maintenance point of view, they're really an excellent tool to use in your toolbox, your security toolbox. So let's take a look at the components of IAM. We have the IAM policy over here, which is really just a JSON document. And that JSON document will describe what this user can do if it's attached directly to it, or if the IAM policy is attached to the group, whatever user is attached to that group will also have the same policy inherited. So these are more long-term credentials in terms of, or permissions rather, that are attached to your login for the duration of your login, whereas roles are, as we've already stated, temporary. And again, once you've established a trust relationship, then we can assign a policy, for example, a policy that gives you only read-only access to a CloudTrail to a role. Now, it's up to the user to assume that role either through the console or through some programmatic means. Whichever way is performed, the user will have to make a direct or indirect call to STS for the assume role call. Now, these permissions are examined by AWS when a user submits a request. So this all happens at runtime dynamically. So when you change a policy, it will take effect pretty much immediately as soon as the user makes the next request. That new security policy, whether you just added or removed the permission, will take immediate effect. So what we're going to do now is just really quickly go to the AWS console and actually show you how an IAM policy looks like. So I've just logged into my AWS management console, and if I search for identity and access management, it should be the first one to show up. I'll just click on that. And I want to show you actually how these IAM policies look like. If you go to the left-hand side here, there's an entry for policies, and there are different types of policies that we can filter out. So let's filter them out by type. We have customer managed, we have AWS managed, and more in line with job functions that AWS managed also. So we're going to take a look at AWS managed. All that means is that AWS has created and will actually update, maintain these pre-established and already vetted identity policies, IAM identity policies. So I could add further down, maybe look at all the S3 policies that are available, and we can see there are some that allows only read-only access. There are some that will give us full access. And there are, of course, other types here that we're not all going to explore, but let's just easily kind of take a look here at the full access. You can see it's just a JSON document. And of course, you cannot modify it since this is a managed policy. However, you can copy it and modify it. And in that case, it will become your own version of it. And so it'll be customer defined. And so when you go here and you do a filter, you can filter on your own customer managed policies. So over here, we are simply allowing certain actions, right? We talked about actions before that were based on API. So here we have an API that starts with S3. So this is for the S3 API. And instead of filtering out exactly specifically what API calls are there, we're basically saying all API calls. So star representing all API actions. And again, there is another category of S3 which deals with object Lambda, and we are allowing all operations on that specific API as well. We could, if this was our own customer managed policy, actually scale down on which resource, which bucket, let's say, or which folder in a bucket this would apply to. But in this case, since this is a full access, we're basically being given permission to execute every single API action under S3 for all buckets. We're going to see in the lab or the demonstration at the end of this tutorial that I'm going to show you how to scale that down. Okay, so that's how an IAM policy looks like. And if you want to assign an IAM policy to a user, well, stay tuned for the demonstration at the end of the video tutorial. What's not at the end of the video tutorial is really how to create a role. So I'll show you what a role is here. Again, there's a whole bunch of roles already set up that we can go and take a look at here. But we can go and create our own role as well. And I might create a role, for example, that gives in EC2, let's choose EC2, access to S3. So if I click EC2 and click Next Permissions, I can actually assign the S3 permission right over here. It's just a policy, just like we took a look at. Obviously assign it a tag and review it. And I'm just going to call this my EC2 role to S3. Create the role. And because I selected EC2 as a service, it automatically will include that in the trust policy. So now when I go and I create an EC2 instance, I can attach this role to that EC2 instance, and that EC2 instance will automatically be able to, if we're using the Linux 2AMI, let's say, have access to, or full admin access to, any S3 bucket in the AWS account. So let's go take a look at where we would actually attach that role on the EC2. So when you're creating an EC2, let's just say we go here, we say launch an EC2 instance, and we'll pick this AMI over here because it'll already include the packages necessary to perform the assume role call to STS for us, so we won't have to code that. And we don't have to embed any credential keys in order to get this running, which is really good, which is the whole point of what I'm doing, because by assuming a role, I don't have to manage that. And I'm just going to pick the free T2 micro. And it is here, once you pick whatever you need, whatever VPC and whatnot, that you come to the IAM role and you select the role to be assumed dynamically. Now I have a whole bunch of them here, but this is the one that I had created here, my EC2 role to S3. And if I go and I launch this EC2 instance, and then I had an application, let's say, that needed to contact S3, or even if I went on the command line of the EC2 instance, I would be able now to communicate with the S3 service, because they being AWS, would actually use this role to perform an assume role call to get those temporary STS tokens for me, which will then allow me to access my IAM policy, which gives me full access to S3. And off I go. So this is a great way, like I said, to avoid having to administrate any embedded keys in this EC2 instance. And I could take this role away at any time as well. So there you have it, a little demonstration on how to create a role, how to attach it to an EC2 instance, and also how managed and customer managed policies look like in IAM. Of course, there is also the fact that we have multiple accounts, and so we could assign a policy that will also allow a user in another account access to our account. So cross-account access is something that's very well needed, and also is a feature of IAM. So when you need to share access to resources from one account to another in your organization, we are in need of an IAM policy to facilitate that. So also roles can come into play here for that. By also assigning granular permissions, we can make sure that we implement the concept or the best practice of the least privilege access. And also we have secure access to AWS resources, because by default, again, we have the principle of least privilege, and no service can communicate with another until we enable it via IAM. So very, very secure out of the box. Of course, if you want to add an additional layer of authentication, of security, we have multi-factor authentication rather, and that'll allow you to ensure through a hardware device, perhaps let's say a hardware token device, or your cell phone that has some software that generates a code, that will allow you to identify you are actually the person that is typing the username and password, and not somebody who's actually stolen your username and password. So at the end of this video tutorial, we will show you, or I will show you how to enable that. And of course, identity federation is a big thing, where your users may have been defined outside of AWS. You may have thousands of users that you've already defined, let's say in an Active Directory or in an LDAP environment on-prem, and you don't want to recreate all those users again in AWS as IAM users. So we can tie in, we can link the users, your user database that's on-prem, or even users that have been your user account that's been defined, let's say on a social site like Facebook or Twitter or Google, and tie that into your AWS account. And though there is an exchange of information, there is a setup to do, but at the end of the day, it is either a role in combination with an IAM policy that will allow to map what you're allowed to do once you've been authenticated by an external system. So this has to do with perhaps like I said, LDAP or Active Directory, and you can tie that in with AWS SSO. There are many different services here that can be leveraged to facilitate what we call identity federation. And of course, IAM itself is free. So it's not a service per API request. AWS is very concerned to put security first, and so IAM is free. It's just the services that you use. For example, if you're securing an EC2, of course, that EC2 instance falls under the current pricing plan. So of course, compliance, like I mentioned, is extremely important, making sure that it's business as usual in the cloud. And so, for example, if you were using the payment card industry data security standard to make sure that you're storing and processing and transmitting credit card information appropriately, in order to do your business, well, you can be assured that the services you use in AWS are PCI DSS compliance. And there's many, many other types of compliance that AWS adheres to as well. So password policies, of course, are important. By default, we do have a password policy in place, but when you go to the IAM console, you're free to update that password policy, make it more restrictive based on whatever policy you have at your company. So many features, and so I think we're ready now to go into a full demonstration, and I will show you how to incorporate IAM users, groups, and also multi-factor authentication. So get ready, let's do it. I'm going to demonstrate now how to attach an S3 bucket policy via IAM. I've already created a bucket called SimplilearnS3 IAM demo. And what we're going to do is we're going to attach a bucket policy right over here. We're going to have to edit it, of course. And the basis of the demonstration will be to allow a user that has MFA, so multi-factor authentication, set up to have access to the contents of a folder within this bucket. So of course, now I have to create a folder. Just simply call it folder 1. Create that folder. And now I'm going to go into that folder and upload a file so that we can actually see this in action. So I'm going to select a demo file that I prepared in advance called demo file user2 MFA. I'm going to upload that. All right, and now what's going to happen is eventually when I create our 2 IAM users, one will have access to view the contents of this file, which should look like something very simple. If I open this up within the console, you'll be able to see, well, it's pretty small right now. I'll make this a little bit bigger, of course. It says this is a demo file which user2-MFA should only be able to have access to. So what's left to do now is to create 2 users, one called user1 and one called user2-MFA, and that's what we're going to do right now. Let's head over to IAM, Identity and Access Management. And on the left-hand side here, we're going to click on Users. You can see here I don't have much going on. I just got an administrator user, so I want to create 2 new users. We'll start with one at a time, so one called user1. Now, by default, we have the principle of least privilege, which means this user is not allowed to do anything unless we give them access to either the console right over here, which I will do right now, and also if they were a kind of programmatic user that needed access to specific keys in order to interact with the APIs via the command line interface or the software development kit, for example, if you were a Java developer. So in this case, that is not what I want. So I'm just going to assign console access, and I'm also going to create a default password for this user, but I will not allow them to reset it on the first login, just for demonstration purposes. Now over here, we have the chance to add the user straight to a group, but I'll only do that later on at the end of the demonstration. For now, I want to show you how to attach to this user an IAM policy, which will give them access to specific services. So if I type in S3 full access here, this is an administrative access to an S3 bucket. If you take a look at the JSON document attached or representing that IAM policy, you can see that it is allowing all API actions across S3 star and also object lambda across all buckets. And I say all buckets because the star represents all buckets. So it is a very broad permission, so be very careful when you're actually assigning this to one of your users and make sure that they deserve to have such a permission. So I'm not going to assign any tags here, but I'm just going to review what I've done. You can see here I've just attached an S3 full access permission to this one user, and I'm going to create that user now. Of course, now's the time for me to download the CSV file, which will contain those credentials. If I don't do it now, I will not have a second chance to do this. And also to send an email to this user in order for them to have a link to the console and also some instructions. I'm not going to bother with that. I'm just going to say close. And now I have my user 1. You can see here that it says none for multi-factor authentication. So I have not set anything up right now for them. And that's what I want to do for this second user that I want to create called user2-MFA, or MFA rather. All right. So now I want to do the same exact thing as before. I'm going to assign a custom password. And I'm going to go through the same steps as we saw before. I'm going to attach an existing managed policy that AWS has already vetted for us. Review, create. Now, right now, they're exactly the same. So I have to go back to user 2 and set up multi-factor authentication. And to do that, you have to go in the Security Credentials tab. And you'll see here assigned MFA device, we have not assigned any yet, so we're going to manage that right now. And we have the option to order and get an actual physical device that's uniquely made for performing multi-factor authentication. However, we're going to opt for the virtual MFA device, which is a software that we're going to install on our cell phones, let's say. So I can actually open this link just to show you the very many options that we have for that. They're right over here. I'm going to go with Google Authenticator. So go to the App Store on your Android device and you can download that. Of course, if you have an Android device. If not, you have other options for iPhone and other softwares for each one of those. So I'll let you do that. Once you've installed that software on your cell phone, you can come here and show the QR code. Now what that is going to do is you're going to need to go to your phone now, and I'm going to my phone right now as we speak, and I'm going to open up that MFA software, in this case the Google Authenticator, and I'm going to say there's a little plus sign at the bottom. I'm going to say scan QR code. I'm going to point my phone to this square code here, this QR code, and it's going to pick it up. I'm going to say add account. There's a little button there, add account, and it's going to give me a code. So I'm going to enter that code right now. So once I've entered the code, I have to wait for a second code, and that's because this code on the screen of my cell phone is going to expire. It's only there for about 20 to 30 seconds. Once that token expires, it refreshes the display with another token. So I have another token now. That's only good for a couple of seconds again. And now I'm going to say assign MFA. What this does is it completes the link between my personal cell phone and this user right now. So now that this has been set up, we can see we actually have an ARN to this device, which we are going to possibly need depending on how we write our policies. In our case here, I'm going to show you a way to kind of bypass having to put that. So now we've got those two users, one with an MFA device and another one without. Okay, so now the lab is going to be, or the demonstration rather, is going to be how do we allow user 2 MFA access to this file in folder 1 and not allow user 1. The distinguishing factor will be that user 2 has an MFA set up and user 1 doesn't. So based off of just that condition, that'll be the determining factor if they can view the file or not. So let's get back to S3 and actually create this IAM bucket policy and see how it's done. So back we are in our bucket, and now we have to go to permissions in order to set up this bucket policy. We're going to click on edit over here, and we're going to click on policy generator to help us generate that JSON file through a user interface. Of course, we're dealing with an S3 bucket policy. Now, what we're going to do is we're going to deny all users and services, so star. S3 is grayed out here because we selected S3 up here. We want to deny all S3 API actions. We're not going to go and selectively go down the list. The specific bucket and the folder. So in this case here, we're missing the Amazon resource name. So we have to go back here and we have to copy the ARN of our bucket, right? So we're going to copy that, come back, Control V, and we're going to, of course, have to specify the folder as well. So I'm going to just do /folder1, and then I'm also going to do /star for all the objects in that folder, okay? So here's the MFA condition that I want to add though, because we cannot assign the MFA condition up here. We have to say add conditions. Very powerful feature here. That's optional, but very powerful. We want to look for a condition that says Boolean if exists, or bool if exists, all right? So there's got to be a key value pair that exists, and there are many, but we're going to look for one that is specifically known as multi-factor authentication present. And we want to make sure that value is equal to false. So I'm going to add that condition, and then I'm going to add that statement. and I want to generate the policy just to show you now how that user interface has generated this JSON document for us that we're going to attach to our S3 bucket. What I want to do is I want to take this in its entirety, copy it, and go back to our S3 bucket that's just waiting for us to paste our policy in here. Okay, so let's see what's actually going on here. We've created a policy. Again, this policy could have any ID. It's just an ID that was given by the user interface. You could name that whatever you want. Of course, something that makes total sense. And then we have one or more statements, and then we only have actually one statement. And again, you can select any ID here. That was just auto-generated by the IDE. We're saying that all actions on the simple storage service, I say all again because of the star, are denied specifically on this resource, which is our bucket and the folder named folder 1 and all the objects within that folder under the certain conditions. So the condition is if you have a Boolean value of false associated with a key called multi-factor authentication present, and it has to exist, okay? Then if that value is equal to false, you don't have access to the objects in this folder, which means that if you do have MFA set up, you will be allowed access to the contents of this folder. So if we assign this and apply this to all principals, which would encompass user 1 and user 2-MFA, then let me just apply this. That would mean that user 1 would not be able to see the contents of our object inside folder 1, and user 2-MFA would. So let's go take a look and log into, let's log out first, and then when we're going to log back in, we're going to log in as the individual user 1 and user 2-MFA and prove this is actually the case. So I am now logging back in as user 1 that we created moments ago. And of course, if I, for example, go see a service like EC2, we don't have access to EC2. We've just given ourselves access to S3. So this makes total sense. We're just going to go see what we have access to, which is S3. Should be able to list and describe all the buckets there because we've been given pretty much administrative access. Now, if we go here to our created bucket and go inside folder 1 and want to actually open up this document, we can see now that that's not happening, okay? And that's because of that condition that is checking if we actually have a value of true for that MFA key that we specified, okay? So this is expected and this is exactly what we wanted. Now what we're going to do is we're going to log out once again, and we're going to do the same thing, but with user 2-MFA. Let me log back in. And then specify the new password we created. Now, of course, now I have an MFA code, right? Because I've set that up for user 2. So back on my cell phone I go. I am opening up the Google Authenticator application, and I have in front of me a new Amazon Web Services code that is only good for, like I said, maybe 20 seconds. So it's a little nerve-wracking. If you're not good under pressure, you're going to choke. So I've just entered the code, and I have to wait for that to actually work. Now, it looks like I actually didn't check off not to recreate the password. So unfortunately, I must have missed that check mark. So I wanted to kind of avoid this here. So I'm going to start over and create a brand new password. A little painful for demonstrations, but it's good for you guys to see how that actually looks like. So because I've set up my MFA device properly, I am able to log in after I enter that MFA code. And once again, if I go to EC2, now I haven't been given the permissions for EC2. I've only been given the permissions for S3. So nothing changes here. I'm going to go to S3. And I'm going to go into folder 1 of our bucket in question. And I'm going to see if I have access now to opening up and seeing the contents. And here I have the contents. This is a demo file which user 2MFA should only be able to have access to. So that worked. So now you guys know how to create a bucket permission policy that is also known as a resource policy because it's assigned to the resource, it's assigned to the bucket. And let me actually show it to you one last time. Here it is. And that'll only allow us to have access to the contents of folder 1 if we have multi-factor authentication set up in our account. So that's really good. The last thing I want to show you now is how to maybe create IAM users in a better way in terms of not having to assign over and over again the same permissions like you saw me do for user 1 and user 2. Of course, now I cannot do anything IAM. Why? Because I'm user 2. I don't have access to IAM. So once again, I'm logging out and we're going to actually see the best practice in terms of how do I assign IAM policies to a group and then assign users to that group in order to inherit those permission policies. So let's get to it. Let's sign up first. So let us go back to IAM and we're going to be creating our first group. We're going to simply create the button or click on the button create group and we'll come up with a group called testers. We have the ability to add existing users to this group. So we will add, for example, user 1 only to the testers group. And we can also add permissions to this group. So we're going to go here and add, for example, the EC2 full permissions, create group. And what's going to happen now, if we go take a look at testers, we can see we have that one user that we added, and we also have the permissions associated with that group. So this means now that any new users we create will automatically inherit whatever permissions the group has, which is really good for maintainability. So for example, let's say we were to create many new testers. So let's say user 3 over here. Now, of course, I'm going to have to go in this case through the same steps as I did before. I'm just going to remember this time not to forget to uncheck that. And instead of attaching policies directly, I'm going to say, well, I want to inherit the policy permissions that were assigned to the group. So I'm going to say this user is going to be part of the testers group. And of course, I'm just going to skip through the remaining repetitive tasks that I've already described. And this user 3 now is already going to have the permissions to access EC2 that they've gained through the group testers. Whereas if we go back to user 1, this user also has the permissions from the group, but has a unique permission added to itself. So in this case, you do have the option of doing that. You have the option of adding a permission over and above that is assigned to the group to yourself directly. So this is really good, adding permissions to groups when you have, of course, lots of users in your company, in your organization. And instead of going to them and adding permissions after permission, you can centrally access this in one or manage this in one place. So for example, if I go back to my roles, groups rather, in my testers, and let's say I forgot to add a permission to all the users in this group. So let's say there was 20 users attached to this group. Okay, I'm not going to bore you with creating 20 users. we have 2 now. That's good enough to show the demonstration. And let's say now I need to add another permission, right? So in this case here, I'm going to add a permission, for example, let's say based on DynamoDB, right? So I'm going to give full access to DynamoDB. I'm going to add that permission. And what's going to happen now is if I go back to my users, for example, user 3, I'm going to see that user 3 automatically has inherited that permission, and so has user 1. All right, show two more, and there they are. So in this case, it really allows for you to easily manage a lot of users in that group, because you can simply go to one place, which is the group, and add and remove policies as you see fit, and the whole team will inherit that. So it saves you lots of work, and that is the best practice. So there you have it, guys. You have learned in this demonstration how to create users, how to create groups, how to add users to groups and manage their policies in terms of best practice. And you've also learned how to attach to an S3 bucket a policy that allows you to permit access based off of if a user has multi-factor authentication set up. And we showed you how to actually set that up when creating an IAM user. So again, permissions tab is where this all happens. Hope you enjoyed that, put that to good use, and I'll see you in the next demonstration. So I hope you enjoyed that demonstration. We're just going to wrap things up in a summary and kind of see what was looked at throughout the tutorial. We first started with what is AWS security. We took a look at how important it was across our organization to maintain best practice and also standardize that practice across accounts organization. We took a look at the topmost services, in which we concentrated then after on IAM. And we took a look at what IAM was in terms of IAM users, groups, long-term credentials that are applied as IAM policies, and then the concept of a role. We took a look at the benefits of IAM and the actual terminology used with working with IAM. Of course, principal being an entity that is either a user or a service itself that can gain access to an AWS resources. And we actually saw the different types of authentication and what we can do to implement authorization via IAM policies and also through the use of roles. So we took a look how to organize our users into groups and what actually goes into acquiring a role through a demonstration. We took a look at how to actually create a role and attach that role to an EC2 instance. And then we took a look at the high-level features of IAM, which allowed us to either grant access to another IAM user from another group, implement multi-factor authentication like we just did in the demonstration, or ensure ourselves that we are following all the compliancy standards that have been adhered to by whatever project we're working on, and that AWS is there to support us. So
here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general. And then it uses a service called Docker. So we're going to understand what Docker is. And there are competitive services available for ECS. ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. Each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment here. Most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application, which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. With containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that I was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right, so no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies, you'll be packing the code, you'll be packing the framework, you'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's an highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes, right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails and that that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there, right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already, and it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, elastic network interface card, separate elastic network interface card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers, kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it, along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right? Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab, we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just one running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it an data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough. And again, it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request. And there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it. And I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service. Is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer and port 80 that receives information on port 80, HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access these servers using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running, it was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here, because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded in any of your application if you want to make that application connect with this container. Now, using IP is not all that advisable because these containers can die and then a new container gets created, and when a new container gets created, it gets a new IP, right? So hard coding IP is not, hard coding dynamic IPs are not advisable. So you would be using load balancer and putting that URL in that application that you want to make it interact with this container instance. It was a wonderful experience in walking you through this ECS topic, and in here we learned about what AWS is and why we're using ECS and what is ECS in general, what is Docker in specific, and we also learned about the advantages of ECS, the architecture, the different components of ECS, and how ECS works when they're all connected together. And we also looked at the companies that use ECS and their use cases, and finally a lab, how we can launch ECS Fargate through the portal. I'm very glad to walk you through this lesson about Route 53. So in this section, we are going to talk about basics of AWS, and then we're going to immediately dive into why we need Amazon Route 53. And then we're going to expand and talk about the details of Amazon Route 53, the benefits it provides over its competitors, and the different types of routing policy it has, and some of Amazon Route 53's key features. And we're going to talk about how to access Route 53, I mean the different ways, the different methods you can access Route 53, and finally we're going to end with a wonderful demo in Route 53. So let's talk about what is AWS. Amazon Web Services, or AWS in short, is a cloud provider that offers a variety of services such as a variety of IT services or infrastructure services such as compute power, database, content delivery, and other resources that helps us to scale and grow our business. And AWS is hot, AWS is picking up, AWS is being adapted by a lot of customers. That's because AWS is easy to use even for a beginner. And talking about safety, the AWS infrastructure is designed to keep the data safe irrespective of the size of the data. Be it small data, be it very minimal data, be it all the data that you have in terabytes and in petabytes, Amazon can keep it safe in their environment. And the wonderful thing and the most important reason why a lot of customers move into the cloud is that the pay-as-you-go pricing. There is no long-term commitment and it's very cost effective. What this means is that you're not paying for a resource that you're not using. In on-premises, you do pay for resources you're not using a lot, meaning you go and buy a server, you do the estimate for the next 5 years, and only after like 3 or 4 years you'll be hitting the peak capacity, but still you would be buying that capacity before 4 years, right? And then you will gradually be, utilizing it from 40%, 60%, 70, 80, and then 100. So what you have done is that even though you're not using the full capacity, you still have bought it and are paying for it from day one. But in the cloud, it's not like that. You only pay for the resources that you use. Anytime you want more, you scale up the resource and you pay for the scaled up resource. And anytime you want less, you scale down the resource and you pay less for that scaled down resource. Let's talk about why Amazon Route 53. Let's take this scenario where Rachel is trying to open her web browser and the URL that she hit isn't working. A lot of reasons behind why the URL isn't working. It could be the server utilization that went high. It could be the memory usage that went high. A lot of reasons. And she starts to think, is there an efficient way to scale resources according to the user requirements? Or is there an efficient way to kind of mask all those failures and kind of divert the traffic to the appropriate active resource or active service that's running our application? You always want to hide the failures, right? In IT, kind of mask the failure and direct the customer to another healthy service that's running, right? None of your customers would want to see a server not available, or none of your customers would want to see your service not working. Not impressive to them. And this is Tom. Tom is an IT guy and he comes up with an idea and he's answering Rachel, yes, we can scale resources efficiently using Amazon Route 53. In a sense, he's saying that yes, we can mask the failure and we can keep the services up and running, meaning we can provide more high availability to our customers with the use of Route 53. And then he goes on and explains Amazon Route 53 is a DNS service that gives developers an efficient way to connect users to internet applications without any downtime. Now, downtime is the key. Amazon Route 53 helps us to avoid any downtime that customers would experience. You still will have downtime in your server, in your application, but your customers will not be made aware of it. And then Rachel is kind of interested and she's like, yeah, that sounds interesting. I want to learn more about it. And Tom goes on and explains the important concepts of Amazon Route 53. That's everything that I'm going to explain it to you as well. All right, so what is Amazon Route 53? Amazon Route 53 is an highly scalable DNS or domain name system web service. This service, this Amazon Route 53, it functions three main things, or it has three main functions. So the first thing is, if a website needs a name, Route 53 registers the name for the website domain. Let's say you want to buy google.com. You want to buy the domain name. Let's say you want to buy that domain name. You buy that through Route 53. Secondly, Route 53 is the service that actually connects your server, which is running your application or which is serving your web page. So that's the service that actually, Route 53 is the service that connects the user to your server when they hit google.com in the browser or whatever domain name that you have purchased. So you bought a domain name and the user types in your domain name.com, and then Route 53 is a service that helps the user to connect their browser to the application that's running in an EC2 instance or any other server that you are using to serve that content. Now, not only that, Route 53 checks health of the resource by sending automated requests over the internet to a resource. So that's how it identifies if there is any resource that has failed. When I say resource, I'm referring to any infrastructure failure, any application level failure. So it kind of keeps checking. So it understands it first before the customer notices it, and then it does the magic, kind of shifts the connection from one server to the other server. We call it routing. We will talk about that as we progress. So the benefits of using Route 53, it's highly scalable, meaning suddenly, let's say the number of requests, the number of people trying to access your website through that domain name that you have bought, let's say it has increased. Route 53 is highly scalable, right? It can handle even millions and millions of requests because it's highly scalable and it's managed by Amazon. The same thing, it's reliable, it's highly scalable, it can handle large queries without without you interacting, without the user who bought it interact with it. You don't have to scale up. When you're expecting more requests, it automatically scales. And it is very reliable in a sense that it's very consistent. It has the ability to route the users to the appropriate application through the logic that it has. It's very easy to use. When we do the lab, you're going to see that. It's very easy to use. You buy the domain name and then you simply map it to the application. You simply map it to the server by putting in the IP, or if you can simply map it to another load balancer by putting in the load balancer URL. You can simply map it to another S3 bucket by simply putting the S3 bucket name or the S3 bucket URL. It's pretty straightforward, easy to set up. And it's very cost effective in a way that we only pay for the service that we have used. So no wastage of money here. So the billing is set up in such a way that you are paying only for the amount of requests that you have received, right? The amount of traffic, the amount of requests that you have received, and a couple of other things. The number of hosted zones that you have created, right? And a couple of other things. It's very cost effective in such a way that you only pay for the service that you are using. And it's secure in a way that access to Route 53 is integrated with the Identity and Access Management, IAM. So you only have authorized users gain access to Route 53. The trainee who just joined yesterday won't get access. And the contractor or the consultant, the third-party consultant you have given access, or who is using your environment, you can block access to that particular person because he's not the admin or he's not a privileged user in your account. So only privileged users and admin gain access to Route 53 through IAM. Now let's talk about the routing policies. So when you create a record in Route 53, record is nothing but an entry. So when you do that, you choose a routing policy. Right? Routing policy is nothing but it determines how Route 53 responds to your queries, how the DNS queries are being responded. Right? That's a record, or that's a routing policy. So the first one is a simple routing policy. So we use simple routing policy for a single resource. In other words, simple routing allows to configure DNS with no special Route 53 routing. It's kind of one-to-one. You use a single resource that performs a given function to your domain. For example, if you want to simply map an URL to a web server, that's pretty straightforward, simple routing. So it routes traffic to a single resource, example, web server, to a website. And with simple routing, multiple records with the same name cannot be created, but multiple values can be created in the same record. The second type of routing policy is failover routing. So we would be using failover routing when we want to configure active, passive failover. If something failed, right, you want to fail over to the next resource, which was previously the backup resource, now the active resource, or which was previously the backup server, now it's an active server. So you would be failing over to that particular resource or that particular IP. If you want to do that, we use failover routing. So failover routing routes traffic to a resource when the resource is healthy, or to a different resource when the previous resource is unhealthy. In other words, anytime a resource goes unhealthy, it does all that's needed to shift the traffic from the primary resource to the secondary resource. In other words, from the unhealthy resource to the healthy resource. And this records can route traffic to anything from an Amazon S3 bucket, or you can also configure a complex tree of records. Now, when we configure the records, it will be more clear to you. So as of now, just understand that Route 53 can route, or this routing policy, the failover routing policy, can route traffic to Amazon S3 bucket or to a website that has complex tree of records. Geolocation routing policy. Now, geolocation routing, just like the name says, it takes that routing decision based on the geographic location of the user. In other words, when you want to route traffic based on the location of the user, that's your primary criteria for sending that request to the appropriate server, we would be using geolocation routing. So it localizes the content and presents a part or the entire website in the language of the user. For example, a user from US, you would want to direct them to an English website, and a user from German, if you want to send them to the German website, and a user from France, you want to send those requests, or you want to show content specific to a customer who lives in France, a French website. So this is, if that's your condition, this is the routing policy we would be using. And the geographic locations are specified by either continent or by country or by state in the United States. So only in the United States you can actually split it to state level, and for the rest of the countries you can do it on a country level. On a high level, you can also do it on a continent level. The next type of routing policy would be geo-proximity routing. Geo-proximity routing policy, when we want to route traffic based on the location of our resource and optimally shift traffic from resources in one location to resource in another location, we would be using geo-proximity routing. So geo-proximity routing routes traffic to the resources based on the geographic location of the user and the resources they want to access. And it also has an option to route more traffic or less to a given resource by specifying a value known as a bias. Kind of weight, but we also have weighted routing, that's different. So we've chosen different name, bias. You can send more traffic to a particular resource by having a bias on that particular routing condition. And a bias expands or shrinks the size of the geographic region from which traffic is routed to a resource. And then we have latency-based routing. Just like the name says, we use latency-based routing if we have resources in multiple AWS regions, and if you want to route traffic to the region that provides the best latency at any given point of time. So let's say if one single website needs to be installed and hosted on multiple AWS regions, then latency routing policy is what is being used. It improves the performance of the users by serving the request from the AWS region that provides the lowest latency. So at any given point, if performance is your criteria, and at any given point of time, irrespective of what happens in Amazon infrastructure, irrespective of what happens in the internet, if you want to route your users to the best performing website, best performing region, then we would be using latency based routing. And for using latency based routing, we should create latency records for the resources in multiple AWS regions. And then the other type of a routing policy is multi-value routing policy, where we can make Route 53 to respond to DNS queries with up to 8 healthy records selected at random. So you're not kind of loading one particular server. We can define 8 records, and on a random basis, Route 53 will respond to queries from these 8 records. So it's not one server that gets all the requests, but 8 servers gets the request in a random fashion. So it's multi-value routing policy, and what we get by this is that we are distributing the traffic to many servers instead of just one server. So multi-value routing configures Route 53 to return multiple values in response to a single or multiple DNS queries. It also checks the health of all resources and returns the multiple values only for the healthy resources. Let's say out of the 8 servers we have defined, one server is not doing healthy. It will not respond to the query with the details of the unhealthy server, right? So now it's going to treat it as only 7 servers in the list because one server is unhealthy. And it has the ability to return multiple health checkable IP addresses to improve availability and load balancing. The other type of routing policy is weighted routing policy, and in here we use to route traffic, or this is used to route traffic to multiple resources in a proportion that we specify. So this is an weighted routing, and weighted routing routes multiple resources to a single domain name or a subdomain and control the traffic that's routed to each resources. So this is very useful when you're doing load balancing and testing new versions of the software. So when you have a new version of the software, you really don't want to send 100% of the traffic to it. So you want to get customers' feedback about the new software that you've launched, new version or new application that you've launched. So you would kind of send only 20% of the traffic to that application, get customer feedback, and if all is good, then we would move the rest of the traffic to that new application. So any software launches, application launches will be using weighted routing. Now let's talk about the key benefits or key features of Route 53. Some of the key features of Route 53 are traffic flow. It routes end users to the endpoint that should provide the best user experience. That's what we discussed in the routing policies, right? It uses a routing policy, a latency-based routing policy, and geo-based routing policy, and then failover routing policy. So it kind of improves the user experience. And the other key feature of Route 53 is we can buy domain names using Route 53 console. We can buy it from here and use it in Route 53. Previously it was not the case, but now we can buy it directly from Amazon through Route 53, and we can assign it to any resources that we want. So anybody browsing that URL, the connection will be directed to the server in AWS that runs our website. Health checks. It monitors health and performance of the application. So it comes with an health check attached to it. Health check are useful to make sure that the unhealthy resources are retired, right? The unhealthy resources are taken away, or your customers are not kind of hitting the unhealthy resources and they see an service down page or something like that. We can have weighted round robin
load balancing that's helpful in spreading traffic between several services or servers via a round robin algorithm. So no one server is fully hit, or no one server kind of fully absorbs all the traffic. You can split and shift the traffic to different servers based on the weight that you would be configuring. And also weighted routing also helps with a soft launch of your new application or the new version of your website. There are different ways we can access Amazon Route 53. So you can access Amazon Route 53 through AWS console. You can also access Amazon Route 53 using AWS SDKs, and we can configure it using the APIs. And we can also do it through the command line interface. That's Linux type, Linux flavor, AWS command line interface. We can also do that using Windows command line, Windows PowerShell flavored command line interface as well. Now let's look at some of the companies that are using Route 53. So some of the famous companies that use Route 53 are Medium. Medium is an online publishing platform, and it's more like a social journalism. It's kind of having hybrid collection of professionals, people, and publications, or exclusive blogs or publishers on Medium. It's kind of an blog website, and that uses Route 53 for the DNS service. Reddit is an social news aggregation or web content rating and discussion website that uses Route 53. So these are some websites that are accessed throughout the world, and they are using Route 53, and it's highly scalable. Suddenly if there is a new news, right, their website will be accessed a lot, and they need to keep their service up and running all the time, more availability, otherwise customers will end up in a broken page, and the number of customers who will be using the website will come down. So it's very critical. Now these companies are very critical, they're being highly available, their site being highly available, and the internet is very critical and crucial for them, and they rely and use Route 53 to meet that particular demand. And Airbnb is another company, Instacart, Coursera is another company, Stripe is another company that uses Route 53 as their DNS provider for their DNS service. They use Route 53 so their customers get best performance. They use Route 53 so their website is highly available. They use Route 53 to kind of shift the traffic between the resources, so their resources are properly used. With all the weighted routing, the resources are properly used. Now let's quickly look at a demo. I'm in my AWS console and I'm in Route 53. So let me click on Route 53. So in this lab, we're actually going to simulate buying a domain name, and then we're going to create an S3 static website, and we're going to map that website to this DNS name, right? So the procedure is the same for mapping load balancer. The procedure is the same for mapping CloudFront. The procedure is the same for mapping EC2 instances as well. We're picking S3 for simplicity, right? But our focus is actually on Route 53. So let's go in here and we'll see if we can, right? We'll buy a domain name here. So let's first check the availability of a domain name called Simplilearn-demo-Route 53. Let's check its availability. It is available for $12, so let me add it to cart and then come back here. And then once you continue, it'll ask for personal information. Once you give the personal information, you finally check out, and then it gets added to your shopping list. Once you pay for it, Amazon takes like 24 to 48 hours to make that DNS name available. So the next stage would be contact details, and then the third stage would be verify and purchase. So once we have bought the domain name, it will become available in our DNS portal. And I do have a domain name which I bought some time back, and it's now available for me to use. So I can go to hosted zone and simply start creating. I can go to hosted zone, and then here it's going to list all the domain names for me, right? Click on the domain name and then click on the record set, and here I can actually map Elastic Load Balancer, S3 website, VPC endpoint, API gateway, and CloudFront, Elastic Beanstalk domain names, right? All that gets mapped through this portal. Quite simple, like 4 or 5 step
button clicks, and then it'll be done. So I have an domain name bot, and then I'm going to go to S3, and I'll show you what I've done in S3. So I've created a bucket name called as DNS name. Let me clear the content in them. So I've created a bucket, and then permissions, I've turned off public access blocking, and then I've created a bucket policy. So this bucket is now publicly accessible. And then I went on to properties and created the static website hosting, right? And I've pointed that this is the file, that's my index file that I'm going to put, or name of the file that's going to be my index file that I'm going to put in this S3 bucket. So I've put the index file.html, saved it, and we're going to create a file now. We're going to create an index file. So this is a sample code. It says Amazon Route 53 getting started, routing internet traffic to S3 bucket for your website, and then a couple of other information. So I've saved it as an index.html file in my desktop. So let me upload that from my desktop into this bucket. So that's index.html, and it's in capital I. So let me go to properties and go to static website hosting and make sure that I spell it properly, right? It's case sensitive, and then save it. So now this means that my website should be running through this URL, and it does. It's running through the static website URL. We're halfway through. So now let me go back to Route 53. Go back to Route 53, go back to hosted zones, go into the domain name, and then create a record set. And it's going to be an alias record. And I see my S3 static website endpoint there. Right, so click on it and create. It has now created an record that's pointing my domain name to the S3 endpoint that I have created, and my static website is running from it. So let me test it. Right, so let me go to the browser, put the domain name in there, and sure enough, the domain name, when my browser queried for the domain name, Route 53 returned a response saying this domain name is actually mapped to the S3 bucket. Static website hosting enabled S3 bucket, and this is the URL for that static website hosting. And then my browser was able to connect to that S3 bucket and download the details and show it in my browser, right? So it's that simple and pretty straightforward.
Today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier, and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer, and if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about the scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. For if you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it, nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance, that is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now, in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now, after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitored, provided capacity provisioning, load balancing, auto scaling, and hence monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are 2 types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you 2 different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client requests, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and it may route. You can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now here in the diagram you can see that there are 2 web server environments and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well, and these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is, if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now, in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the autoscaling group. So that's something which we have discussed already. Now, this autoscaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now, what does autoscaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the autoscaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the autoscaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the autoscaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group autoscaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of securities also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the example. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now, the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now, first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now, I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now, click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now, open this service and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now, what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application, put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now, the usability of a worker environment can be anything. Now, we'll do a demo for creating a web server environment. So just click on Select, and we have the environment name created. Now, we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability. XYZ ABC, and it says yes, it is available. Now, once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description. It's a demo app that we are creating, and then you have to define a platform as well. Now, these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now, either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on Configure More Options. So let's click on Configure More Options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a Modify button. And here you can modify your instances with respect to the storage as well. Now, apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated, and that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now in the security groups, if you see that here the AWS Beanstalk security groups are defined. It has the elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created, and we have that environment colored in green. We'll access the environment, and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI, and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console, to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface, and then you have the command references, CLI command references, that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file, and wherever your application is hosted at, just select that, upload it, and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance, and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups on HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here, and after that you just have to upload and deploy your application, and then from that URL you can get the output. Now this URL you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL, and from there it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's in the, so we have this bundle logs in the zip file. All right, so if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Hi, this is the 4th lesson of the AWS Solutions Architect course. Migrating to the cloud doesn't mean that resources become completely separated from the local infrastructure. In fact, running applications in the cloud will be completely transparent to your end users. AWS offers a number of services to fully and seamlessly integrate your local resources with the cloud. One such service is the Amazon Virtual Private Cloud. This lesson talks about creating virtual networks that closely resemble the ones that operate in your own data centers, but with the added benefit of being able to take full advantage of AWS. So let's get started. In this lesson, you'll learn all about virtual private clouds and understand their concept. You'll know the difference between public, private, and elastic IP addresses. You'll learn about what a public and private subnet is. And you'll understand what an internet gateway is and how it's used. You'll learn what route tables are and when they are used. You'll understand what a NAT gateway is. We'll take a look at security groups and their importance. And we'll take a look at network ACLs and how they're used in Amazon VPC. We'll also review the Amazon VPC best practices and also the costs associated with running a VPC in the Amazon cloud. Welcome to the Amazon Virtual Private Cloud and Subnet section. In this section, we're going to have an overview of what Amazon VPC is and how you use it. And we're also going to have a demonstration of how to create your own custom virtual private cloud. We're going to look at IP addresses and the use of elastic IP addresses in AWS. And finally, we'll take a look at subnets, and there'll be a demonstration about how to create your own subnets in an Amazon VPC. And here are some of the terms that are used in VPCs. There's subnets, route tables, elastic IP addresses, internet gateways, NAT gateways, network ACLs, and security groups. And in the next sections, we're going to take a look at each of these and build our own custom VPC that we'll use throughout this course. Amazon defines a VPC as a virtual private cloud that enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using the scalable infrastructure of AWS. A VPC is your own virtual network in the Amazon cloud, which is used as the network layer for your EC2 resources. And this is a diagram of the default VPC. Now there's a lot going on here, so don't worry about that. What we're going to do is break down each of the individual items in this default VPC over the coming lesson. But what you need to know is that a VPC is a critical part of the exam, and you need to know all the concepts and how it differs from your own networks. Throughout this lesson, we're going to create our own VPC from scratch, which you'll need to replicate at the end of this so you can do well in the exam. Each VPC that you create is logically isolated from other virtual networks in the AWS cloud. It's fully customizable. You can select the IP address range, create subnets, configure route tables, set up network gateways, define security settings using security groups, and network access control lists. So each Amazon account comes with a default VPC that's pre-configured for you to start using straight away, so you can launch your EC2 instances without having to think about anything we mentioned in the opening section. A VPC can span multiple availability zones in a region. And here's a very basic diagram of a VPC. It isn't this simple in reality. And as we saw in the first section, here's the default Amazon VPC, which looks kind of complicated. But what we need to know at this stage is that the CIDR block for the default VPC is always a 16 subnet mask. So in this example, it's 172.31.0.0/16. What that means is this VPC will provide up to 65,536 private IP addresses. So in the coming sections, we'll take a look at all of these different items that you can see on this default VPC. But why wouldn't you just use the default VPC? Well, the default VPC is great for launching new instances when you're testing AWS. But creating a custom VPC allows you to make things more secure, and you can customize your virtual network as you can define your own IP address range. You can create your own subnets that are both private and public, and you can tighten down your security settings. By default, instances that you launch into a VPC can't communicate with your own network. So you can connect your VPCs to your existing data center using something called hardware VPN access, so that you can effectively extend your data center into the cloud and create a hybrid environment. Now to do this, you need a virtual private gateway, and this is the VPN concentrator on the Amazon side of the VPN connection. Then on your side, in your data center, you need a customer gateway, which is either a physical device or a software application that sits on your side of the VPN connection. So when you create a VPN connection, a VPN tunnel comes up when traffic is generated from your side of the connection. VPC peering is an important concept to understand. A peering connection can be made between your own VPCs or with a VPC in another AWS account, as long as it's in the same region. So what that means is, if you have instances in VPC A, they wouldn't be able to communicate with instances in VPC B or C unless you set up a peering connection. Peering is a one-to-one relationship. A VPC can have multiple peering connections to other VPCs, but, and this is important, transitive peering is not supported. In other words, VPC A can connect to B and C in this diagram, but C wouldn't be able to communicate with B unless they were directly peered. Also, VPCs with overlapping CIDRs cannot be peered. So in this diagram you can see they all have different IP ranges, which is fine, but if they had the same IP ranges, they wouldn't be able to be peered. And finally for this section, if you delete the default VPC, you have to contact AWS support to get it back again. So be careful with it and only delete it if you have good reason to do so and know what you're doing. This is a demonstration of how to create a custom VPC. So here we are, back at the Amazon Web Services Management Console. And this time we're going to go down to the bottom left where the networking section is. I'm going to click on VPC. And the VPC dashboard will load up. Now there's a couple of ways you can create a custom VPC. There's something called the VPC Wizard, which will build VPCs on your behalf from a selection of different configurations. For example, a VPC with a single public subnet, or a VPC with public and private subnets. Now this is great because you click a button, type in a few details, and it does the work for you. However, you're not going to learn much or pass the exam if this is how you do it. So We'll cancel that and we'll go to your VPCs and we'll click on Create a VPC. And we're presented with the Create a VPC window. So let's give our VPC a name. I'm going to call it SimplilearnVPC. And this is the kind of naming convention I'll be using throughout this course. Next, we need to give it the CIDR block, or the classless interdomain routing block. So we're going to give it a very simple one, 10.0.0.0, and then we need to give it the subnet mask. So you're not allowed to go larger than 15. So if I try to put 15 in, it says no, not going to happen. For a reference, subnet mask of 15 would give you around 131,000 IP addresses. And subnet 16 will give you 65,536, which is probably more than enough for what we're going to do. Next, you get to choose the tenancy. There's two options, default and dedicated. If you select dedicated, then your EC2 instances will reside on hardware that's dedicated to you. So your performance is going to be great, but your cost is going to be significantly higher. So I'm going to stick with default. And we just click on yes, create. It'll take a couple of seconds. And then in our VPC dashboard, we can see our Simplilearn VPC has been created. Now, if we go down to the bottom here to see the information about our new VPC, we can see it has a route table associated with it, which is our default route table. So there it is. And we can see that it's only allowing local traffic at the moment. We go back to the VPC again. We can see it's been given a default network ACL. And we'll click on that and have a look. And you can see this is very similar to what we looked at in the lesson. So it's allowing all traffic from all sources, inbound and outbound. Now if we go to the subnet section, and just widen the VPC area here, you can see there's no subnets associated with the VPC we just created. So that means we won't be able to launch any instances into our VPC. And to prove it, I'll just show you. We'll go to the EC2 section. So this is a glimpse into your future. This is what we'll be looking at in the next lesson. And we'll just quickly try and launch an instance. We'll select any instance, it doesn't matter. Any size, not important. So here, the network section, if I try and select Simplilearn VPC, it's saying no subnets found, this is not going to work. So we basically need to create some subnets in our VPC. And that is what we're going to look at in the next lesson. Now, private IP addresses are IP addresses that are not reachable over the internet, and they're used for communication between instances in the same network. When you launch a new instance, it's given a private IP address and an internal DNS hostname that resolves to the private IP address of the instance. But if you want to connect to this from the internet, it's not going to work. So then you'd need a public IP address, which is reachable from the internet. You can use public IP addresses for communication between your instances and the internet. Each instance that receives a public IP address is also given an external DNS hostname. Public IP addresses are associated with your instances from the Amazon pool of public IP addresses. When you stop or terminate your instance, the public IP address is released and a new one is associated when the instance starts. So if you want your instance to retain its public IP address, you need to use something called an elastic IP address. An elastic IP address is a static or persistent public IP address that's allocated to your account and can be associated to and from your instances as required. An elastic IP address remains in your account until you choose to release it. There is a charge associated with an elastic IP address if it's in your account but not actually allocated to an instance. This is a demonstration of how to create an elastic IP address. So we're back at the Amazon Web Services Management Console. We're going to head back down to the networking VPC section. and we'll get to the VPC dashboard. On the left hand side, we'll click on Elastic IPs. Now you'll see a list of any Elastic IPs that you have associated in your account, and remember, any Elastic IP address that you're using that isn't allocated to something, you'll be charged for. So I have one available, and that is allocated to an instance currently. So we want to allocate a new address, and it reminds you that there's a charge if you're not using it. I'm saying yes, allocate, and it takes a couple of seconds, and there's our new Elastic IP address. Now we'll be using this IP address to associate with the NAT gateway when we build that. AWS defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select. You can use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. The net mask for the default subnet in your VPC is always 20, which provides up to 4,096 addresses per subnet, and a few of them are reserved for AWS use. A VPC can span multiple availability zones, but a subnet is always mapped to a single availability zone. This is important to know. So here's our basic diagram, which we're now going to start adding to. So we can see the virtual private cloud, and you can see the availability zones, and now inside each availability zone we've created a subnet. Now you won't be able to launch any instances unless there are subnets in your VPC. So it's good to spread them across availability zones for redundancy and failover purposes. There's two different types of subnet, public and private. You use a public subnet for resources that must be connected to the internet, for example web servers. A public subnet is made public because the main route table sends the subnet's traffic that is destined for the internet to the internet gateway, and we'll touch on internet gateways next. Private subnets are for resources that don't need an internet connection or that you want to protect from the internet, for example database instances. So in this demonstration we're going to create some subnets, a public and a private subnet, and we're going to put them in our custom VPC in different availability zones. So we'll head to Networking and VPC, wait for the VPC dashboard to load up. We'll click on Subnets, we'll go to Create Subnet, and I'm going to give the subnet a name. So it's good to give them meaningful names. So I'm going to call this first one for the public subnet 10.0.1.0, and I'm going to put this one in the US East 1B availability zone, and I'm going to call it SimplilearnPublic. So it's quite a long name, I understand, but at least it makes it clear for what's going on in this example. So we need to choose a VPC. So we obviously want to put it in our SimpliLearn VPC. And I said I wanted to put it in US East 1B. I'm using the North Virginia region, by the way. So we click on that. Then we need to give it the CIDR block. Now, as I mentioned earlier, when I typed in the name, that's the range I want to use. And then we need to give it the subnet mask. And we're going to go with 24, which should give us 251 addresses in this range, which obviously is going to be more than enough. If I try and put a different value in that's unacceptable to Amazon, it's going to say, it's going to give me an error and tell me not to do that. Let's go back to 24 and click. I'm going to cut and paste this, by the way, just because I need to type something very similar for the next one. Click Create. And it takes a few seconds. Okay, so there's our new subnet, and I just widen this. You can see, so that's the IP range, that's the availability zone, it's for SimpliLearn, and it's public. So now we want to create the private. So I'm going to put the name in. I'm going to give the private the IP address block of that. I'm going to put this one in US East 1C, and it's going to be the private subnet. Obviously I want it to be in the same VPC. Availability zone of US East 1C. And we're going to give it 10.0.2.0/24. And we'll click Yes, Create. And again, it takes a few seconds. Okay, so let me sort by name. So there we are, we can see now we've got our private subnet and our public subnet. In fact, let me just type in Simplilearn, there we are. So now you can see them both there. And you can see they're both in the same VPC, Simplilearn VPC. Now if we go down to the bottom, you can see the route table associated with these VPCs. And you can see that they can communicate with each other internally, but there's no internet access. So that's what we need to do next. In the next lesson, you're going to learn about internet gateways and how we can make these subnets have internet access. Welcome to the networking section. In this section, we're going to take a look at internet gateways, route tables, and NAT devices. And we'll have a demonstration on how to create each of these AWS VPC items. So to allow your VPC the ability to connect to the internet, you need to attach an internet gateway. And you can only attach one internet gateway per VPC. So attaching an internet gateway is the first stage in permitting internet access to instances in your VPC. Now here's our diagram again, and now we've added the internet gateway, which is providing the connection to the internet to your VPC. But before you can configure internet correctly, there's a couple more steps. For an EC2 instance to be internet connected, you have to adhere to the following rules. Firstly, you have to attach an internet gateway to your VPC, which we just discussed. Then you need to ensure that your instances have public IP addresses or elastic IP addresses, so they're able to connect to the internet. Then you need to ensure that your subnet's route table points to the internet gateway, and you need to ensure that your network access control and security group rules allow relevant traffic to flow to and from your instance. So you need to allow the rules to let in the traffic you want, for example HTTP traffic. After the demonstration for this section, we're going to look at how route tables, access control lists, and security groups are used. In this demonstration, we're going to create an internet gateway and attach it to our custom VPC. So let's go to Networking VPC, bring up the VPC dashboard, and on the left hand side we click on Internet Gateways. So here's a couple of internet gateways I have already, but I need to create a new one. So create Internet Gateway. I'll give it a name, which is going to be Simplilearn Internet Gateway, IGW. And I'm going to click Create. So this is an internet gateway which will connect a VPC to the internet, because at the moment our custom VPC has no internet access. So there, it's created. Simplilearn IGW. But its state is detached because it's not attached to anything. So let me try and attach it to a VPC. And it gives me an option of all the VPCs that have no internet gateway attached to them currently. So I only have one, which is Simplilearn VPC. Yes, attach. Now you can see our VPC has internet attached, and you can see that down here. So let's click on that, and it will take us to our VPC. But before any instances in our VPC can access the internet, we need to ensure that our subnet route table points to the internet gateway. and we don't want to change the main route table, we want to create a custom route table, and that's what you're going to learn about next. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only be associated with one route table. However, multiple subnets can be associated with the same route table. Every VPC has a default route table, and it's good practice to leave this in its original state and create a new route table to customize the network traffic routes associated with your VPC. So here's our example, and we've added two route tables, the main route table and the custom route table. The new route table, or the custom route table, will tell the Internet Gateway to direct Internet traffic to the public subnet. But the private subnet is still associated to the default route table, the main route table, which does not allow Internet traffic to it. All traffic inside the private subnet is just remaining local. In this demonstration, we're going to create a custom route table, associate it with our Internet Gateway, and associate our public subnet with it. So let's go to Networking and VPC. The dashboard will load, and we're going to go to Route Tables. Now our VPC only has its main route table at the moment, the default one it was given at the time it was created. So we want to create a new route table, and we want to give it a name. So we're going to call it SimplilearnCloud. I'm going to call it route table, RTB for short. And then we get to pick which VPC we want to put it in. So obviously we want to use Simplilearn VPC. So we click Create. It'll take a couple of seconds, and here you are. Here's our new route table. So what we need to do now is change its route so that it points to the Internet Gateway. So if we go down here to Routes, at a minute you can see it's just like our main route table. It just has local access. So we want to click on Edit, and we want to add another route. So the destination is the Internet, which is all the zeros, and our target, and we click on this, it gives us the option of our Internet Gateway, which we want to do. So now we have Internet access to this to this route table. And we click on Save. Save was successful. So now we can see that as well as local access, we have Internet access. Now at the moment, if we click on Subnet Associations, you do not have any subnet associations. So basically, both our subnets, the public and private subnets, are associated with the main route table, which doesn't have Internet access. So we want to change this. So we'll click on Edit, and we want our public subnet to be associated with this route table. So click on Save. So it's just saving that. So now we can see that our public subnet is associated with this route table, and this route table is associated with the Internet Gateway. So now anything we launch into the public subnet will have Internet access. But what if we wanted our instances in the private subnet to have Internet access? Well, there's a way of doing that with a NAT device, and that's what we're going to look at in the next lecture. You can use a NAT device to enable instances in a private subnet to connect to the Internet or other AWS services, but prevent the Internet from initiating connections with the instances in the private subnet. So we talked earlier about public and private subnets to protect your assets from being directly connected to the Internet. For example, your web server would sit in the public subnet, and your database in the private subnet, which has no Internet connectivity. However, your private subnet database instance might still need Internet access or the ability to connect to other AWS resources. If so, you can use a Network Address Translation device, or a NAT device, to do this. A NAT device forwards traffic from your private subnet to the Internet or other AWS services, and then sends the response back to the instances. When traffic goes to the internet, the source IP address of your instance is replaced with the NAT device address, and when the internet traffic comes back again, the NAT device translates the address to your instance's private IP address. So here's our diagram, which is getting ever more complicated, and if you look in the public subnet, you can see we've now added a NAT device, and you have to put NAT devices in the public subnet so that they get internet connectivity. AWS provides two kinds of NAT devices, a NAT gateway and a NAT instance. AWS recommends a NAT gateway as it's a managed service that provides better availability and bandwidth than NAT instances. Each NAT gateway is created in a specific availability zone and is implemented with redundancy in that zone. A NAT instance is launched from a NAT AMI, an Amazon Machine Image, and runs as an instance in your VPC, so it's something else you have to look after, whereas a NAT gateway, being a fully managed service, means once it's installed, you can pretty much forget about it. A NAT gateway must be launched into a public subnet because it needs internet connectivity. It also needs an elastic IP address, which you can select at the time of launch. Once created, you need to update the route table associated with your private subnet to point internet-bound traffic to the NAT gateway. This way, the instances in your private subnets can communicate with the internet. So if you remember back to the diagram when we had the custom route table, which was pointed to the internet gateway, now we're pointing our main route table to the NAT gateway, so that the private subnet also gets internet access, but in a more secure manner. Welcome to the Create a NAT Gateway demonstration, where we're going to create a NAT gateway so that the instances in our private subnet can get internet access. So we'll start by going to Networking and VPC. And the first thing we're going to do is take a look at our subnets, and you'll see why shortly. So here are our Simplilearn subnets. So this is the private subnet that we want to give internet access, but if you remember from the section, NAT gateways need to be placed in public subnets. So I'm just going to copy the name of this subnet ID for the public subnet, and you'll see why in a moment. So then we go to NAT gateways on the left hand side, and we want to create a new NAT gateway. So we have to put a subnet in there. So we want to choose our public subnet. Now, as you can see, it truncates a lot of the subnet names on this option, so it's a bit confusing. So we know that we want to put it in our Simplilearn VPC in the public subnet, but you can see it's truncated. So it's actually this one at the bottom, but what I'm going to do is just paste in the subnet ID, which I copied earlier, so there's no confusion. Then we need to give it an elastic IP address. Now, if you remember from the earlier demonstration, we created one, so let's select that. But if you hadn't allocated one, you could click on the Create New EIP button. So we'll do that. Okay, so it's telling me my NAT gateway has been created. And in order to use your NAT gateway, ensure that you edit your route table to include a route with a target of, and then our NAT gateway ID. So it's given us the option to click on our edit route tables. So we'll go straight there. Now here's our route tables. Now, here's the custom route table that we created earlier, and this is the default, the main route table, which was created when we created our VPC. So we should probably give this a name so that we know what it is. So let me just call this Simplilearn RTB main. So now we know that's our main route table. So if you take a look at the main route table and the subnet associations, you can see that our private subnet is associated with this table. So what we need to do is put a route in here that points to the NAT gateway. So if we click on routes and edit, and we want to add another route, and we want to say that all traffic can either go to the Simplilearn internet gateway, which we don't want to do. We want to point it to our NAT instance, which is this NAT ID here, and we click save. So now any instances launched in our private subnet will be able to get internet access via our NAT gateway. Welcome to the Using Security Groups and Network ACL section. In this section, we're going to take a look at security groups and network ACLs, and we're going to have a demonstration on how you create both of these items in the Amazon Web Services console. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. Basically, a security group controls the inbound and outbound traffic for one or more EC2 instances. Security groups can be found on both the EC2 and VPC dashboards in the AWS Web Management Console. We're going to cover them here in this section, and you'll see them crop up again in the EC2 lesson. And here is our diagram, and you can see we've now added security groups to it. And you can see that EC2 instances are sitting inside the security groups, and the security groups will control what traffic flows in and out. So let's take a look at some examples, and we'll start with a security group for a web server. Now obviously a web server needs HTTP and HTTPS traffic as a minimum to be able to access it. So here is an example of the security group table, and you can see we're allowing HTTP and HTTPS, the ports that are associated with those two, and the sources, and we're allowing it from the internet. We're basically allowing all traffic to those ports. And that means any other traffic that comes in on different ports would be unable to reach the security group and the instances inside it. Let's take a look at an example for a database server security group. Now imagine you have a SQL Server database, then you would need to open up the SQL Server port so that people can access it, which is port 1433 by default. So we've added that to the table and we've allowed the source to come from the internet. Now because it's a Windows machine, you might want RDP access so you can log on and do some administration. So we've also added RDP access to the security group. Now you could leave it open to the internet, but that would mean anyone could try and hack their way into your box. So in this example, we've added a source IP address of 10.0.0.0.0. So only IP ranges from that address can RDP to the instance. Now there's a few rules associated with security groups. By default, security groups allow all outbound traffic. So if you want to tighten that down, you can do so in a similar way to you can define the inbound traffic. Security group rules are always permissive. You can't create rules that deny access, so you're allowing access rather than denying it. Security groups are stateful, so if you send a request from your instance, the response traffic for that request is allowed to flow in regardless of the inbound security group rules. And you can modify the rules of a security group at any time, and the rules are applied immediately. Welcome to the Create Security Group demonstration, where we're going to create two security groups, one to host DB servers and one to host web servers. Now if you remember from the best practices section, it said it was always a good idea to tier your applications into security groups, and that's exactly what we're going to do. So if we go to networking and VPC to bring up the VPC dashboard, on the left hand side under security we click on security groups. Now you can also get to security groups from the EC2 dashboard as well. So here's a list of my existing security groups, but we want to create a new security group, and we're going to call it SimplilearnCloud Web Server SG security group, and we'll give the group name as the same, and our description is going to be SimplilearnCloud Web Servers Security Groups. Okay, and then we need to select our VPC. Now it defaults to the default VPC, but obviously we want to put it in our Simplilearn VPC. So we click Yes, Create. Takes a couple of seconds, and there it is. There's our new security group. Now if we go down to the rules, the inbound rules, you can see there are none. So by default, a new security group has no inbound rules. But what about outbound rules? If you remember from the lesson, a new security group by default allows all traffic to be outbound. And there you are, all traffic as destination of everywhere. So all traffic is allowed. But we want to add some rules. So let's click on inbound rules, click on edit. Now this is going to be a web server. So if we click on the drop down, we need to give it HTTP. So you can either choose custom TCP rule and type in your own port ranges, or you can just use the ones they have for you. So HTTP, this pre-populates the port range. And then here you can add the source. Now if I click on it, it's giving me the option of saying allow access from different security groups. So you could create a security group and say I only accept traffic from a different security group, which is a nice way of securing things down. You could also put in here just your IP address so that only you could do HTTP requests to the instance. But because it's a web server, we want people to be able to see our website, otherwise it's not going to be much use. So we're going to say all traffic, so all source traffic can access our instance on port HTTP 80. I want to add another rule because we also want to do HTTPS, which is hiding from me. There we are. And again, we want to do the same. And also, because this is going to be a Linux instance, we want to be able to connect to the Linux instance to do some work and configuration. So we need to give it SSH access. And again, it would be good practice to tie it down to your specific IP or an IP range, but we're just going to do all for now. And then we click on save, and there we are, there we have our ranges. So now we want to create our security group for our DB servers. So let's click create security group, and then we'll go through it and give it a similar name, SimplilearnDB servers SG. And the description is going to be SimplilearnDB servers security group. And our VPC is obviously going to be Simplilearn VPC. So let's click yes, create, we'll wait a few seconds. And here's our new security group. As you can see, it has no inbound rules by default, and outbound rules allow all traffic. So this is going to be a SQL Server database server. And so we need to allow SQL Server traffic into the instance. So we need to give it Microsoft SQL port access. Now the default port for Microsoft SQL Server is 1433. Now in reality, I'd probably change the port the SQL Server was running on to make it more secure, but we'll go with this for now. And then the source. So we could choose the IP ranges again, but what we want to do is place the DB server in the private subnet and allow the traffic to come from the web server. So the web server will accept traffic, and the web server will then go to the database to get the information it needs to display on its on the website. Or if people are entering information into the website, we want the information to be stored in our DB server. So basically, we want to say that the DB servers can only accept SQL Server traffic from the web server security group. So we can select the Simplilearn Web Server Security Group as the source traffic for Microsoft SQL Server data. So we'll select that. Now our SQL Server is obviously going to be a Windows instance, so from time to time we might need to log in and configure it. So we want to give RDP access. Now again, you would probably put a specific IP range in there. We're just going to do all traffic for now. Then we click save. And there we are. So now we have two security groups, DB servers and web servers. A network ACL is a network access control list, and it's an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets. You might set up network ACLs with rules similar to your security groups in order to add an additional layer of security to your VPC. Here is our network diagram, and we've added network ACLs to the mix. Now you can see they sit somewhere between the route tables and the subnets. This diagram makes it a little bit clearer, and you can see that a network ACL sits in between a route table and a subnet. And also you can see an example of the default network ACL, which is configured to allow all traffic to flow in and out of the subnets to which it's associated. Each network ACL includes a rule, whose rule number is an asterisk. This rule ensures that if a packet doesn't match any of the other numbered rules, it's denied. You can't modify or remove this rule. So if you take a look at this table, you can see on the inbound, some traffic would come in and it would look for the first rule, which is 100. And that's saying I'm allowing all traffic from all sources. So that's fine, the traffic comes in. If that rule 100 wasn't there, it would go to the asterisk rule. And the asterisk rule is saying traffic from all sources is denied. Let's take a look at the network ACL rules. Each subnet in your VPC must be associated with an ACL. If you don't assign it to a custom ACL, it will automatically be associated to your default ACL. A subnet can only be associated with one ACL. However, an ACL can be associated with multiple subnets. An ACL contains a list of numbered rules which are evaluated in order, starting with the lowest. As soon as a rule matches traffic, it's applied regardless of any higher numbered rules that may contradict it. AWS recommends incrementing your rules by a factor of 100, so there's plenty of room to implement new rules at a later date. Unlike security groups, ACLs are stateless. Responses to allowed inbound traffic are subject to the rules for outbound traffic. Welcome to the network ACL demonstration, where we're just going to have an overview of ACLs where they are in the dashboard. Now, you don't need to know a huge amount about them for the exam, you just need to know how they work and where they are. So let's go to networking and VPC, and when the dashboard loads, on the left hand side under security there's network ACLs. So let's click on that. Now you can see some ACLs that are in my AWS account. So we want the one that's associated with our Simplilearn VPC. So if we extend this VPC column, that's our network ACL there, Simplilearn VPC. Now let's give it a name because it's not very clear to see otherwise. Also, I'm kind of an obsessive tagger, so let's call it Simplilearn ACL and click on the tick. So there we are. So now it's much easier to see. So we click on inbound rules. So this is exactly what we showed you in the lesson. The rule is 100, so that's the first rule that's going to get evaluated, and it's saying allow all traffic from all sources. And the outbound rules are the same. So if you wanted to tighten down the new rule, you could click edit. We would give it a new rule number, say, which would be 200. So you should always increment them in 100. So that means if you had 99 more rules you needed to put in place, you'd have space to put them in between these two. And then you could do whatever you wanted. You could say, you know, we are allowing HTTP access from all traffic, and we're allowing, or you could say, actually, you know what, we're going to deny it. So this is the way of blacklisting traffic into your VPC. Now I'm not going to save that because we don't need it, but this is where network ACLs sit, and this is where you would make any changes. It's also worth having a look at the subnet associations with your ACL. So we have two subnets in our Simplilearn VPC, so we would expect to see both of them associated with this network ACL because it's the default. And there they are. There's both our public and our private subnets are associated. And you can also see up here on the dashboard, it says default. So this is telling us this is our default ACL. If you did want to create a new network ACL, you would click create network ACL. You'd give it a name, just say new ACL, and then you would associate it with your VPC. So we would say Simplilearn VPC. Takes a few seconds, and there we are. There we have our new one. Now you can see this one says default no, because it obviously isn't the default ACL for our Simplilearn VPC, and it has no subnets associated with it. So let's just delete that because we don't need it. But there you are. There's a very brief overview of network ACLs. Welcome to the Amazon VPC Best Practices and Costs, where we're going to take a look at the best practices and the costs associated with the Amazon Virtual Private Cloud. Always use public and private subnets. You should use private subnets to secure resources that don't need to be available to the internet, such as database services. To provide secure internet access, to the instances that reside in your private subnets, you should provide a NAT device. When using NAT devices, you should use a NAT gateway over NAT instances because they're a managed service and require less administration effort. You should choose your CIDR blocks carefully. Amazon VPC can contain from 16 to 65,536 IP addresses, so you should choose your CIDR block according to how many instances you think you'll need. You should also create separate Amazon VPCs for development, staging, test and production, or create one Amazon VPC with separate subnets, with a subnet each for production, development, staging and test. You should understand the Amazon VPC limits. There are various limitations on the VPC components. For example, you're allowed 5 VPCs per region, 200 subnets per VPC, 200 route tables per VPC, 500 security groups per VPC, 50 in- and outbound rules per VPC. However, some of these rules can be increased by raising a ticket with AWS support. You should use security groups and network ACLs to secure the traffic coming in and out of your VPC. Amazon advises to use security groups for whitelisting traffic and network ACLs for blacklisting traffic. Amazon recommends tiering your security groups. You should create different security groups for different tiers of your infrastructure architecture inside VPC. If you have web tiers and DB tiers, you should create different security groups for each of them. Creating tier-wise security groups will increase the infrastructure security inside the Amazon VPC. So if you launch all your web servers in the web server security group, that means they'll automatically all have HTTP and HTTPS open. Conversely, the database security group will have SQL Server ports already open. You should also standardize your security group naming conventions. Following a security group naming convention allows Amazon VPC operation and management for large-scale deployments to become much easier. Always span your Amazon VPC across multiple subnets in multiple availability zones inside a region. This helps in architecting high availability inside your VPC. If you choose to create a hardware VPN connection to your VPC using Virtual Private Gateway, you are charged for each VPN connection hour that your VPN connection is provisioned and available. Each partial VPN connection hour consumed is billed as a full hour. You'll also incur standard AWS data transfer charges for all data transferred via the VPN connection. If you choose to create a NAT gateway in your VPC, you are charged for each NAT gateway hour that your NAT gateway is provisioned and available. Data processing charges apply for each gigabyte processed through the NAT gateway. Each partial NAT gateway hour consumed is billed as a full hour. This is the practice assignment for designing a custom VPC, where you'll create a custom VPC using the concepts learnt in this lesson. Using the concepts learnt in this lesson, recreate the custom VPC as shown in the demonstrations. The VPC name should be SimplilearnVPC. The CIDR block should be 10.0.0.0/16. There should be 2 subnets, one public with a range of 10.0.1.0 and one private with a range of 10.0.2.0, and they should be placed in separate availability zones. There should be one internet gateway and one NAT gateway, and also one custom route table for the public subnet. Also create 2 security groups, Simplilearn Web Server Security Group and Simplilearn DB Server Security Group.
So let's review the key takeaways from this lesson.
Amazon Virtual Private Cloud, or VPC, enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, but with the benefits of using scalable infrastructure of AWS. There are 3 types of IP address in AWS. A private IP address. This is an IP address that's not reachable over the internet, and it's used for communication between instances in the same network. A public IP address is reachable from the internet, which you can use for communication between your instances and the internet. And there's an elastic IP address. This is a static, public, persistent IP address that persists after an instance restarts, whereas a public IP address is reassociated after each restart. Amazon defines a subnet as a range of IP addresses in your VPC. You can launch AWS resources into a subnet that you select, and a subnet is always mapped to a single availability zone. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. To allow your VPC the ability to connect to the internet, you need to attach an internet gateway to it, and you can only attach one internet gateway per VPC. A route table determines where network traffic is directed. It does this by defining a set of rules. Every subnet has to be associated with a route table, and a subnet can only have an association with one route table. However, multiple subnets can be associated to the same route table. And you can use a NAT device to enable instances in a private subnet to connect to the internet or other AWS services. But a NAT device will prevent the internet from initiating connections with instances inside your private subnet. A security group acts as a virtual firewall that controls the traffic for one or more instances. You add rules to each security group that allow traffic to or from its associated instances. A Network Access Control List, or Network ACL, is an optional layer of security for your VPC that acts as a firewall for controlling traffic in and out of one or more of your subnets.
Today's session is on AWS SageMaker. Let's look into what we have in our today's session. So what's in it for you? We would be covering what is AWS, why do we need AWS SageMaker, what is AWS SageMaker services, what are the benefits of using the AWS SageMaker, machine learning with AWS SageMaker, how to train a model with AWS SageMaker, how to validate a model with AWS, and the companies that are using AWS SageMaker. Along with that, we will be covering up one live demo on the AWS platform. Now let's understand what is AWS. So what is AWS? It's an Amazon Web Services. It's the largest or most widely used public cloud platform offered by Amazon. It provides services over the internet. AWS services can be used to build, monitor, and deploy any type of application in the cloud. AWS also uses the subscription pricing model. That means you only pay for whatever the services you use for. Now, why do we need AWS SageMaker? Let's look into it. So let's consider an example of one of the company, that is ProQuest. Now, before AWS SageMaker, the ProQuest is a global information content and technology company that provides valuable content such as ebooks, newspapers, etc. to the users. Before AWS SageMaker, the ProQuest requirement was to have a better user experience, maximum relevant search results. Now, after AWS SageMaker, they were able to achieve those results. So they achieved more appealing video user experience. They achieved more relevant search results for the users. Now, what do we mean by AWS SageMaker? Why this service is primarily used? So Amazon SageMaker is a cloud machine learning platform that helps users in building, training, tuning, and deploying machine learning models in a production-ready hosted environment. So it's kind of a machine learning service which is already hosted on the AWS platform. Now, what are the benefits of using AWS SageMaker? The key benefits of using AWS SageMaker are: it reduces machine learning data cost, so you can do the cost optimization while running this particular service on the AWS. All ML components are stored in a particular place in a dashboard, so they can be managed together. Highly scalable, so it can be scalable on, you can scale this particular service on the fly. It trains the models quite faster, maintains the uptime, so you can be assured that your workloads will be running all the time, it will be available all the time. High data security, so security becomes a major concern on the cloud platforms, and it ensures that you have the high data security. Along with that, you can do a data transfer to different AWS services like S3 bucket and all with the simple data transfer techniques. Now, machine learning with AWS SageMaker, let's look into it. So machine learning with AWS SageMaker is a 3-step function. So one is to build, second is to test and tune the model, and third is to deploy the model. Now with the build, it provides more than 15 widely used ML algorithms for training purpose. Now to build a model, you can collect and prepare training data, or you can select from the Amazon S3 bucket also. Choose and optimize the required algorithm. So some of the algorithms that you can select are k-means, linear regressions, logistic regression. SageMaker helps developers to customize ML instances with the Jupyter Notebook interface. In the test and tune, you have to set up and manage the environment for training. So you would need some sample data to train the model. So train and tune a model with the Amazon SageMaker. SageMaker implements hyperparameter tuning by adding a suitable combination of algorithm parameters. Also, it divides the training data and stores that in the Amazon S3. S3 is a simple storage service which is primarily used for storing the objects and the data. Hence, it is used for storing and recovering data over the internet. And below you can see that AWS SageMaker uses Amazon S3 to store data as it's safe and secure. Also, it divides the training data and stores in Amazon S3, where the training algorithm code is stored in the ECR. ECR stands for Elastic Container Registry, which is primarily used for containers and Dockers. ECR helps users to save, monitor, and deploy Docker and the containers. Later, SageMaker sets up a cluster for the input data, trains it, and stores it in the Amazon S3 itself. So this is done by the SageMaker itself. After that, you need to deploy it. So suppose you want to predict limited data at a time, you use Amazon SageMaker hosting services for that. Okay. But if you want to get prediction for an entire data set, prefer using Amazon SageMaker batch transform. Now the last step, that is to deploy the model. So once tuning is done, models can be deployed to SageMaker endpoints. And in the endpoint, real-time prediction is performed. So you would have some data which you would reserve and validate your model whether it is working correctly or not. Now evaluate your model and determine whether you have achieved your business goals. Now the other aspect is how we can train a model with AWS SageMaker. So this is basically a flow diagram which shows you how to train a model with the AWS SageMaker. And here we have used a couple of services of an AWS to get that done. So model training in AWS SageMaker is done on machine learning compute instances. And here we can see there are two machine learning compute instances used as helper code and the training code. Along with that, we are using two S3 buckets and the ECR for the container registry. Now let's look into what are the ways to train the model as per the slides. So below are the following requirements to train a model. So here in the diagram you can see these are the following requirements to train a model. The URL of an Amazon S3 bucket where the training data is stored, that is mentioned. The compute resources on machine learning compute instances. So these are all your machine learning compute instances. Then the URL of an Amazon S3 bucket where the output will be stored. And the path of AWS Elastic Container Registry where the code data is saved. The inference code image lies in the Elastic Container Registry. Now what are these called? These are called as the training jobs. Now when a user trains a model in Amazon SageMaker, he/she creates a training job. So we need to first create a training job, and then the input data is fetched from the specified Amazon S3 bucket. Once the training job is built, Amazon SageMaker launches the ML compute instances. So these compute instances will be launched once the training job is built. Then it trains the model with the training code and the data set, and it shows the output and model artifacts in the AWS S3 bucket. So this is done automatically. Now here the helper code performs a task when the training code fails. The interference code, which is in the Elastic Container Registry, consists of multiple linear sequence containers that process the request for inference on data. The EC2 container registry is a container registry that helps users to save, monitor, and deploy container images, whereas container images are the ready applications. Once the data is trained, the output is stored in the specified Amazon S3 bucket. So here you can see the output will be stored here. To prevent your algorithm being deleted, save the data in Amazon SageMaker Critical System, which can process your ML compute instances. Now, how to validate a model? Let's look into it. So you can evaluate your model using offline or using the historical data. So first thing is that you can do the offline testing to validate a model. You can do an online testing with the live data. So if you have a live data coming or real-time streams coming, you can validate a model from there itself. You can validate using a holdout set, and also you can validate using the k-fold validation. Now use historical data to send requests to the model through the Jupyter Notebook in Amazon SageMaker for the evaluation. Online testing with live data deploys multiple models into the endpoints of Amazon SageMaker and directs live traffic to the model for validation. Validating using a holdout set is part of the data is set aside, which is called holdout set. So the part of the data is left, which is basically called as the holdout set. This data is not used for the model training. So later, when the model is trained with the remaining input data and generalize the data based on what is learned initially. So whatever the data which is left out will be used for validating a model, because we have not used that data while training a model. The k-fold validation is the input data is split into two parts. One part is called k, which is the validation data for testing the model, and the other part is k-1, which is used as a training data. Now, based on the input data, the machine learning model evaluates the final output. Now, the companies that are using AWS SageMaker, one is the ADP. So you must be knowing about ADP, Zalando, Dow Jones, which is on the stock market, ProQuest, and the Intuit. Now let's look into the demo that how we can actually run the AWS SageMaker. So we'll use the R algorithm and then package the algorithm as a container for building, training, and deploying a model. We are going to use the Jupyter Notebook for that, for model building, for model training, for model deployment, and the code for the demo is in the below link. So you can see here that from this link you can get the code for the demo. Let's try to do a demo on the AWS. Now I would be using a link which is provided by Amazon to build, train, and deploy the machine learning model on the SageMaker, as you can see on my screen. And in this tutorial, you would have some steps where you can put those steps and the code, Python codes, into your AWS SageMaker Jupyter Lab. So in this tutorial, you will learn how to use Amazon SageMaker to build, train, and deploy a machine learning model. And for that, we will use the popular XGBoost ML algorithm for this exercise. So first of all, what you need to do is you have to go to the AWS console, and there you have to create a notebook instance. So in this tutorial, you will be creating a notebook instance. You will prepare the data, train the model to learn from the data, deploy the model, evaluate your ML model's performance, and once all those activities are done, then we'll see how we can actually remove all the resources in order to prevent the extra costing. Now the first step is we have to enter to the Amazon SageMaker console. So here you can see I'm already logged in into the SageMaker console. You can click on the services, search for the SageMaker here, and here you get the Amazon SageMaker service. Now the next step is that we have to create a notebook instance. So we will select the notebook instance from the SageMaker service, and then after the notebook instance is selected, we'll put a name to our instance and we'll create a new IAM role for that. So let's wait for the SageMaker Studio to open. So here you can see the studio is open, and you just have to click on the notebook instances, and here you have to create a notebook instance. So here you can see a couple of notebook instances have already been created. One of them is in service. So this is the notebook instance that we are going to use for creating the demo model. I'll show you how you can create a notebook instance. You just have to click on create notebook instance button and put your notebook instance name. So you can put something like demo-sagemaker 987, or we can put it as model. We'll go with notebook instance type as default, which is mlt2.media. And in the permission and encryptions under the IAM role, we'll click on create a new IAM role. Now why we are creating a new IAM role? So that we can allow the SageMaker to access any S3 bucket that has been created on our account. Just click on create a role, and here you would see that the new IAM role will be created with the set of permissions. The rest of the things we'll keep it as default, and then you just have to click on create a notebook instance. The notebook instance creation takes some time, so you just have to wait for a couple of minutes to get that in service. We already have one of the notebook instance that has been created, so we will be using that to create a demo. Now going back to the steps, so these are the steps that we have already performed. Now once the notebook instance is created, then we have to prepare the data. So in this step, we will be using the SageMaker notebook instance to pre-process the data that would require to train the machine learning model. And for that, we would be opening up the Jupyter notebook, and then we have to select an environment, a kernel environment in the Jupyter notebook that would be conda_python 3. So let's follow these steps. Go back to the SageMaker, click on the notebook instances, select the running notebook instance, and here you would select the Open Jupyter Lab. Now here you would see that the SageMaker would try to open up the Jupyter notepad, and we would be performing all our inputs into that Jupyter notebook and executing the results there itself. So just wait for the notebook to open. Now here you can see the Jupyter Lab notebook has been opened. So I would be selecting one of the notebook that has been created. So this one. So likewise, you can create your own notebook also. How you can do that? First of all, let me select the kernel environment. So I would be selecting conda_python 3 and just click on select. So how you can create your own notebook? Just have to click on file, click on new, and here you can select the notebook. Just name your notebook, select the environment conda_python 3 to run this demo. So I have my notebook open. So in the tabs, I would be putting up the Python codes, and I would be executing those codes to get the output directly. So the next step is to prepare the data, train the ML model, and deploy it. We will need to import some libraries and define a few environment variables in the Jupyter notebook environment. So I would be copying this code, which you can see that would try to import NumPy, pandas. These are all required to run the Python syntax. So just copy this code and paste it into your notebook. Right? So once you do that, execute your code, and here you can see that you get the output, which is that it has imported all the necessary libraries that have been defined in the code. Now the next step is we would create an S3 bucket into the S3 service, and for that you have to copy this Python code, just that you have to edit it. So you have to specify this bucket name that you want to get created. So here I would provide the bucket name, which should be unique, should not overlap. So something like SageMaker -demo is the name that I have selected for the bucket. And now you have to execute that code. It says that the S3 bucket has been created successfully with the name SageMaker-demo 9876. So this is something which you can verify. So you can go to the S3 service, and there you can verify whether the bucket has been created or not. Now the next task is that we need to download the data to the AWS SageMaker instance and load it into the data frame. And for that, we have to follow this URL. So from this URL, which is build, train, deploy machine learning model, would have a data in the form of bank_clean.csv, and this will be deployed onto our SageMaker instance. We'll copy this code and paste it here and execute the code. So it says that it has successfully downloaded bank_clean.csv, which has the data inside it, and that has been loaded into the SageMaker data frame successfully. Now we have a data to build and train our machine learning model. So what we are going to do, we are going to shuffle the data and we are going to split it, one into the training data set and the other one into test data set. So for the training data set, we are going to use 70% of the customers that are listed in the CSV file, and 30% of the customers in the CSV file data, we will be using it as a test data to train the model. So we will copy the following code into a new code cell, and then we are going to run that code cell. So I'll just copy it for training the data so that we can segregate the data model, 70% for building the model and 30% for testing the data. So click on run the execution, and here you can see that we got the output successfully. Now we have to train the model from that data. So how we are going to train that model? And for that, we'll use SageMaker pre-built XGBoost model, which is an algorithm. So you will need to reformat the header and first column of the training data and load the data from the S3 bucket. So what I'll do is I'll copy this syntax and paste it in the node cell. So it has the train data, it would train the model. Click on run execution. Now it is changing the S3 input class, which will be renamed to training input, because now we are training the model with the training data. So we just have to wait for some time till it gets executed completely. Now the next thing is that we need to set up the Amazon SageMaker session to create an instance of the XGBoost model. So here we are going to create this SageMaker session. Say we are going to create an instance of the XGBoost model, which is an estimator. So just copy that code and paste it here. Execute it. And here you can see that it will start. It has basically changed the parameter image name to the image_URI in the SageMaker Python SDK v2. Now we'll follow the next step, that is with the data loaded in the XGBoost estimator, we'll set up train the model using gradient optimization. And we'll copy the following code, and that would actually start the training of the model. So copy this code, and this would actually start training the model using our input data that we have reserved, 70% of that data that we have reserved for training the model. So just copy that, again initiate the execution, and it will start the training job. Now we'll deploy the model, and for that I would copy the deploy code, put that in the cell, and execute it. So it says parameter image will be renamed to image URI and using already existing model. So XGBoost was deployed already. If you have not done that, if you're doing it the first time, so it will initiate another XGBoost instance. So where you can find your XGBoost endpoints created, you just have to scroll down, and here under the inference, click on the endpoints, and you should find the XGBoost endpoints defined here. So here you can see that today I have created one XGBoost endpoint, and that is now in process of creating. So just refresh it. So it is still created. It is going to take some time to get that in service. Now our endpoint is in service state, so now we can use it. So going forward with the next steps, we'll try to predict whether the customer in the test data enroll for the bank product or not. For that, we are going to copy this code, put that in the Jupyter cell function, and execute it. So here it gives you the output that it has actually evaluated, and the same output we got in the screenshot of the demo as well. Now we are going to evaluate the model performance. So what we are going to do, we are going to get the prediction done. So based on the prediction, we can conclude that you predicted a customer that will enroll for a certificate of deposit accurately for 90% of the customers in the test data, with a precision of 65% for enrolled and 90% which haven't enrolled for it. So for that, we are going to copy this code and execute it here in the cell. So if it is predicted correctly, that means our model is working absolutely fine. So here you can say the overall classification rate is 89.5%, and there is the accurate prediction that has been made by the model. And that's what the output we can see here in the screenshot of a model. So that means our model is absolutely working fine. It has been built, deployed, and trained correctly. Now the next thing is that once you are done with that, you terminate your resources, and for that you just have to copy this code and put that in the cell function, so that the additional resources and the endpoints and the buckets that have been created by the Jupyter Notepad should be terminated, so that you would not be incurred with the extra costing. So just execute it, and here you would see that it would try to terminate all the additional resources that we have created from the Jupyter Notebook. Today's tutorial is on AWS CloudFront. Let's look into what we have today in the CloudFront. So what's in it for you? We would be covering up the concept of what is AWS, what was earlier before AWS CloudFront, after AWS CloudFront, what were the services that were introduced, how it benefited. What do we mean by AWS CloudFront, benefits of the using AWS CloudFront, and how AWS CloudFront actually is known as a content delivery service, the name of the companies that are using AWS CloudFront, and we would be covering up one live demo. Now, AWS is the Amazon Web Services. It's a cloud service provider that basically offers a multiple services, variety of services, such as compute power, database storage, networking, and other resources, so that you can create your solutions on the cloud and help the business grow. Now, with AWS, you only pay for whatever the services you use. So for example, if you're using a service for a couple of hours, then you pay for only that many hours that you have used that service. Before AWS CloudFront, so there is an example that we are going to talk, and that is you must be aware of an application called Spotify. So when you used to access Spotify, and when you click on it, it kept on loading, and at the end you used to get the error. And the error was that the connection failed. And why you received that error? Because of a latency issue, probably a network error, right? So how you can solve these kind of a latency issues, and that is also going to, these kind of an issues are also going to impact the performance of an application. So with the introduction of AWS CloudFront, this problem of loading the application got resolved. So after AWS CloudFront, with the help of AWS CloudFront, Spotify gives the facility of updating new features, access to million songs that you can access instantly. So with the use of AWS CloudFront, the latency issues were solved, and successfully you can basically access your application. Now, what we mean by AWS CloudFront? So AWS CloudFront is a globally distributed network that is offered by AWS, Amazon Web Services, which securely delivers content to the end users across any geography with a higher transfer speed and an improved or a low latency. Now, what are the benefits of AWS CloudFront? There are multiple benefits. One is the cost effective. So it helps you to do the cost optimization when you use the CloudFront. It is time saving, so it is implemented easily, and also a lot of issues with respect to accessing the application with respect to latency and all can be resolved. Content privacy, so the content is placed to the end users and also to the CloudFront servers in a secured manner, in a secured way. It is highly programmable, and you can make the changes, amend the changes on the fly. and you can target any location, any geography across the globe. Along with that, it helps you to get the content deliver quickly. Now, how AWS CloudFront delivers the content? Let's look into the architecture. So this is a flow, and the flow is with respect to how the user is going to get a content from the CloudFront. Now, the client first access a website by typing a URL on the browser, and in the step 1, it tries to access the application. Then the client requests, when the website is open, the client requests for an object to download, such as, for example, a particular file. Now, at that time, the DNS routes user request to download that file to AWS CloudFront. The AWS CloudFront connects to the nearest edge locations. Edge locations are basically the servers where it caches the files, documents, and the web codes. AWS CloudFront connects to its nearest edge location in order to serve the user the request. At edge location, AWS CloudFront looks for its requested cache file. Once the file is found, let's say if the file is available in the cache of an edge location, AWS CloudFront then sends the file to the user. Otherwise, if the file is not found in the cache memory of an edge location, AWS CloudFront compares the requirement with the specification and share it with a respected server. That means a web server or a server where the file is actually available. The web server responds to the edge location by sending the file back to the CloudFront edge location. And then as soon as the AWS CloudFront receives the file, it shares with the client, also adds the file to the cache of an edge location for a future reference. This is how the flow of a CloudFront is. Now, the name of the companies that are using the AWS CloudFront. So one of them is Geo7 app, which is a very popular app. So it uses Amazon CloudFront to deliver 15 petabytes of audio and video to its subscribers globally, which is a huge data. Sky News, it uses the service in order to unify the content for faster distribution to subscribers. The Discovery Communications also uses the CloudFront. It uses the service for delivering API, static asset, and also the dynamic content. And then the TV1 EU, Streaming Europe, is basically also uses the CloudFront service that helps in improving latency and performance that results in fastest delivery of content. Now let's look into the demo how to use CloudFront to serve private S3 bucket as a website. Now I'm going to run a CloudFront distribution demo on the AWS console, and we'll basically try to deliver the content from a private S3 bucket and then map that with the domain name using the Route 53 service. So what we need for this demo, we would need a domain URL, we would need a Route 53 service, we would need CloudFront, we have to create a CloudFront distribution, and that will be linked with our S3 bucket, the private S3 bucket, right? And in the S3 bucket, we would have one HTML file, the index.html file. So let's move into AWS console. So right now I have opened up the CloudFront distribution, and here you can see that couple of distributions have already been created. So what I'm going to do, I'm going to create a distribution. Now there are two types of delivery method for your content. One is the web distribution and the other one is RTMP. RTMP stands for real-time audio or video distribution. It's basically used for distribution of a media content or a media file which are available in the S3 bucket. Here we are going to select a web distribution because primarily we will be using files which uses protocols HTTP or the HTTPS. So you have to click on Get Started, and in the origin domain name you have to specify the bucket where your code is available. So I have a bucket already created. Here you can do is you have to create a bucket with the URL name or the domain name which you would be mapping with the Route 53 service. So this is a bucket that has already been created. Let me show you in a new tab. So here you have to go to the storage. Under the storage, you have to select the S3 bucket. Let's open the link in the new tab and let's look into how we can create the S3 buckets. Now here are a couple of buckets already created. I have created one bucket with the domain name that I'm going to use and map it with the Route 53 service. So that is basically mapped to a region which is in Ohio. And if you open up this bucket, here you will find an HTML web page. The index.html has been already added, right? So similarly, you have to create a bucket with a domain, and an index.html page needs to be uploaded there. Now again, we'll go to the CloudFront. We'll try to create a distribution. Just have to click on create distribution. Select a web delivery method. Select an origin domain, which is sunshinelearning.in, and origin path you don't have to specify. Origin ID is this one. So basically, when you define an origin domain name, automatically the origin ID appears. You can customize this origin ID as per your requirement also. So rest of the things, primarily we keep it as a default settings only until and unless if we require some customized settings to be done. So let's say if you have to change the cache behavior settings, you can do that. Otherwise, we'll keep it as default. Now in the distribution setting, you can either select use all edge locations for the best performance. So what does AWS basically do here? It uses all the edge locations which are associated with AWS across the globe. Otherwise, you can specify based on the regions also, right? Apart from that, if you want to enable firewalls or the access control list, you can specify here. And then what you need to do is, in the default root object, here you have to specify your index.html page, which is in the S3 bucket. The distribution state has to be enabled, and if you want to use IP version 6 as well, you need to enable it. Click on create a distribution. Now you can see here a distribution has been created. It's in progress and it is enabled. And it takes around 15 to 20 minutes to get that distribution completed. The reason is that the web codes, the web pages will be distributed across all the edge locations across the globe. So hence it takes time to get that done, right? Well, let's move on to Route 53 service, and let's create the hosted zones. So we'll type Route 53 here, scalable DNS and domain name registration. And what we are going to do here is we are going to map our URL, the domains pointed to the name servers that will be provided by the Route 53. So we have to create a hosted zone. Let's wait for it. So now the Route 53 dashboard is open, and you can see one hosted zone is already created. So just click on the hosted zones. And in order to point the traffic from the external domains towards the AWS, you have to first point the domains traffic to the hosted zone in the Route 53. So I'll click on create hosted zone, but before that I will first delete the existing one, and then I'll create another record, another hosted zone, right? Put your domain name. Let's say I put as sunshinelearning.in, and it is acting as a public hosted zone. Rest of the things will be default. Click on create hosted zone. Now it gives you 4 name servers, and these 4 name servers has to be updated in the domain. So you have to update these name servers in a platform from where you have purchased the domain, right? So this is half of the work done. Then what you need to do is you have to go and create records. Now in the records you can select a routing policy. So right now what we are targeting basically that the traffic from the domain should be pointed directly towards the CloudFront distribution. Hence we are going with a simple routing right now. Click on next. Here you have to specify the record sets. So we are going to create the records. just click on default simple record, put here as World Wide Web, and you have to select an endpoint. So endpoint we are selecting for the CloudFront distribution. So we have to specify alias for the CloudFront distribution. Now here we are going to put the CloudFront distribution URL, and then we are going to define the simple record set. So what we need is we need a CloudFront distribution URL, which you can find it from the CloudFront service itself, and you can find the domain name here itself. You just have to copy that and then paste it here in the distribution, and then just click on define simple records. Again, click on create records, and here you can see the record set has been updated. Now this domain is basically pointed towards these name servers, which are further pointed towards the CloudFront distribution. Right now, the only thing which is left is that within the domain, from wherever you have purchased the domain, you should update these 4 name servers, and then you can see the live traffic coming on this domain will have an output from the CloudFront distribution.
Today's topic is on AWS autoscaling. So this is Akhil. I would be taking up a tutorial on the autoscaling. Let's begin with our tutorial, and let's look into what we have in today's session. So I would be covering up why we require AWS autoscaling, what is AWS autoscaling, what are the benefits of using the scaling service, how this autoscaling works, the different scaling plans we have, what is the difference between the snapshot and the AMI, what is a load balancer, and how many types of load balancers we have, and along with that I would be covering up a real live demo on the AWS. Let's begin with why we require AWS autoscaling. Now, before AWS cloud scaling, there was a question in the mind of enterprises that they were spending a lot of money on the purchase of the infrastructure. If they have to set up some kind of a solution, so they have to purchase an infrastructure, and a one-time cost was required. So that was a burden for them in terms of procuring a server, hardware, software, and then having a team of experts to manage all those infrastructure. So they used to think that no longer they require these resources if there was a cost-efficient solution for their project. That was the project manager used to think. Now, after the AWS cloud scaling that was introduced, automatically the autoscaling maintains the application performance based on the user requirements at the lowest possible price. So what does the autoscaling does is that whenever there is a scalability required, it manages it automatically, and hence the cost optimization became possible. Now, what is AWS autoscaling? Let's look into deep. So AWS autoscaling is a service that helps users to monitor their applications and the servers and automatically adjust the capacity of their infrastructure to maintain the steadiness. So they can increase the capacity, they can even decrease the capacity also for the cost optimization. And also predictable performance at the lowest possible cost. Now, what are the benefits of autoscaling? It gave the better fault tolerance applications. You can get the servers created and you can have a clone copy of the servers so that you don't have to deploy the applications again and again. Better cost management because the scalability is decided by the AWS automatically based on some threshold parameters. It was a reliable service, and whenever the scaling is created or initiated, you can get the notifications onto your mail IDs or to your cell phones. Scalability, as I mentioned, is always there in the autoscaling. It can scale up, it can scale down as well. And it has the flexibility in terms of whenever you want to schedule it, if you want to stop it, if you want to keep the size of the servers at a fixed number, you can always make the changes on the fly. And the better availability. Now, with the use of the autoscaling, we come around with the terminology called snapshot and the AMI. Let's look into the difference between the snapshots and the AMI. Snapshots versus AMI. So in a company, there was one of the employee that was facing an issue with launching the virtual machines. So he asked his colleague a question
Is it possible to launch multiple virtual machines with a minimum amount of time? Because it takes a lot of time in terms of creating the virtual machines. The other colleague said that yes, it is possible to launch multiple EC2 instances, and that can be done at a lesser time and with the same configuration. And this can be done either you use a snapshot or the AMI on the AWS. Then the colleague said that what are the differences between the snapshot and AMI? Let's look into the difference now. The snapshots basically kind of a backup of a single EBS volume, which is just like a virtual hard drive that is attached to the EC2 instance. Whereas the AMI, it is basically used as a backup of an EC2 instance only. The snapshots opts for this when the instance contains multiple static EBS volumes. When you opt for the snapshot, whenever the instance contains multiple static EBS volumes. AMI, this is widely used to replace the failed EC2 instance. In the snapshots, here you pay only for the storage of the modified data, whereas with the AMI, you pay only for the storage that you use. The snapshots are non-bootable images on EBS volume, whereas AMI are bootable images on the EC2 instance. However, creating an AMI image will also create the EBS snapshots. Now, how does AWS autoscaling work? Let's look into it. So for the AWS autoscaling to work, you have to configure single unified scaling policy per application resource. And this scaling policy, with that you can explore the applications also. And then select the service you want to scale. Also, for the optimization, select do you want to optimize the cost or do you want to optimize the performance. And then keep track of scaling by monitoring or getting the notifications. Now, what are the different scaling plans we have? So in the autoscaling, a scaling plan basically helps a user to configure a set of instructions for scaling based on the particular software requirement. The scaling strategy basically guides the service of AWS autoscaling on how to optimize resources in a particular application. So it's basically kind of the parameters that you set it up so that how the resource optimization can be achieved in the autoscaling. With the scaling strategies, users can create their own strategy based on their required metrics and thresholds, and this can be changed on the fly as well. What are the two types of scaling policies we have? So there are basically dynamic scaling and the predictive scaling. Now, what is dynamic scaling? It basically guides the service of AWS autoscaling on how to optimize the resources. And it is helpful in optimizing resources for availability and particular price. Now, with scaling strategies, users can create their plan based on the required metrics and thresholds. So a metric can be like, let's say, a network in, network out, or it can be a CPU utilization, memory utilization likewise. Now, in the predictive scaling, its objective is to predict future workload based on daily and weekly trends and regular forecast future network traffic. So it is kind of a forecast that happens based on the previous past experiences. It uses a machine learning technique for analyzing that network traffic, and this scaling is like how weather forecast works, right? It provides schedule scaling actions to ensure the resource capacity is available for application requirement. Now, with the auto scaling, you would need the load balancers also, because if there are multiple instances that are created, then you would need a load balancer to distribute the load to those instances. So let's understand what do we mean by a load balancer. A load balancer basically acts as a reverse proxy, and it is responsible for distributing the network or the application traffic across multiple servers. With the help of a load balancer, you can achieve a reliability, you can achieve a fault tolerance of an application. That is basically, it increases the fault tolerance and the reliability. So for example, when there is a high network traffic that is coming to your application, and if that much traffic comes to your application to the instances, your instances may crash. So how you can avoid that situation? So you need to manage the network traffic that is coming to your instances, and that can be done with the load balancer. So thanks to the AWS load balancers, which helps in distributing network traffic across backend servers in a way that it increases performance of an application. Here in the image, you can see the traffic coming from different resources landing onto the EC2 instance, And the load balancer is actually distributing that traffic to all the three instances, hence managing the network traffic quite properly. Now, what are the types of load balancers we have? There are three types of load balancers on the AWS. One is the classic load balancer, second is the application load balancer, and the third one is the network load balancer. Let's look into what we have in the classic load balancer. So the classic load balancer is the most basic form of load balancing, and we call it as a primitive load balancer also. And it is widely used for the EC2 instances. It is based on the IP address and the TCP port, and it routes network traffic between end users as well as in between the backend servers. And it does not support host-based routing, and it results in low efficiency of resources. Let's look into what we have in the application load balancer. This is one of the advanced forms of load balancing. It performs the task on the application level in the OSI model. It is used when there are HTTP and HTTPS traffic routing is required, and also it supports the host-based and path-based routing and performs well with the microservices or the backend applications. The network load balancer performs the task at layer 4 of the connection level in the OSI model. The prime role of the network load balancer is to route the TCP traffic, and it can manage a massive amount of traffic and is also suitable to manage the low latencies. Let's look into the demo and see how practically we can create the autoscaling. Hi guys, let's look into the demo for how we can create an autoscaling on the AWS console. So right now I'm logged into the AWS console and I am in the Mumbai region. What you need to do is you have to go to the compute section, and under that click on the EC2 service. Let's wait for the EC2 service to come. Now just scroll down, and under the load balancing there is an option called autoscaling. So there first you have to create a launch configuration, and then after that you have to create the autoscaling groups. So click on launch configuration, and then you have to click on create launch configurations. So click on create launch configuration. Now this launch configuration is basically the set of parameters that you define while launching an autoscaling, so that this uniformity is maintained with all the instances. So that includes, let's say if you select a Windows OS or a Linux OS, that particular type of an operating system will be implemented in all the instances that will be part of an autoscaling. So there are certain set of parameters that we have to specify during the launch configuration, so that we can have a uniformity in terms of launching the servers. So here I would select an Amazon Linux AMI, and then I would select the type of a server, which will be t2.micro. Click on configure details, put the name to the launch configuration. Let's say we put it as a demo, and the rest of the things we'll keep it default. Click on add storage. Since it's a Linux AMI, we can go with the 8 GB storage. That should be fine. Click on configure security group. Let's create a new security group which has the SSH port open, and that is open for anywhere, which is basically source IPv4 and IPv6 IPs. Any IP would be able to access that. Click on review. Just review your launch configuration. If you want to make changes, you can do that. Otherwise, click on create a launch configuration. You would need the key pair, and this key pair will be a unique key pair which will be used with all the instances that are part of the autoscaling group. So we can select an existing key pair if you have that. Otherwise, you can create a new key pair. So I have an existing key pair. I'll go with that, acknowledge it, and click on create launch configuration. Now we have successfully launched the configuration of an autoscaling. The next thing is to create an autoscaling group. So click on create an autoscaling group using this launch configuration. Put a group name. Let's say we put something like test, and the group size to start with, it says one instance, so that means at least a single instance will always be running, and it will be initiated and running 24/7 till the autoscaling is available. You can increase the size of the minimum base instances also. Let's say you can change it to 2 also, so you would get at least 2 servers running all the time. So we'll go with the one instance. The network would be the VPC default, and
In the VPC particular region, we can select the availability zones. So let's say if I select availability zone 1A and then availability zone 1B. So how the instances will be launched? So one instance will be launched in 1A, the other one in the 1B, the third one in the 1A, fourth one in the 1B. Likewise, it will be equally spread among the availability zones. Next part is to configure the scaling policies. So click on it. If you want to keep this group at its initial size, let's say if you want to go with only a single instance or two instances and you don't want the scaling to progress, you can put it, keep this group at its initial size. So this is basically a way to halt the scaling. But we'll use the scaling policies to adjust the capacity of this group. So click on it. And we would scale between, let's say, minimum one instance that we have, and we'll scale it between 1 to 4 instances. And what condition, on what basis these instances will be scaled up or scaled down would be defined in the scale group size. So the scaling policies you can implement based on a scale group size or using the simple scaling policies using the steps. So in the scale group size, you have certain metrics. You can use average CPU utilization. You can define a metric related to average network in, average network out, or the load balancer request counts per target. And if you create the simple scaling policies using steps, then you need to create the alarms, and there you can get some more metrics that you can add up as a parameter for the auto scaling. Let's go with the scaling group size. Let's go with the metric type as average CPU utilization, and the target value here you have to specify what would be the threshold that when the instance CPU utilization is crossed, then a new instance should be initiated. So you can put a reasonable threshold for that. Let's say we put something like 85%, and whenever the instance CPU utilization is crossed 85% threshold, you will see that there will be a new instance created. Let's go to the next configure notifications, and here you can add notifications. So let's say if there is a new instance that is initiated and you want to basically be notified, so you can get notifications over your email IDs, or you can get it on the cell phones. So for that, for adding the notification, you would need the SNS service, and that is called as a simple notification service. And you have to create a topic there. You have to subscribe for the topic using your email ID, and then you should get the notifications. Click on configure tags. The tags are not mandatory. You can basically put a tag. Let's say if you want to identify the instance or purpose it was created. Otherwise, you can leave it blank also. Click on review and review your scaling policies, notification, tags, as well as the scaling group details. Click on create auto scaling group, and here you go. Your scaling has been launched. Click on close, and you should get at least a single instance initiated automatically by the auto scaling. So let's wait for the details to appear. So here you can see our launch configuration name, demo, auto scaling group name, test, minimum instance we want 1, the maximum instances we want 4. We have selected 2 availability zones, AP South 1A, AP South 1B, and the instance 1 has been initiated. And if you want to verify where exactly this instance has been initiated, just click on the instances here, and here you will see that a single instance has been initiated, that is in service, and that has been initiated in AP South 1B. Now once the threshold of this instance crosses 85%, that is what we have defined in the scaling policies, then you should see that another instance will be initiated. So likewise, this is basically I have created steps to initiate a scaling policy, that means to increase the number of servers whenever the threshold crosses. Likewise, here itself you can add another policy to scale down the resources in case if the CPU utilization goes to a normal value.
Today we are going to discuss about Amazon Redshift, which is one of the data warehouse service on the AWS. So let's begin with Amazon Redshift, and let's see what we have for today's session. So what's in it for you today? We'll see what is AWS, why we require Amazon Redshift, what do we mean by Amazon Redshift,
the advantages of Amazon Redshift, the architecture of Amazon Redshift, some of the additional concepts associated with the Redshift, and the companies that are using the Amazon Redshift. And finally, we'll cover up one demo which will show you the practical example that how you can actually use the Redshift service. Now, what is AWS? As we know that AWS stands for Amazon Web Service. It's one of the largest cloud providers in the market, and it's basically a secure cloud service platform provided from the Amazon. Also, on the AWS, you can create and deploy the applications using the AWS service. Along with that, you can access the services provided by the AWS over the public network, that is, over the internet. They are accessible. Plus, you pay only whatever the service you use for. Now, let's understand why we require Amazon Redshift. So earlier, before Amazon Redshift, what used to happen that the people used to, or the developers used to fetch the data from the data warehouse. So data warehouse is basically a terminology which is basically represents the collection of the data. So a repository where the data is stored is generally called as a data warehouse. Now, fetching data from the data warehouse was a complicated task because might be a possibility that the developer is located at a different geography and the data warehouse is at a different location, and probably there is not that much network connectivity or some networking challenges, internet connectivity challenges, security challenges might be, and a lot of maintenance was required to manage the data warehouses. So what were the cons of the traditional data warehouse services? It was time consuming to download or get the data from the data warehouse. Maintenance cost was high, and there was the possibility of loss of information in between the downloading of the data, and the data rigidity was an issue. Now, how these problems could overcome, and this was basically solved with the introduction of Amazon Redshift over the cloud platform. Now, we say that Amazon Redshift has solved traditional data warehouse problems that the developers were facing, but how? What is Amazon Redshift actually is? So what is Amazon Redshift? It is one of the services over the AWS, Amazon Web Services, which is called as a data warehouse service. So Amazon Redshift is a cloud-based service or a data warehouse service that is primarily used for collecting and storing the large chunk of data. So it also helps you to get or extract the data, analyze the data using some of the BI tools. So business intelligence tools you can use and get the data from the Redshift and process that. And hence it simplifies the process of handling the large scale data sets. So this is the symbol for the Amazon Redshift over the AWS. Now let's discuss about one of the use case. So DNA is basically a telecommunication company, and they were facing an issue with managing their website and also the Amazon S3 data, which led down to slow process of their applications. Now, how could they overcome this problem? Let's see that. So they overcome this issue by using the Amazon Redshift, and all the company noticed that there was a 52% increase in the application performance. Now, did you know that Amazon Redshift is basically cost less to operate than any other cloud data warehouse service available on the cloud computing platforms? And also the performance of an Amazon Redshift is the fastest data warehouse, we can say that is available as of now. So in both cases, one is that it saves the cost as compared to the traditional data warehouses, and also the performance of this Redshift service or a data warehouse service, the fastest available on the cloud platforms. And more than 15,000 customers presently they are using the Amazon Redshift service. Now let's understand some of the advantages of Amazon Redshift. First of all, as we saw that it is one of the fastest available data warehouse service, so it has the high performance. Second is, it is a low cost service. So you can have a large scale of data warehouse or the databases combined in a data warehouse at a very low cost. So whatever you use, you pay for that only. Scalability. Now, in case if you wanted to increase the nodes of the databases in your Redshift, you can actually increase that based on your requirement, and that is on the fly. So you don't have to wait for the procurement of any kind of a hardware or the infrastructure. It is whenever you require, you can scale up or scale down the resources. So the scalability is again one of the advantage of the Amazon Redshift. Availability, since it's available across multiple availability zones, so it makes this service as a highly available service. Security. So whenever you access Redshift, you create a clusters in the Redshift, and the clusters are created in you can define a specific virtual private cloud for your cluster.
and you can create your own security groups and attach it to your cluster. So you can design the security parameters based on your requirement, and you can get your data warehouse or the data items in a secured place. Flexibility, and you can remove the clusters, you can create another clusters. If you are deleting a cluster, you can take a snapshot of it and you can move those snapshots to different regions. So that much flexibility is available on the AWS for the service. And the other advantage is that it is basically a very simple way to do a database migration. So if you're planning that you wanted to migrate your databases from the traditional data center over the cloud on the Redshift, it is basically very simple to do a database migration. You can have some of the inbuilt tools available on the AWS, you can connect them with your traditional data center and get that data migrated directly to the Redshift. Now let's understand the architecture of the Amazon Redshift. So architecture of an Amazon Redshift is basically it combines of a cluster, and that we call it as a data warehouse cluster. In this picture, you can see that this is a data warehouse cluster and this is a representation of a Amazon Redshift. So it has some of the compute nodes which does the data processing, and a leader node which gives the instructions to these compute nodes. And also the leader node basically manages the client applications that require the data from the Redshift. So let's understand about the components of the Redshift. The client application of Amazon Redshift basically interact with the leader node using JDBC or the ODBC. Now what is JDBC? It's a Java database connectivity, and the ODBC stands for Open Database Connectivity. The Amazon Redshift service using a JDBC connector can monitor the connections from the other client applications. So the leader node can actually have a check on the client applications using the JDBC connections. Whereas the ODBC allows a leader node to have a direct interaction or to have a live interaction with the Amazon Redshift. So ODBC allows a user to interact with live data of Amazon Redshift. So it has a direct connectivity, direct access of the applications, as well as the leader node can get the information from the compute nodes. Now, what are these compute nodes? These are basically kind of a databases which does the processing. So Amazon Redshift has a set of computing resources which we call it as a nodes, and the nodes, when they are combined together, they are called it as a clusters. Now a cluster, a set of computing resources which are called as nodes, and this gathers into a group which we call it as a data warehouse cluster. So you can have a compute node starting from 1 to n number of nodes, and that's why we call that the Redshift is a scalable service, because we can scale up the compute nodes whenever we require. Now the data warehouse cluster, or each cluster, has one or more databases in the form of a nodes. Now what is a leader node? This node basically manages the interaction between the client application and the compute node. So it acts as a bridge between the client application and the compute nodes. Also, it analyzes and develops designs in order to carry out any kind of a database operations. So leader node basically sends out the instructions to the compute nodes, basically perform or execute that instruction and give that output to the leader node. So that is what we are going to see in the next slide, that the leader node runs the program and assign the code to individual compute nodes, and the compute nodes execute the program and share the result back to the leader node for the final aggregation, and then it is delivered to the client application for analytics or whatever the client application is created for. So compute nodes are basically categorized into slices, and each node slice is allotted with specific memory space, or you can say a storage space, where the data is processed. These node slices works in parallel in order to finish their work, and hence when we talk about a Redshift as a faster processing capability as compared to other data warehouses or traditional data warehouses, this is because that these node slices work in a parallel operation that makes it more faster. Now, the additional concept associated with Amazon Redshift is there are two additional concepts associated with the Redshift. One is called as the column storage and the other one is called as the compression. Let's see what is the column storage. As the name suggests, column storage is basically kind of a data storage in the form of a column, so that whenever we run a query, it becomes easier to pull out the data from the columns. So column storage is an essential factor in optimizing query performance and resulting in quicker output. So one of the examples are mentioned here. So below example show how database tables store record into disk block by row. So here you can see that if we wanted to pull out some kind of an information based on the city, address, age, we can basically create a filter, and from there we can put out the details that we require, and that is going to fetch out the details based on the column storage. So that makes data more structured, more streamlined, and it becomes very easier to run a query and get that output. Now the compression is basically to save the column storage. We can use a compression as an attribute. So compression is a column level operation which decreases the storage requirement, and hence it improves the query performance. And this is one of the syntax for the column compression. Now the companies that are using Amazon Redshift, one is LYA, the other one is Equinox, the third one is the Pfizer, which is one of the famous pharmaceuticals company. McDonald's, one of the burger chains across the globe, and Philips, it's an electronic company. So these are one of the biggest companies that are basically relying and they are putting their data on the Redshift data warehouse service. Now in another video, we'll see the demo for using the Amazon Redshift. Let's look into the Amazon Redshift demo. So these are the steps that we need to follow for creating the Amazon Redshift cluster. And in this demo, what we'll be doing is that we'll be creating an IAM role for the Redshift so that the Redshift can call the services, and specifically we'll be using the S3 service. So the role that we'll be creating, we'll be giving the permission to Redshift to have an access of an S3 in the read-only format. So in the step one, what we require, we'll check the prerequisites, and what you need to have is the AWS credentials. If you don't have that, you need to create your own credentials, and you can use your credit and the debit card. And then in the step two, we'll proceed with the IAM role for the Amazon Redshift. Once the role is created, we'll launch a sample Amazon Redshift cluster mentioned in the step 3, and then we'll assign a VPC security groups to our cluster. Now you can create it in the default VPC also, you can create a default security groups also, otherwise you can customize the security groups based on your requirement. Now to connect to the sample cluster, you need to run the queries, and you can connect to your cluster and run queries on the AWS Management Console query editor, which you will find it in the Redshift only. Or if you use the query editor, you don't have to download and set up a SQL client application separately. And in the step 6, what you can do is you can copy the data from the S3 and upload that in the Redshift, because the Redshift would have an access, a read-only access for the S3, as that will be created in the IAM role. So let's see how we can actually use the Redshift on the AWS. So I am already logged into my account. I am in North Virginia region. I'll search for Redshift service, and here I find Amazon Redshift. So just click on it. Let's wait for the Redshift to come. Now this is a Redshift dashboard, and from here itself you have to run the cluster. So to launch a cluster, you just have to click on this launch cluster, and once the cluster is created, and if you wanted to run queries, you can open query editor, or you can basically create queries and access the data from the Redshift. So that's what it was mentioned in the steps also, that you don't require a separate SQL client application to get the queries run on the data warehouse. Now, before creating a cluster, we need to create the role. So what we'll do is we'll click on the services and we'll move to IAM role section. So IAM role I can find here under the security, identity and compliance. So just click on the identity access management and then click on create roles. So let's wait for IAM page to open. So here in the IAM dashboard, you just have to click on the roles. I already have the role created. So what I'll do is I'll delete this role and I'll create it separately. So just click on a create role, and under the AWS services, you have to select for the Redshift, because now the Redshift will be calling the other services, and that's why we are creating the role. Now, which other services that the Redshift will be having an access of? S3. Why? Because we'll be putting up the data on the S3, and that is something which needs to be uploaded on the Redshift. So we'll just search for the Redshift service, and we can find it here. So just click on it, and then click on Redshift customizable in the use case. Now click on next permissions, and here in the permissions, give the access to this role, assign the permissions to this role in the form of an S3 read-only access. So you can search here for the S3 also. Let's wait for the policies to come in. Here it is. Let's type S3. And here we can find Amazon S3 read-only access. So just click on it and assign the permissions to this role. Tags, you can leave them blank. Click on next review. Put a name to your role. Let's put my Redshift role and click on a create role. Now you can see that your role has been created. Now the next step is that we'll move to Redshift service and we'll create one cluster. So click on the services Click on Amazon Redshift. You can find that in the history section since we browsed it just now. And from here, we are going to create a sample cluster. Now, to launch a cluster, you just have to click on launch this cluster. Whatever the uncompressed data size you want in the form of a gigabyte, terabyte, or petabyte, you can select that. And let's say if you select in the form of GB, how much GB memory you want, you can define it here itself. This also gives you the information about the costing. On demand is basically pay as you use. So they are going to charge you $0.5 per hour for using the 2 node slices. So let's click on launch this cluster, and this will be a DC2.large kind of an instance that will be given to you. It would be in the form of a solid state drive, SSDs, which is one of the fastest way of storing the information. And the nodes 2 are mentioned by default. That means there will be 2 node slices that will be created in a cluster. You can increase them also. Let's say if I put 3 node slices, so it is going to give us 3 into 0.16 TB per node storage. Now here you have to define the master username password for your Redshift cluster, and you have to follow the password instructions. So I would put a password to this cluster, and if it accepts, that means it does not give you any kind of a warning. Otherwise it is going to tell you about you have to use the ASCII characters and all. And here you have to assign this cluster the role that we created recently. So in the available IAM roles, you just have to click on my Redshift role, and then you have to launch the cluster. If you wanted to change something in with respect to the default settings, let's say if you wanted to change the VPC from default VPC to your custom VPC, and you wanted to change the default security groups to your own security groups, so you can switch to advanced settings and do that modification. Now let's launch the cluster, and here you can see the Redshift cluster is being created. Now if you wanted to run queries on this Redshift cluster, so you don't require a separate SQL client, you just have to follow the simple steps to run a query editor, and the query editor you will find it on the dashboard. So let's click on the cluster, and here you would see that the Redshift cluster would be created with the 3 nodes in the US East 1B availability zone. So we have created the Redshift cluster in the Ohio region, and now what we'll do is we'll see how we can create the tables inside the Redshift, and we'll see how we can use the copy command so that we can directly move the data uploaded on the S3 bucket to the Redshift database tables, and then we'll query the results of a table as well. So how we can do that? First of all, after creating the Redshift cluster, we have to install SQL Workbench /J. This is not a MySQL, which is managed by Oracle, and you can find this on the Google. You can download it from there. And then you have to connect this client with the Redshift database. How you can do? Click on File, click on Connect Window, and after connecting a window, you have to paste the URL, which is a JDBC driver. This driver link, you can find it onto the AWS console. So if you open up a Redshift cluster, there you would find the JDBC driver link. Let's wait for it. So this is our cluster created. Let's open it, and here you can find this JDBC URL. And also make sure that in the security groups of a Redshift, you have the port 5439 open for the traffic, incoming traffic. You also need to have the Amazon Redshift driver, and this is the link where you can download the driver and specify the path. Once you are done with that, you provide the username and the password that you created while creating the Redshift cluster. Click on OK. So this connects with the database, and now the database connection is almost completed. Now what we will be doing in the SQL Workbench, we'll be first creating the sales table, and then in the sales table, we'll be adding up the entries copied from the S3 bucket, and then move it to the Redshift database. And after that, we'll query the results in the sales table. Now, whatever the values you are creating in the table, the same values needs to be in the data file. And I have taken up this sample data file from this link, which is docs.aws.amazon.com, Redshift, sample database creation. And here you can find a download file, ticketdb.zip file. This folder has basically multiple data files, sample data files, which you can actually use it to practice uploading the data on the Redshift cluster. So I have extracted one of the files from this folder, and then I have uploaded that file in the S3 bucket. Now we'll move into the S3 bucket. Let's look for the file that has been uploaded on the S3 bucket. So this is the bucket sample, and sales underscore tab.text is the file that I have uploaded. This has the entries, data entries that will be uploaded using a copy command onto the Redshift cluster. Now, after putting up the command for creating up the table, then we'll use a copy command. And copy command, we have to define the table name. The table name is sales, and we have to define the path from where the data would be copied over to the sales table in the Redshift. Now, path is the S3 bucket, and this is the Redshift bucket sample, and it has to look for the data inside the sales underscore tab.text file. Also, we have to define the role ARN that was created previously. And once it is done, then the third step is to query the results inside the sales table to check whether our data has been uploaded correctly on the table or not. Now what we'll do is we'll execute all these three syntax. It gives us the error because we have to connect it again to the database. Let's wait for it. Execute it. It again gives us the error. Let's look into the name of the bucket. It's Redshift bucket sample. So we have two T's mentioned here. Right. Let's connect with the database again and now execute it. So table sales created, and we got the error. The specified bucket does not exist. Redshift bucket sample. Let's view the bucket name. Redshift bucket sample. Let's copy that. Put it here. Connect to the window. Connect back to the database. Right, and now execute it. So table sales created. The data in the table has been copied from the S3 bucket to sales underscore tab.text to the Redshift, and then the query of the results. The results from the table has been queried.
Back in the 2000s, organizations were utterly dependent on purchase servers for their IT infrastructure. These servers not only came with limited functionality, but were also very expensive. The traditional way of storing and managing data was costly and complicated. It required a massive amount of hardware and complex software to run. All these issues were resolved using cloud computing. Rather than owning their computing infrastructures, organizations were able to scale up or scale down resources based on the requirement. Companies providing these computing services are called as cloud providers. According to C# Corner, the two popular cloud providers in the cloud market are Amazon AWS and Microsoft Azure. Now, let's take a step back and talk about a question. What should an individual learn in the year 2021? Amazon Web Services or Microsoft Azure? Though this question is tricky, we need to understand which cloud provider is the best option to choose. Now, let's take a brief look at both of these cloud providers. Amazon Web Services is an evolving cloud computing platform that offers various services such as compute power, storage, database, content delivery, and other resources to help business scale and grow. AWS services are provided based on a subscription basis. Similarly, Microsoft Azure provides a set of cloud services to design, create, and monitor applications on a network. Talking about the general features, Amazon Web Services was established in the year 2006. Today, it holds a market share of 31.7%, whereas Microsoft Azure was started in the year 2010 and now has a market share up to 16.8%. Amazon AWS is the world's most broadly adopted cloud platform. It offers up to 165 services globally. These services are used by millions of companies like Spotify, Netflix, Facebook, BBC, etc. Talking about Netflix, the company moved its IT operations to AWS in the year 2009. AWS was able to solve the company's scalability and data management issues. Azure offers several services in various categories, including artificial intelligence, analytics, containers, IoT, and many more. These services are used by many famous companies like Accenture, LinkedIn, Stack, eBay, and Samsung. Accenture chose Microsoft Azure to boost productivity and provide better security to its employees. The AWS pricing model is based on an hourly basis. With AWS, every individual pays only for the services that are required for his work. Every person only pays for the services he consumes. Azure pricing is charged on a per minute basis. The payment system is very simple and doesn't involve any long-term contracts. Microsoft Azure is free of upfront costs and cancellation fees, and only users pay for the resources they consume. With Azure and Amazon AWS, there are no additional costs or termination fees. Moving on to the next factor, let's talk about availability zones. Availability zones are isolated data centers with independent power and networking. These zones protect applications and files from data center failures. In total, AWS has nearly 77 availability zones within 24 geographic regions around the world. The company plans to establish 9 more AWS availability zones and 3 more AWS regions in Indonesia, Japan, and Spain. On the other hand, Microsoft Azure has many isolated availability zones. These zones are located within an Azure region, and they provide fast network connectivity. Azure has 44 availability zones around the world. The company is planning to launch 12 more zones. Now, after discussing the availability zones, let's talk about the services. The services that I am going to compare here come under the following domains: compute, storage, database, security, and finally networking. AWS and Azure provide a wide variety of services with low migration costs so that every individual can shift his or her current traditional infrastructure to cloud platform very easily. AWS EC2 is a suitable example of compute services. EC2 is a web service that aims to make life easier for developers by providing secure and resizable compute capacity in the cloud. It can be integrated to several other services like S3, IAM, CloudFormation, etc. Azure has a small service called Azure Virtual Machine Image. It helps the developers to develop and design identical virtual machines in the matter of minutes. Azure virtual machines are becoming more popular among IT infrastructures. These machines let an individual create and use virtual machines in the cloud as IaaS or infrastructure as a service. Virtual machines can be created using Azure Portal, Azure PowerShell, and ARM templates, Azure CLI or Client Software Development Kits. Next comes Amazon S3. It is the best example for storage service. Simple Storage Service is an object storage service designed to store and recover any information from anywhere via the internet. Amazon S3 facilitates storage through a web service interface. The service provides 99.9% durability and 99.9% availability of objects. It has the capacity of storing computer files up to 5 terabytes in size. On the other hand, Azure provides a similar service called Blob Storage Service. This service provides a large amount of storage and is highly scalable. It stores an object in the tiers depending on how often the data is being accessed. Blob storage supports widely used frameworks like Java, .NET, Python, and Node.js. It is the only cloud storage service in Microsoft Azure that offers a premium SSD-based object storage tier for low latency networks. AWS provides a secure cloud platform where every individual can manage and deploy their applications. Compared to the on-premises environment, AWS security offers a high level of data protection at a lower cost. For security purposes, IAM is a suitable service. AWS Identity and Access Management is a cloud service that controls and manages AWS resources securely. It has no upfront cost, also gives a facility to create and maintain services within a specific set of users on your AWS resources. In Microsoft Azure, Azure Active Directory, or in short also called as Azure AD, is a web service which provides MFA, multi-factor authentication features to users in order to protect their data from cyber attacks. Next is Amazon RDS. It is a web service designed to simplify the setup, operation, and scaling of a relational database. It is simple to set up, use and scale when required by users. It provides inexpensive and resizable capacity and automates several tasks such as hardware provisioning, database setup, patching, and backups. On the other side, the Azure SQL database automatically updates and backups data in order to focus on the development of applications. Not just that, it also manages database services and responds to client requirements. Client requirements such as scalability of a service, data backup, and high availability of database. Similarly, these cloud providers have plenty of services that help users build and deploy their applications effectively. Moving on to the next topic, let us focus on integrating AWS and Azure with open source tools. Now, we will explain how to build a pipeline using Jenkins along with one of the services of Amazon Web Services, that is the EC2. In this integration process, we have a sample Python application called as a Docker file. This Docker file will consist of a Python-based image. The Docker file builds a pipeline in order to create a Docker image upon pushing the code to the repository. Later, the new image is used to start a new AWS service on an ECS cluster. Now, let's have a look at how the integration of open source tools happen in Azure. In your Azure Cloud application, DevOps tools like Docker, Maven, and Jenkins can be integrated. In case you want to integrate the Jenkins pipeline, go to Project and create a subscription, followed by Jenkins. You can specify the required filters based on your requirement. Then choose your endpoint for Azure DevOps to communicate with Jenkins. So that was all about Amazon AWS and Microsoft Azure. Both AWS and Azure are honored to be on top of all other cloud providers. Both provide all necessary features like scalability, high availability, and security. But the moment I hear about choosing the best one, I have to say that all that depends upon the individual business needs. Both cloud providers are the certified ones that hold immense value in the current cloud service market.
Hey awesome viewers, come, let's leap into the world of cloud computing. Whether you're a tech enthusiast, a student, or a professional looking to upskill, the cloud technology offers endless opportunities for innovation and growth. Did you know that the global cloud computing market is projected to reach a staggering $832.1 billion by 2025? We all know that projects are essential for your career in cloud because they allow you to apply theoretical knowledge to real-world scenarios, gaining practical skills and experience. Through your projects, you can showcase your skills and depth of your knowledge. Projects are often the key to impress your employers. In this video, we are going to unveil the top cloud projects tailor-made for beginners, empowering you to kickstart your journey into the clouds with confidence. The first project in our list is website hosting. Here, you will build a website and host your website on the cloud. The steps are: sign up for a cloud hosting service like AWS, Google Cloud, or Azure. Upload your website files to the cloud storage provided by the hosting service. Then, configure DNS settings to point your domain name to the cloud server. After that, set up SSL TLS certificates for secure HTTPS connections. At last, monitor website performance and scalability using cloud-based analytics tools. Next, we have Expense Tracker. In this project, you have to develop an app to track expenses and manage finances using cloud storage for data synchronization. Now let's see the steps. Choose a cloud database service like Firebase or AWS DynamoDB for storing expense data. Now, design and develop the Expense Tracker app interface and functionality. Implement user authentication and authorization for secure access. Then, set up real-time data synchronization between devices using Cloud Database SDKs. After which, test the app thoroughly across platforms to ensure data integrity and usability. The third one is Virtual Classroom Platform. Here, you create an online learning platform with live lectures and interactive features and host it on the cloud. The steps to do this include: select a cloud-based video conferencing platform like Zoom or Microsoft Teams for hosting live lectures. Integrate additional features like chat, file sharing, and quizzes using cloud-based APIs or SDKs. Set up user authentication and access controls to ensure a secure learning environment. After which, you will have to customize a platform to match the branding and requirements of your educational institution. Train educators and students on using the virtual classroom tools effectively. Next, we have document collaboration platform with Microsoft. Here, you can build a document management and collaboration platform using Microsoft SharePoint on the cloud. Let's see the steps. Set up a SharePoint site on Microsoft 365 or SharePoint Online. Create document libraries for storing and organizing files with metadata and content types. Configure access controls and permissions to manage document security and sharing. Customize the platform with workflows, forms, and templates to streamline document management processes. Train users on how to use SharePoint for document collaboration and version control. The next is Health Tracker app with Google Fit API. In this project, you will develop a health tracking app that syncs data from fitness devices using the Google Fit API. The steps are: obtain API credentials and set up authentication for accessing the Google Fit API. Design the app interface and functionality for tracking user health metrics like activity, sleep, and heart rate. Integrate the Google Fit API into the app to retrieve and display user health data. Implement features for goal setting, progress tracking, and personalized recommendations based on health data. Test the app on different devices and ensure compliance with privacy and security regulations. The next is image recognition with Google Cloud Vision. In this project, you have to build an application that identifies objects and text in images using Google Cloud Vision API. Steps are: set up a Google Cloud Platform project and enable the Cloud Vision API. Obtain API credentials and configure authentication for accessing the API. Develop the application interface for uploading images and displaying recognition results. Integrate the Cloud Vision API into the application to analyze and process image data. Enhance the application with additional features like text translation or object detection based on recognition results. Seventh on the list is chat application with Firebase Firestore. Create a real-time chat application using Firebase Firestore for data storage and synchronization. The steps are: set up a Firebase project and enable Firestore as a database service. After that, design the chat application interface for sending and receiving messages in real time. Then, implement the user authentication and authorization to secure access to chat rooms. After which, integrate Firestore SDK into the application to store and sync chat data across devices. Now, test the application thoroughly to ensure reliability and real-time synchronization of messages. Next, we have continuous integration or continuous deployment pipeline with GitHub. Here, you have to set up a CI/CD pipeline for automating software development processes using GitHub Actions. For that, create a GitHub repository for your project and enable GitHub Actions. Define workflows in YAML format to automate tasks like testing, building, and deploying. Configure triggers to initiate workflows based on events such as code pushes or pull requests. Now, integrate third-party tools or services for additional tasks like code quality analysis or deployment to cloud platforms. After which, monitor workflow runs and troubleshoot any issues that arise during the CI/CD process. Next in our list is IoT data analytics with IoT Hub and Stream Analytics. Here, you have to collect and analyze data from IoT devices using Azure IoT Hub and Stream Analytics. Now, the steps for this project include: firstly, set up an Azure account and create an IoT Hub instance for managing IoT devices. Connect IoT devices to the IoT Hub and configure message routing for data ingestion. Now, create an Azure Stream Analytics job to process streaming data from IoT devices. Define queries and transformations to analyze and aggregate IoT data in real time. And then visualize the analyzed data using Azure services like Power BI or Azure Data Explorer for actionable insights. Last project on the list, we have Budget-Friendly Travel Planner. In this project, you are required to develop a travel planning application that helps users discover budget-friendly destinations and manage trip expenses. Now, the steps include: firstly, design the user interface of the travel planner application, allowing users to search for destinations and plan itineraries. Integrate APIs like Google Maps, Open Weather Map, and Skyscanner to provide travel information such as flight prices, weather forecasts, and accommodation options. Now, implement features for budget tracking, expense management, and itinerary customization based on user preferences. Test the application across different devices and platforms to ensure usability and performance. And at last, deploy the travel planner application to a cloud hosting platform for accessibility and scalability, and continue to iterate based on user feedback and usage metrics. So there you have it, top 10 cloud projects for beginners that can help you create a portfolio and land a job. We have explored a diverse range of projects that offer valuable insights into various aspects of cloud computing.
Welcome everyone. In today's rapidly evolving digital landscape, the importance of mastering cloud computing cannot be overstated. To thrive in modern IT environments, professionals must possess a robust set of crucial skills. These include managing and maintaining infrastructures that are increasingly complex and distributed, ensuring robust security measures to protect sensitive data against emerging threats, optimizing cost to make the most of IT investments, and mastering effective deployment strategies that ensure scalability and reliability across various platforms. At Simplilearn, we understand these skills form the backbone of successful cloud computing practices. With over a decade of leadership in cloud solutions, our company has been at the forefront of providing top-tier education and services to a wide range of clients. We are committed to making high-level cloud skills accessible to everyone, from aspiring IT professionals to seasoned experts. That's why our courses are designed not just to inform, but to transform your approach to cloud technology. Whether you are just starting out or looking to deepen your expertise, we provide the tools and training you need to navigate and excel with the cloud domain. With our guidance, you will not only keep pace with current technologies, but also stay ahead of the curve in this dynamic field. So let's start with the courses, and number one on our list is the postgraduate program in cloud computing, a comprehensive course designed in collaboration with Caltech CTME. Let's explore what makes this program a standout choice. This postgraduate program is your gateway to becoming a cloud expert. It's structured to take you through a deep dive into the world of cloud computing, covering crucial areas from basic concepts to advanced applications. And by joining this program, you are setting yourself up for success in a field that's at the forefront of technological advancement. It's designed to arm you with the skills needed to design, implement, and manage cloud solutions that are innovative and efficient. Moreover, graduates of this program find themselves well prepared for competitive roles worldwide, such as cloud architects, cloud project managers, or cloud service developers, working for top tech companies across the globe. Moreover, you will gain mastery or essential skills like managing cloud infrastructures, cloud security, data compliance, and disaster recovery planning. Completing this program earns you a postgraduate certificate from Caltech CTME, recognized globally and respected in the tech industry. And this course offers hands-on experience with leading tools such as AWS, Microsoft Azure, Google Cloud, Docker, and Kubernetes. You will tackle real-world projects that challenge you to apply your learning to build scalable, secure cloud architectures and manage extensive cloud deployments. If you're ready to start your journey in cloud computing with a top-rated program, visit the description box or pinned comment to enroll. So next on our list at number 2 is the Cloud Solutions Architect Master's Program. So let's delve into why this course is crucial for those aspiring to become cloud architects. This master's program is designed to turn you into a solutions architect capable of designing and implementing robust and scalable cloud solutions. This course ensures you gain comprehensive knowledge and skills. So choosing this program means selecting a path to mastery in cloud architecture. It's perfect for IT professionals who want to excel in creating high-performing cloud solutions that meet critical business needs. And this program opens doors to roles like Cloud Solutions Architect and Enterprise Architect, among others. Graduates often step into significant positions into multinational corporations and tech firms around the world, where they strategize and oversee cloud infrastructure deployments. And throughout this program, you will master skills in cloud deployment, migration, and infrastructure management. You will also learn about securing cloud environments and optimizing them for cost and performance. Completing this course will provide you with a holistic view of cloud architecture, backed by a master certification recognized in the industry. You will get hands-on experience with essential tools used by cloud architects, including AWS, Microsoft Azure, and Google Cloud platforms. The course also includes real-life projects that challenge you to solve problems and design solutions that are not only efficient, but also scalable and secure. If designing top-tier cloud solutions is your goal, then the Cloud Solutions Architect Master's Program is your stepping stone. Visit the description box or pinned comment to check out the course link. Moving on to the third course in our series, we have the AWS Cloud Architect Certification Training. This program is essential for those looking to specialize in Amazon Web Services, the leading cloud services platform. This certification course is tailored to develop your skills in designing and managing scalable, reliable applications on AWS. It's ideal for solutions architects, programmers, and anyone interested in building robust cloud solutions using AWS technology. Enrolling in this course will elevate your technical understanding and capabilities, preparing you to lead cloud initiatives using AWS powerful platform. You will gain in-depth knowledge of AWS architectural principles and services, learn to design and deploy scalable systems, and understand elasticity and scalability concepts. This course culminates in earning on AWS certification, adding significant value to your professional credentials. Practical, hands-on labs and project work will let you work directly with AWS technologies, ensuring you can apply what you learn immediately in any cloud environment. So are you ready to become an AWS cloud architect? Sign up for this course today to start your specialized training with the link mentioned in the description box and pinned comment. Next up at number 4 in our series is the Azure Cloud Architect Certification Training. This course is designed for those who aim to excel in designing and implementing Microsoft Azure solutions. Azure is one of the leading cloud platforms, and this training equips you to master its complex systems and services, preparing you to tackle real-world challenges with confidence. With this program, you will transform into a skilled cloud architect capable of managing Azure's extensive features and services. It's an ideal path for IT professionals looking to specialize in Azure for advancing their careers. The course covers a range of key areas including Azure administration, Azure networking, security, and identity management. You will also prepare for the Microsoft Certified Azure Architect Technologies exam, a highly respected credential in the industry. Moreover, hands-on labs and projects throughout the course ensure you gain practical experience with Azure. This training includes simulations and real-life scenarios to provide you with the skills needed to succeed in any Azure environment. So are you ready to harness the power of Microsoft Azure? Enroll in our Azure Cloud Certification training today with the link in the description box and pinned comment. Rounding out our top 5 cloud computing courses, at number 5 we have the Azure DevOps Solution Expert Masters Program. This advanced training is tailored for those who wish to blend cloud technology with DevOps practices using the Microsoft Azure platform. This Masters program is designed to empower IT professionals with the skills to implement DevOps practices effectively in Azure environments. It's perfect for those aiming to specialize in building, testing, and maintaining cloud solutions that are efficient and scalable. By integrating DevOps with cloud innovations, this course ensures you are adept at speeding up to IT operations and enhancing collaboration across teams. It's an essential skill set for increasing business agility and IT efficiency. The program covers a comprehensive range of topics, including continuous integration and delivery, CI/CD, infrastructure as a code, and monitoring and feedback mechanisms. Graduates are well prepared to lead DevOps initiatives and handle complex cloud infrastructures. Moreover, you will work with popular tools like Jenkins, Docker, Ansible, and Kubernetes alongside Azure-specific technologies. Real-world projects are integrated throughout the course to provide hands-on experience and insights into actual DevOps challenges. If you are ready to advance your career by mastering Azure and DevOps, enroll in our Azure DevOps Solution Expert Masters program today. Check out the link in the pinned comment and description box. So thank you for joining us as we explored these top 5 cloud computing courses. Each program is designed to not only meet but exceed the demands of today's digital landscape, preparing you for a future where cloud technology is ubiquitous. You can check out pinned comment and description box for respective course links.
Moving on to the top 10 cloud computing projects, we have divided this video into 3 parts. The first part is for beginners. Moving on to the first project for beginners, we have a cloud-based file storage. In this project, you will create a simple cloud-based file storage system similar to a Dropbox or a Google Drive. Users can upload, download, and manage files stored in the cloud. The part to create this project will start by choosing a cloud storage service. Select a cloud storage service provider like AWS S3, Google Cloud Storage, or Azure Blob Storage. The next step is creating an account. Sign up for an account with the chosen cloud provider if you don't already have one. The next step is to set up a bucket or a container. Create a storage bucket or container to store your files. The next step is to develop a web interface. Create a web-based interface for users to interact with your storage system. You can use HTML, CSS, and JavaScript for this. The next step is to implement file upload and download. Add functionality for users to upload and download files to or from their storage bucket using the cloud provider's SDK or API. The next step is user authentication. Implement user authentication to secure access to files. You can use services like Firebase authentication or build one of your own. The next step is testing and deployment. Test your file storage system locally, and once satisfied, deploy it to the cloud. Make it publicly accessible if needed. The key learning points of this project is You will learn the basics of cloud storage services, file uploading and downloading, and user authentication. Moving on to project number 2, we have a website hosting service. This project involves setting up an essential website on a cloud platform like AWS, Azure, or Google Cloud. You will deploy a static or dynamic website and make it accessible to users worldwide. Let's move on to the path to create this project. The first step is to select a cloud hosting service. Choose a cloud hosting platform like Amazon Web Services, Azure, or Google Cloud. The next step is to design your website. Create the content and design for your website. You can use HTML, CSS, and JavaScript for static websites or web frameworks for dynamic ones. Then register a domain name. Purchase a domain name from a domain registrar, for example GoDaddy, Namecheap, etc. The next step is to configure DNS. Configure the DNS setting to point to your cloud hosting server's IP address. The next step is to set up a virtual server. Create a virtual server instance on your chosen cloud platform, for example AWS EC2, Azure VM, and Google Compute Engine. The next step is to install web server software. Install and configure web server software like Apache on your virtual server. And the last step is to upload website files. Upload your website files to the server and then you are done with the project. The key learning points of this project: you will learn how to configure a web server, you will deploy web applications and manage domain names, and finally you will ensure high availability. The next project we have for beginners is a cloud-based calculator. Create a simple web-based calculator application and deploy it on a cloud platform like Heroku. Users can perform basic calculations using this calculator. Let's talk about the path to create this project. You will start by selecting a cloud platform. Choose a cloud platform like Heroku, AWS, or Azure for deployment. Then develop the calculator. Create a simple web-based calculator. You can use HTML, CSS, and JavaScript for this. Then set up a development environment. Install necessary development tools and libraries on your local machine. Then move ahead with version control. Use version control systems like Git to manage your project. Then create a cloud account. Sign up for an account with your chosen cloud platform. Then comes the deployment part. Deploy your calculator application to the cloud platform of your choice. For Heroku, this might involve pushing your code to a Git repository. And then comes the testing part. Ensure that the calculator functions correctly on the cloud server. Let's talk about the key learning points of this project. You will gain experience in setting up cloud server environments, deploying web applications, and understanding server-client interactions. Moving on to intermediate level projects. These projects are for people with decent knowledge of cloud computing basics. The first project we have in this category is an IoT data analytics project. Build a system that collects data from IoT devices, sensors, smart devices, etc. and stores it in cloud databases, for example AWS DynamoDB or Azure Cosmos database. Implement analytics to gain insights from the collected data. Let's talk about the path to create this project. The first step is IoT device setup. Set up IoT devices or sensors to collect data. Then choose a cloud database. Select a cloud database service, for example AWS Dynamo database, Azure Cosmos database for data storage. Then comes the data ingestion part. Write code to send data from IoT devices to the cloud database. Then comes data analytics. Implement data analytics tools or scripts to analyze the collected data. Then comes data visualization. Create visualizations to present insights from the data using tools like AWS QuickSight or data visualizations libraries. And then the last part is monitoring and scaling. Implement monitoring and scaling mechanisms to handle increased data volumes. So let's talk about the key learning points of this project. You will explore IoT data ingestion, cloud database management, data analytics, and of course data visualization. Moving on to the next project, we have a video streaming service. So you will create a video streaming service where users can upload and stream videos from the cloud. Implement features like video encoding, content delivery, and user authentication. Let's talk about the path to create this project. You will start by selecting cloud services. Choose cloud services for video storage, for example AWS S3. For encoding, you can choose AWS Elastic Transcoder, and for content delivery, you can choose AWS CloudFront. The next step is to design the application. Plan the architecture of your video streaming platform, including user interfaces for uploading and streaming. The next step is user authentication. Implement user authentication using services like AWS Cognito. Then comes the video uploading part. Allow users to upload videos to the cloud storage. And then comes the video encoding. Implement video encoding to create different quality versions of uploaded videos. Then comes the content delivery. Use a content delivery network or CDN to distribute videos efficiently to the users. And the last step is testing and scalability. Test video streaming and ensure it scales to handle concurrent users and varying network conditions. Let's talk about the key learning points for this project. You will learn about video processing, content delivery networks, and secure user access control. Moving on to the next project, we have cloud-based e-commerce website. Build an e-commerce platform hosted on cloud. Develop features like product listing, shopping carts, and secure payment processing. Let's talk about the path to create this project. You will start by selecting cloud platform. Choose a cloud platform, for example AWS or Azure, to host your e-commerce application. Then comes the e-commerce framework. Choose an e-commerce framework, for example WooCommerce or Shopify, or build a custom solution. Then comes the product listings part. Add product listings and descriptions with images. Then comes the shopping cart. Implement a shopping cart functionality for users to add products. Then comes the secure payment processing. Set up secure payment processing using payment gateways like Stripe or PayPal. Then comes the user authentication part. Implement user authentication for customer accounts. And finally, the testing and security. Thoroughly test your e-commerce website, ensuring it's secure and capable of handling transactions. What are the key points of this project? You will gain experience in building scalable web applications, handling online transactions securely, and managing customer data. Talking about advanced level cloud computing projects. For advanced level cloud computing projects, you should master cloud infrastructure and cloud services. The first advanced level project we have for today is machine learning with cloud. Develop a machine learning model and deploy it on a cloud server for scalable processing. This project involves working with large data sets and real-time data analysis. The first step is machine learning model. Develop a machine learning model using libraries like TensorFlow or scikit-learn. Then comes the data preparation part. Prepare and clean the data for training and testing. Then choose a cloud machine learning service. Select a cloud machine learning service, for example AWS SageMaker, Google AI Platform, and etc. Then comes the model deployment part. Deploy your machine learning model on the cloud platform. And finally, the scalability. Ensure the model can handle real-time predictions and scale as needed. Let's talk about the key learning points of this project. You will delve into machine learning, cloud-based data processing, and model deployment. The next project we have in this list is the cloud-based virtual desktop. Create a system that allows users to access virtualized desktop environments hosted on the cloud. This project focuses on remote desktop solutions. Talking about the path to create this project, you should start by selecting cloud service. Choose a cloud service for virtual desktop. For example, Amazon Workspace, Windows Virtual Desktop, or Azure. Then comes the configuration part. Configure virtual desktop instances with desired specifications. User management. Create and manage user accounts for accessing virtual desktops. Security. Implement security measures for data protection during remote desktop access. Then comes the access control part. Set up access control policies to restrict user permissions. And lastly, testing. Test the remote desktop access from different devices and locations. Talking about the key learning points of this project, you will learn about virtualization, remote desktop technologies, and user management in a cloud-based context. Moving on to the third advanced level cloud project, we have a cloud gaming service. Build a cloud-based gaming service similar to Google Stadia. This project involves GPU virtualization, low latency streaming, and multiplayer game server management. Talking about the path to create this project, you should start by selecting cloud infrastructure. Choose a cloud infrastructure. You can either choose AWS or Azure for hosting game servers. Then comes the game server setup. Set up game servers for hosting games. Then comes the low latency streaming. Implement low latency streaming technologies for gameplay. Then comes the multiplayer support. Add multiplayer support for users to play together. Then comes the user management. Create user accounts and manage players' profiles. And finally comes load balancing. Implement load balancing to handle increased player loads. Talking about the key learning points of this project, you will explore cloud-based gaming infrastructure, server management, and real-time multiplayer networking. Moving on to the last cloud computing project, we have a healthcare data management system. Develop a cloud-based system for storing and managing healthcare-related data such as patient records. Ensure compliance with healthcare industry standards, for example, HIPAA. Talking about the path to create this project, you should start by ensuring compliance with healthcare industry standards. HIPAA compliance. Understand and adhere to HIPAA compliance regulations. Cloud platform selection. Choose a HIPAA compliant cloud platform, for example, AWS Healthcare APIs and Azure for Healthcare. Then comes the data storage part. Create a secure cloud-based data storage system for healthcare records. Then comes the access control. Implement strict access controls and encryption for data security. Then comes the audit trials. Maintain audit trials for data access and modifications. And then at last comes the user training. Ensure staff are trained on HIPAA compliance and data handling protocols. Talking about the key learning points of this project, you will gain expertise in cloud security, data privacy, and compliance while addressing real-world healthcare data challenges. These projects provide a progressive learning path allowing individuals to start with basic cloud concepts and gradually advance to more complex and impactful cloud computing applications. Each project offers valuable experience and skills that can be applied to real-life scenarios and career development in the cloud computing field.
Hey there, future cloud experts. Are you preparing for your GCP interview and feeling a bit nervous about those tough questions? Don't worry, because in this video from Simplilearn, we will be covering some top GCP questions that you might face in your interview. But first, let's see what is the role of a GCP engineer. So, a GCP or Google Cloud Platform engineer is responsible for designing, implementing, and managing cloud-based solutions using GCP services and infrastructure. They use cloud computing, networking, and security to build scalable and reliable systems to meet specific business needs. The interview panel will expect you to be familiar with topics like networking, security, automation, and troubleshooting, along with effective communication. Now, let's start with the first question. What is cloud computing? In simple terms, it's like outsourcing your computer needs to a remote internet-connected service provider. So, you can explain in this way. Cloud computing is a way of delivering computing services like servers, storage, databases, and software over the internet. Instead of keeping all these resources on your personal computer or local server, you access them remotely through the internet. It's like renting computing power and storage space on a massive shared network, which offers benefits like scalability, flexibility, and cost-effectiveness. We can also talk about different types of cloud computing like private, public, hybrid, and multi. Now, let's move on to the next question. What do you know about Google Cloud Platform? Here, it's important to demonstrate your understanding of GCP's key components and its significance. GCP or Google Cloud Platform is a collection of cloud computing services provided by Google. It offers a wide range of services including computing, storage, networking, databases, machine learning, and more, all hosted on Google's infrastructure. GCP allows businesses to build, deploy, and scale applications and services in a flexible and cost-effective manner. It is widely used by organizations of all sizes across various industries for hosting websites, running applications, analyzing data, and developing innovative solutions. Now, list few benefits and drawbacks of GCP. In this answer, make sure you provide a balance between the benefits and drawbacks that you mention. Here's how you can approach. Some of the benefits are high storage efficiency, stability, easy integration, confidential computing, security, and compute globally as per requirement. The drawbacks include complexity, support limitations, data transfer costs, and geographic restrictions. Now, let's see the next question. What are the main layers in cloud computing? You can start by naming the layers first and then briefly describe them. So the main layers of cloud computing are infrastructure as a service, platform as a service, and software as a service. So in infrastructure as a service, this layer provides virtualized computing resources over the internet, including virtual machines, storage, and networking infrastructure. Examples include AWS, Microsoft Azure, Google Compute Engine, etc. Now, platform as a service offers a platform allowing developers to build, deploy, and manage applications without worrying about underlying infrastructure. It includes tools and services like databases, development frameworks, and application hosting environments. The examples are Google App Engine, Adobe Commerce, etc. Now comes software as a service, which delivers software applications over the internet on a subscription basis. So users access these applications through a web browser without needing to install or maintain any software locally. Examples include email services, CRM systems, and productivity suites like Google Workspace or Microsoft 365. Now, briefly explain the working of GCP. When asked to explain the working of GCP briefly in an interview, focus on its core principles. So GCP operates by providing a range of cloud computing services over the internet, like storage, computing power, networking, etc. It functions by hosting these services in data centers worldwide and allowing users to access and manage them remotely via an internet connection. You can also mention that GCP's infrastructure is designed for scalability, reliability, and security, enabling businesses to deploy, manage, and scale applications and services efficiently. Additionally, GCP offers various tools and resources for developers, data scientists, and IT professionals to build, deploy, and manage their applications seamlessly. The next question is, what are the services offered by GCP? As already mentioned in some answers, the services include compute, storage, networking, and databases. You can also highlight specialized services like machine learning, big data analytics, and IoT, Internet of Things solution. Finally, emphasize GCP's unique features, such as its global network infrastructure and advanced security capabilities. So let's move on to the next question. What is a bucket in cloud storage? So bucket in cloud storage refers to a container or folder-like structure used to store data within a cloud storage service, such as Google Cloud Storage. Think of it as a virtual storage container where you can store files, objects, or data. Buckets are typically used to organize and manage data within a cloud storage environment. They allow users to store and retrieve data efficiently, and they often come with features for managing access permissions, versioning, and lifecycle policies. Overall, buckets play a fundamental role in organizing and managing data within cloud storage system. Now let's see what's the next question. How can information in cloud be safeguarded? So start by highlighting encryption methods to protect data, both in transit and at rest. Discuss robust access control measures like Identity and Access Management (IAM) to ensure only authorized users can access sensitive information. Mention regular security audits and compliance checks to maintain a secure environment. Emphasize the importance of choosing reputable cloud service providers with strong security protocols in place. Finally, you can mention the significance of user education and awareness to prevent data breaches due to human error. Now, what do you know about GKE? So explain that GKE stands for Google Kubernetes Engine. It is a managed service by Google Cloud Platform for deploying, managing, and scaling containerized applications using Kubernetes. Talk about its benefits such as automatic scaling, seamless integration with other GCP services, and simplified container orchestration, while also highlight your understanding of its role in modern cloud-native application development and deployment. The next question they can ask is, what is the pricing model of GCP? So when answering the question about the pricing model, you can explain that GCP follows a pay-as-you-go model, where users are charged only for the resources they consume. Additionally, GCP offers various pricing options, including per-minute billing, sustained use discounts, and committed use discounts, allowing users to optimize costs based on their usage patterns and commitments. It's important to highlight GCP's transparent pricing structure and flexibility in accommodating diverse business needs. Now, what is Compute Engine? You can say that Compute Engine is a core infrastructure as a service offering within Google Cloud Platform. It provides users with virtual machine instances running on Google's infrastructure, allowing them to deploy and manage scalable computing resources in the cloud. So Compute Engine offers flexibility, reliability, and high performance for various workloads, ranging from small projects to large-scale applications. Additionally, you can also mention its integration with other GCP services and the ability to customize instances based on specific requirements. So let's move on to the next question. What is the default bucket location if we do not specify a location constraint? So when asked about the default bucket location in Google Cloud Storage, if no location constraint is specified, you can respond by stating that the default location is a United States multi-region. This means that if you create a bucket without specifying a location, it will be stored in a multi-region location within the United States, ensuring redundancy and reliability across multiple data centers in that region. Now, what libraries and tools are provided by GCP? When addressing this question about libraries and tools, you can mention a variety of libraries and tools available within Google Cloud Platform. Some notable libraries include Google Cloud Client libraries for various programming languages such as Python, Java, and Go, which provide convenient access to GCP services. Additionally, there are specialized libraries like TensorFlow for machine learning tasks and Apache Beam for data processing. Regarding tools, emphasize widely used ones like Google Cloud Storage for scalable object storage, BigQuery for analytics, Cloud Functions for serverless computing, and Kubernetes Engine for container orchestration. By highlighting these libraries and tools, you demonstrate familiarity with GCP's robust ecosystem, showcasing your readiness to leverage them effectively in your projects or tasks. Now, what is a project in GCP and how to create one? So in Google Cloud Platform, a project is a container for resources such as virtual machines, storage buckets, databases, and more, allowing you to organize and manage your cloud services effectively. So to create a program in GCP, you typically start by logging into the GCP console. Then navigate to the IAM and admin section and select projects. From there, you can click on Create Project, provide a name and optional description, and configure any necessary settings. Once created, you can begin provisioning and managing resources within your GCP projects to support your specific use case or application. Now, let's move on to the next question, which is, what is Google Cloud SDK? You can say that Google Cloud SDK is like a toolbox provided by Google. It helps developers manage and interact with Google Cloud Platform services using commands in the computer's terminal or command prompt. It's handy for tasks like deploying apps, managing resources, and assessing cloud services. Now, what are objects in GCP? So start by explaining that objects in Google Cloud Platform typically refer to data entities stored in cloud storage services like Google Cloud Storage. So emphasize that these objects can be anything from files to multimedia content, and they are stored with unique identifiers within buckets, which are analogous to folders. Also highlight the versatility of objects as they can be accessed, manipulated, and shared across various GCP services, facilitating seamless data management and integration within cloud environments. So, what are the various methods for authentication of GCE API? You can mention several methods, after which you can start explaining each, including service account authentication. So this involves creating and using service accounts in Google Cloud Platform to authenticate API requests. So service accounts are associated with projects and can be granted specific permissions. 2.0 authentication. 2.0 is a standard protocol used for authorization. GCE API supports 2.0 for authentication, enabling users to obtain access tokens and authentication API requests. The next one is API key authentication. Now, API keys are unique identifiers that developers can generate to authenticate access to GCE API endpoints. This method is often used for accessing public data or resources that don't require user-specific permissions. Identity-aware proxy authentication. So Google Cloud's Identity-Aware Proxy allows administrators to control access to GCE API endpoints based on user identity and context. Users authenticate through Google identities, and IAP verifies these accesses before allowing API requests. Moving on to the next question. What is load balancing? So load balancing in GCP involves distributing incoming network traffic across multiple servers to ensure optimal resource utilization, minimize downtime, and maximize performance. Emphasize that GCP's load balancing services automatically adjust to varying levels of traffic, helping to maintain stability and reliability for application and services hosted on GCP infrastructure. You can also mention that GCP offers various load balancing options, including HTTPS load balancing, TCP SSL proxy load balancing, and network load balancing, each tailored to specific use cases and requirements. Now coming to the next question, what is Cloud Pub Sub? So Cloud Pub Sub is a fully managed messaging service offered by Google Cloud Platform. You can describe its functionality as a scalable and reliable system for real-time message ingestion and delivery between applications and services. Highlight its key features such as asynchronous communication, durable storage, and support for event-driven architecture. You can emphasize its role in enabling decoupled, scalable, and resilient cloud-native applications. Finally, mention its benefits in terms of flexibility, scalability, and ease of integration with other GCP services. Now coming to our last question, what is Google BigQuery? So Google BigQuery is a fully managed serverless data warehouse solution provided by Google Cloud Platform. It allows users to run SQL-like queries against large data sets quickly and efficiently. Emphasize its scalability, real-time analytics capabilities, and seamless integration with other Google Cloud services. And there you are, with top 20 GCP interview questions that you can definitely expect in your interview. We have given an overview of each of the topics, but make sure while you answer the questions during an interview, try explaining the concepts in your own words so that you can portray your communication skills. Also, mention real-time examples according to your experience. So I hope you found this video informative.
So that's a wrap on our full course. If you have any doubts or queries, you can ask them in the comment section below. Our team of experts will reply you as soon as possible. Thank you and keep learning with SimpliLearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the SimplilearN YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.